Ladies and gentlemen, it's a privilege to invite you all to this session. When I'm saying fantastic, yes, this technology is actually gaining a lot of traction in the country, and we've been promoting 3D printing technology and 3D visualization for the last 8 years. It's a privilege and an honor to invite some of the eminent personalities who have done some great work in this technology, and somebody who's also been an industrialist and working and promoting various different aspects of business to also have joined our platform today. And Let me give you a brief of 3D Graphy. 3D Graphy is a consortium that we started in the year 2018. And then it was been inaugurated by the Minister Shri Subhas Desai, an industrial minister. And the conscious effort for us to have formulated 3D Graphy was to build a consortium where 3D technology can be well understood for the end user to benefit from this particular in this particular space. Though this technology was never new in European and other Western countries, been there for almost last 3 decades. But in India, the inception started maybe 3 or 4 years or 5 years back. And we were privileged to build this consortium to also connect with researchers and scientists and also 3D technology companies and also end users coming from various different backgrounds, may it be medical from doctors and surgeons to material scientists to biotechnologists, bioengineers, material scientists, and also companies who are dealing in software and simulation. So it was a great time to introduce 3D Graphy, and then we built this consortium. And with time, we've almost conducted 40 events in the last 8 years. And today we are on the conducting our 41st event, but very specific to automotive industry. Though this technology has a great potential in various sectors. So today I have the privilege to invite one of the senior respondents and veterans in the industry from Coimbatore, Dr. S. Chandrasekhar, who is also our chief guest and guest of honor. Somebody who have actively been engaged in the corporate world and in the engineering and the manufacturing space. Uh, uh, Now he's the director with Roots Group of Companies and also a council in the Coimbatore Chambers of Commerce. So may I invite him, sir, and please your note of expression on the subject, and we'll then carry forward to the other sessions and for the day. Thank you so much.
Um, Gentlemen, good morning to you all. And first of all, I'd like to thank my friend Dr. Shibu John, the founder of 3D Printing World, 3D Graphy, AI World, and a host of other organizations related to additive manufacturing to invite me to attend this August event. My heartfelt greetings to Dr. Shibu John, organizer the event, Dr. Naga Hanumaya, Director, Central Manufacturing Technology Institute, Bengaluru, the keynote speaker for the day, respected members and associate corporate members of the 3D Graphy Advisory Board, and all the distinguished speakers for today's events. I wish to humbly convey my gratitude to Dr. Shibu John who have chosen to bestow me with the guest of honor today in front of this big distinguished gathering. Thank you, sir. Additive manufacturing, also known as 3D printing, is a transformative approach to industrial production that enables the creation of lighter, stronger parts and systems for multi-various applications. It is yet another technological advancement made possible by the transition from analog to digital processes. While the terms 3D printing and rapid prototyping are casually interchangeably used to discuss additive manufacturing, each process is actually a subset of additive manufacturing. While additive manufacturing seems to be new to many, it has actually been around for several decades across the Western world. In right applications, additive manufacturing delivers a perfect trifecta of improved performance, complex geometries, and simplified fabrication. As a result, opportunities abound for those who actively embrace additive manufacturing. The challenges which are there for additive manufacturing are the high cost of equipment, material, and costly material due to the dependence on import, lack of formal industry standards, lack of skilled manpower, and uncertainty in the regulatory and legal framework are all impediments in the additive manufacturing process. This being the going, Sri Ashwini Vaishnav, Union Minister for Electronics, Information Technology, Communication and Railways, and Sri Rajiv Chandrasekhar, Minister of State for Electronics, Information Technology and Skill Development and Entrepreneurship, have released a national strategy on additive manufacturing on the 24th of February 2022. As per this national strategy for additive manufacturing, by 2025, India will aim to achieve certain targets such as 50 India-specific technologies for material measurement software, 100 new startups for additive manufacturing, about 500 new products to cater to the next generation digital manufacturing and mitigate immediate disabilities of local industries. The national strategy on additive manufacturing will aim to create a conducive ecosystem for design, development, deployment, and to overcome technical and economic barriers for global additive manufacturing leaders to set up their operations with supporting ancillaries in India. This mission is to ensure creation of a sustainable ecosystem for the AM industry to compete globally, encourage additive manufacturing transformation, and driving capabilities in the country for developing core competencies and position India as a global innovation and research hub for additive manufacturing. MITI aims to increase India's share in global additive manufacturing to 5% by 2025, with hopes that are likely to add about $1 billion to GDP by the time. At this point of time, about 100,000 people would be gaining direct employment in this industry. It aims to ensure manufacturing manufactured end-user functional components for domestic and export markets and promote creation of Indian IPRs and patents. An apex body with subject matter experts and leaders from local and global industries have also been planned to be established to lead the mission. Additive manufacturing has immense potential to revolutionize India's manufacturing industrial production landscape through digital processes, communication, imaging, architecture, and engineering. With this scenario in the background, there could not have been a better time to conduct this exclusive event titled 3D Graphy Engineering Workshop 2022, 3D Printing and 3D Visualization for Automotive Industry, and about the topic 3D Technology. This board game changed automotive. Wish all the specialists and the resource persons, the speakers, and all the participants who virtually attend this program a great mission and lots of takeaways at the end of this session. I thank you once again, Dr. Shibu John, and everybody here to have a wonderful session. Thank you once again for having bestowed me the guest of honor. God bless you all. Thank you, sir.
Thank you, sir. Thank you for a very eloquent, detailed speech, and also for addressing what the technology would need to shape up to be in terms of what is expected. And somebody who has been in the helm of the industry and also understanding what the industry requires, being the key respondent of Coimbatore Chamber of Commerce. Uh, uh, so, just a question: how actively do you feel that the industry, as in the Chamber of Commerce, should actually see and devise a means and method if this something like a customized manufacturing solution can gain that kind of attraction, sir? Your thoughts, and then we will go to Sir Dr. Naga Humai, and then he will also share his inputs. Yeah, please.
Thank you, Doctor. And it is not just Chamber of Commerce and Industries and Codicea. You've heard about it's got about 23,000 members. The Codicea is the largest small-scale manufacturing association in the country. And this definitely, I would request for a program of similar kind to be held in the premises of Codicea and to Chamber. And probably a lot of people have some kind of a basic knowledge about this stuff and the 3D printing technology. A few companies have already started, but not in a scalable size. They have gone in for either prototyping or having 3D printing machines for their own local development. But this is a good opportunity, and Chamber and the Codicea and the Coimbatore industry would definitely welcome this as an opportunity to step up, because they are all into conventional engineering industry now. They are either have to step into this or get vanished. So it's an opportunity for them to think very far behind this and step onto it, and this shall be a wonderful opportunity. I believe a lot of people in Coimbatore will be definitely attending to this program also. I have forwarded this to almost all the universities in Coimbatore engineering colleges. I think there will be a lot of takeaway from them. Thank you, Shibu.
Thank you so much, sir, for your inputs, and I'm very encouraged. I mean, industry also needs to come forward to embrace technologies like these. And thank you so much, sir, for your presence. Now, may I now like to invite Dr. Naga Hanumai, who is the director with the Center for Manufacturing Technology Institute. Sir actually has been in the epitome of research and his bit of research, and he's also a PhD in additive manufacturing. Somebody who has also started his journey long back, almost a decade and more, and now seated at a very important chair to see that how this technology can be democratized in terms of the opportunity, and also indigenously manufactured the 3D printer here in the name of Sukshan 3D. Thank you so much, sir. Your words of thoughts on the subject, sir, and also the platform. Thank you so much.
Thank you, Dr. Shibu, and good morning to all the chief guest, Dr. Chandrasekhar, and my fellow speakers and the audience who joined in this virtual platform. As basically what I try to cover in my presentation is, basically I'm a tool engineer. So keeping that as a background, I'll try to see how this additive manufacturing would help for the tool engineer. That is the kind of broader perspective. But at the same time, yes, now I'm more into technology management, so I will give you my perspective, particularly if I look at additive manufacturing as an alternative manufacturing process, which could be used in the typical shop floor. I think that is the background, whatever I speak. In that view, I'll try to share my thoughts. Basically, myself, Naga Anumaya, I'm currently director at Central Manufacturing Technology Institute. I'm here almost 3+ years. July 2018, I took over here. Prior to that, 2 decades, I worked for CSIR, CMER, Central Mechanical Engineering Research Institute, is one of the CSIR lab at Durgapur. By training, I'm basically mechanical engineer, then tool engineer. After my tool engineering specialization at the master's level, then I spent a few years in the industry as a tool designer. In my career, of course, I've designed about 23 dies and molds for an industrial components. Then I joined CSIR in 98, and I was there up to 2018. Primarily, I worked on 3 different areas. So one is on additive manufacturing. That was part of my PhD, and as well as the group we were working on how to use the 3D printing, or that time we used to call rapid prototyping, rapid tooling, particularly focusing on rapid tooling, how to use the layered manufacturing, additive manufacturing processes to develop the toolings for net shape or near net shape manufacturing processes. I think I will show some of my work I did there. And then while in CMERI also, I worked on like how to use this selective laser sintering process to sintered micro nanoscale powders with an objective of creating a micro components by selective laser sintering, layer by layer. I think with my PhD student, we succeeded to sinter about 22 layers of for some specific dimensions. We built a micro parts of 5 millimeter, 5 millimeter, having a feature size about 500 microns. That was my direct research experience, and as a part of a PhD, I was primarily focused on the manufacturability evaluation of dies and molds using this rapid prototype or rapid tooling process. That was primarily my research topic. Once we did that, then I moved to CMTI. In CMTI, you may be aware, CMTI is the number one or the first to introduce the metal-based additive manufacturing. We started with installing this one EOS Germany machine. particularly for we call it the DMLS. As of now, about CMT facilitated to industries to develop about about 300, 280 something is the precise value, products for various customers. And in addition, we also facilitated to the industry to make some of the molds and dies which are being used by both researchers as well as the industries for first batch of components production, particularly in the product development process. And then we also installed another machine that is a metal-based additive. This is called DED or DMD machine. That machine also we with that process still we are offering a services. We are offering a services primarily for the remanufacturing of component, less of prototyping, more of remanufacturing. I think some of my slides I have will show you what my colleagues did here at particularly remanufacturing and reconditioning of one-off items, components, one-off components. Then CMT being a machine tool lab, because we are since 1962, it is our Diamond Jubilee year this year. We are into machines and manufacturing processes. Since inception, CMT has developed about 500 solutions to industry, primarily in the machine tool. Machine tool is not necessarily milling, turning machine, but special purpose machines too. And then we also started on building a 3D additive manufacturing machines. First, our focus was on micro nanoscale manufacturing. Still, I think there's not much development happened. Again, what I said back in CM era, I started on metal-based selective laser sintering process for micro application. Here, my colleague started on 3D printing of micro parts using photopolymer. Now we built successfully the machine called Sukshma 3D. It works on microstructure. I will brief you what we did in that machine, which is capable of building a photopolymer components having a geometric features like as small as about 500 microns, that means 0.5 millimeter. No, but the smallest feature which you can build with this machine is, I can give you assurance comfortably you can use this machine to build 10 micron features. I think a component like micro needles and all we built. Then we also try to, because smart manufacturing is another vertical where our colleagues are associated converting legacy machine into a smart machine, then building a smart machine. In 3D printing also we made FDM machine as a smart FDM machine. The second is recently, this is still to demonstrate to the industry. The consortium of 12 researchers, we joined together and we built a machine that we called Smart Foundry, where complete the hardware system, software system, starting from your CAD data to part data. You just import the part data, then you do the tool design, then methoding, simulations, solidification, all these simulations you can do. Then hardware for 3D printing, mold making, mold melting, pouring, and which are integrated with the sensor systems. And then we also developed a smart foundry platform, so which could capture the data and then share this data through cloud to the server wherever you want and get it downloaded for a specific study, which analytics wanted to do. Including Foundry engine, analytics engine was developed by our kind of consortium of 12 research teams across 10 institutes. I think I have a few slides. Thank you.
Doctor, I think it was a body of work that you have been able to do from where you started, and good enough a time to develop and now come with an indigenous machine by the name of Sukshma 3D. I'm sure it will be very interesting with your keynote session where the audience and the participants will also get to learn and understand the various applications and what the machine can offer. So thank you so much, sir, for your presence and also for your active participation. CMTI is also our 3D Graphy associate corporate member and also an industry partner for this particular conference and various other conferences that we would want to work very closely. And because I think imparting of knowledge through platforms like these is always a conscious effort for each sector, and that's the reason we have almost 13 different sectors to address. That is including medical and healthcare. You have dental and maxillofacial. You have orthotics and prosthetics. Then also bioprinting. That's to do with tissue engineering. Automotive that we're doing right now. So I think the idea is to come as a team and a consortium to work together in the larger interest to see that how the industries can benefit from technologies that is into the offerings. So let me now introduce you all to 3D Graphy associate corporate members who have been actively working with us in this consortium, starting with I have Mr. Sushil Mane from Altair, who is a technical specialist. They are in the area of simulation software. Sushil, a few words, and then we will go to the next respondent, and then we will also we are waiting for launching our 3D Graphy news online portal, which is also was in the waiting for almost last 8 years. The conscious effort is since that we have no dearth of information and content today, and since we have built this consortium, we are looking forward to using this platform to also see that how we can propagate the technology and also share insights with case studies and research and various new developments happening with innovation, and spotlight being one of the key aspect also, wherein new innovators coming into this space need to be highlighted, and we will want to do that on an ongoing basis. We've actually been able to activate almost 56,000 plus respondents in this activity. It was an exercise for the last 1 year we've been doing it, and this is also through a AI tool based exercise. Working on that particular project. So let me first introduce you to Sushil, and then we will introduce the other respondents, please. Thank you.
Sure. Hello, and a very good morning to you all. Thanks, Dr. Shibu, for inviting us to this conference. It is really a pleasure to be part of a very wonderful topic, and that is on 3D printing and how it is changing the world, right? Not just the key market verticals that initially it started with, which is aerospace, but now it is moving to various other market segments, right? A very good morning to Dr. Chandrasekhar, Dr. Naga, and all my fellow speakers on this panel, and also to the audience. As Dr. Shibu mentioned, I'm being part of the Altair, let's say, software vendor here. We have been in this industry for close to 35 years now. We are an Altair American-based company, and here in India, it is almost like 25 years that Altair has been promoting this technology. So we have been part of the simulation world, right? So it is basically how we are trying to leverage simulation for all the design and development of various mechanical systems. And we definitely feel that simulation plays a huge part in driving the design. And that's why our coining of the word simulation-driven design has been leveraged across various industries. And various companies are using this technology to basically drive their design and therefore try to lightweight the design and also improve the performance. So we have been working with various companies across different segments. And as far as this technology on 3D printing is concerned, there has been a lot of case studies that we have really worked with of having to design and develop using the simulation technology, and not only that, but look at how you can simulate manufacturing process and also see whether you can improve the design so that there are minimum problems in the design going forward, right? So this whole process of not only conceptualizing the design in this whole concept development tool that we have called as Inspire, but also to look at how you can simulate the manufacturing process and understand whether there are any problems that may occur while you're manufacturing that particular component. So this is basically a platform that is very usable. Designers can quickly learn the technology and start implementing this technology for various complex systems that they want to design and develop. So that is what we are trying to promote across the industry, and we have been very successful in implementing this technology across the entire industry. So look forward to a wide discussion over here. As far as my topic of discussion later in the evening, I'll be basically covering some of those case studies that we have implemented across the automotive industry, and how it has benefited some of these companies. So with that introduction, I close, Dr. Shivu. Thank
Thank
you.
you so much, Sushil. I think there is much to learn subsequently in your session. I'm sure it will be very engaging, and to also know some of the case studies. I think today's session would be much will be proliferated through various case studies from various experts coming on a platform like us. So I think it's a great opportunity. Thank you so much, Sushil. Deshpande, who is the country manager with Intech Additive Solutions. Intech is a company dealing in metal 3D printers, and they have been working really in the forefront of now proudly being one of the indigenous manufacturers in the space. So Ashwin, thank you so much for your participation. They are also one of our associate corporate members, ensuring that how we can work together to see that the technology gets a larger proliferation in the country. Ashwin, please, you can start.
Yeah. Very good morning. Namaskar to everyone. And it is thanks to Shibu John and his organization for inviting us. Just in brief, Intech is the India's first OEM to design, manufacture, and launch laser bed powder fusion machines for the metal 3D printers. And we actually started way back in 2012. Again, we were so there are many firsts in our company, and so in 2012 we were the first metal 3D printer service bureau in India, recognized by the Wohlers Associates, one of the leading publications in the world of additive manufacturing. From there our journey started, and subsequently we launched our machines, we developed our own softwares. And in 2021, our first, while we announced our machines in 2020, our first sales started happening in the calendar year 2021. To the till date, we have around 8 installations, 6 of them in India and a couple of them in Europe. And so proud moment for Intech to bring India into the global map of additive manufacturing, especially metal. And so as an organization, we have probably the deepest and the broadest experience of additive manufacturing, from design for additive manufacturing to actual the machinery and the software. It was also nice to see our we got featured in the National Additive Manufacturing Forum released by the Ministry of the Government of India, and along with CMTI, our machines were featured on the page, the cover page. So nice to see ourselves over there reflected. And in today's afternoon session, I will be introducing our technology and what is something unique that we do in terms of our, let's say, our softwares, pretty unique in some of the areas, and how the industry has adopted our technology, and so forth. I think with that brief introduction, I can, see you later in the afternoon.
Sanjeev, he's the business head with Lodestar. So they've also been, in 3D printing technology for almost a decade now. The clear intention being to see that how new technologies can be introduced in the Indian market. So they are also resellers for G Additive and various other machines which are in dealing into polyether ketone like PEEK. PEEK happens to be a very a material which is probably in match or even better with titanium. I think a lot of talk though, but yeah, so a great opportunity, Sanjeev, for us to also have an active participation with you as a member on our platform. Please, just an introduction and then.
Yeah, good morning all. First of all, I would like to thank Mr. Shibu for getting an opportunity to share our views, and chief guest and other speakers. So Lodestar is like 10 years old company. We have been partnered with many OEMs like GE, E Plus and all. So as Sir said, mainly we are concentrating on industry. We are supporting industries for giving a 360-degree ecosystem on 3D printing and scanning technologies. Uh, so just a small brief, that's all. So maybe we'll be discussing on the second session, sir. So just for concerning the timing. Thank you for giving us an opportunity. Thank you.
Thank you, Sanjeev. Thanks for your time and thanks for your introduction. May I now introduce Kuntesh? Kuntesh is again a key respondent from Gujarat. So we have a diverse, respondents from various states. They've also the company is by the name STPL, who's actually actively been in the machining business for many years, almost 3 decades, and now they've also introduced STPL, which is an SLA and FDM machine both with a bed size of 1,000 by 800. So that's a huge scale. In terms of the offerings, they are also offering these solutions in automotive, in medical, likewise. So Kuntesh, please introduce yourself. Thank you so much.
Yeah, good morning all. Am I audible?
Yeah, you're audible. Please.
Yeah, so good morning all, and thank you, 3D Graphy and Sibu John, for inviting us to represent our company as well as what features in our products we are manufacturing. So in later sessions we'll discuss about more in product terms and as well as the opportunity in automotives in the field of plastic 3D printing manufacturing. And also, if I brief about STPL, Surgeon Technology Private Limited is a 30-year-old company. We started our company with the diamond technology solutions, and today we are the one of the leading company in the diamond technology space. And also, we have a like second group company, Surgeon and Medical Technology, where we are manufacturing cardiovascular stents. And our third group of companies, Surgeon Life Sciences, where we are manufacturing herbal medicines. So it's a very diversified portfolio we have, and we are very one of the oldest company in the different field of like manufacturing of the technology as well as the medical field. And we started our 3D printing journey in 2015 as a service bureau. Then slowly, gradually, we noticed some of the key problems in the industry in terms of like manufacturing of the machines. And then we started our R&D for the making of machines, and we started manufacturing of machines from like FDM SLA, and very soon we are having all the technology under the one roof of STPL. So it's our pleasure to provide us cutting edge solution to the industry. So thank you very much, all of you, and we'll see the presentation in later stage. Thank you.
Thank you so much, Kuntesh, for your inputs and also to give a broad an introduction of your company and what you do. Now, let me take the opportunity to invite Dr. S. Chandrasekhar sir to be on the virtual stage. We will actually make the formal launch of the 3D Graphy News as a platform. Doctor, please.
You hear me? Can you hear me, sir?
Yes, we can hear you, sir. Please.
Yeah. It's an honor to be called up again to address this August gathering, and so I'll be honored to release this software. And please go ahead, Dr. Shibu.
Yeah. So this is, ladies and gentlemen, this is our platform. So thank you so much, sir, for acknowledging the same. This is the platform called 3D Graphy News, and we will be launching it actively from Monday, that is coming week. The content is being built in a way. So what we do is here, this is actually a AI tool based platform. Currently, we are close to 56,000 respondents who have responded to this platform. It's been an active source for the last 8 to 9 months that we've been building. So we have various different sections. We have case studies on various subjects, research and innovation is also that we are trying to cover. Innovation spotlight, news and events is also something that will be an ongoing activation program in terms of seeing that a lot of things are happening in the country and also globally. And here is an interesting part is the sectors that we are trying to cover: orthotics and prosthetics, maritime and shipbuilding, aerospace and defense, automotive and tooling, architecture and construction. A lot of that has been seeing a great future in the coming times. Dental and maxillofacial. This has been more consumed now that we know that we are at a time when every dental setup or a clinic might also look forward to having a dental machine, very specifically a desktop machine. We are also seeing a great prospect for even metal machines with resin already in the kind of proliferation that we are seeing. Orthopedics and spine, medicine and healthcare, bioprinting and tissue, art and entertainment. So all these sectors have been really benefiting from these customized solutions that are to be offered because when it comes to medical, yes, every body anatomy is different, shape and size, bones, structure. So I think it's so very clearly defined in terms of what can be expected from uh, from uh, from this technology. And we want to keep sourcing information on the subject. We're also happy to launch our 3D Graphy Lab, which is an initiative, and we will also be setting up this as a franchisee in the country for many of whom would also want to start their 3D printing businesses. So with more proliferation and more setups like these, the idea is to see that how there can be more active participation and indulgence when it comes to business, and the technology will get its growth. So that's about it. And thank you so much, ladies and gentlemen, and also this a panel of dignitaries and Dr. S. Chandrasekhar sir and Dr. Naga sir, and also the other 3D Graphy associate corporate members who've actively been a part of our consortium. And I'm sure there is much that we have in store going forward to see that this technology gets the prominence in the country. Also to introduce Rajesh, who've been missing the links because of some audio problem at his end. But I'm sure towards the session he will be active to share his presentation on the subject. So thank you so much, gentlemen, and thank you, Dr. S. Chandrasekhar sir, for your presence and participation. And look forward, sir. We will definitely want to work with your association, sir, to ensure that how there can be the larger interest to see that the sector and the industry can benefit from this technology going forward. Thank you, sir. So,
And are we in LinkedIn? Is this platform publicized in the LinkedIn platform?
yeah, we are activating the LinkedIn platform also, sir,
The
because
reason I'm asking you is one of my posts last week had about 627,000 views. One of the
right.
most viewed the post was from my, so I can be able to take you across. And please do it. And I
Sure,
wish this.
definitely, sir. Definitely.
Thank you
Definitely,
very much.
definitely.
Best
Thank you,
wishes.
sir. Thank you for your presence. Now, may I now invite all the key respondents to join in our first session. So we will have the privilege to have Dr. Naga sir, taking us through the presentation on the subject more on the technical side. So what I would suggest and I would request everybody is to then log out of this session, and we will log into the session one to then join. Thank you so much.
Good morning again. Thank you, Dr. Shibu, and the chief guest, and all the fellow speakers and colleagues and delegates joined in this virtual platform. Myself, Naga Anumaya, I'm currently director at Central Manufacturing Technology Institute, and I was worked as a chief scientist at CMERI, Durgapur, for 2 decades before I moved to CMTI in 2018. My presentation is more of the work which we did in the past, both at, that is the reason I'm using both the affiliation here, because whatever I'm presenting, it is a work carried out both at CMERI and CMTI. My talk is, I try to focus on how this 3D technology would facilitate product innovation, Particularly, I will try to cover the challenges with respect to these 4 Ps. I always call 4P challenges. There's a product, process, people, and production, focusing particularly on the 3D technology. Let me start with this slide. This is, yes, we are all now being an Indian, starting from the government to individual citizens. We all try to reach kind of Atmanirbhar. If you look at Atmanirbhar, this is all there in the public media. Basically, it is to create an ecosystem that will allow Indian companies to be globally competitive, and that makes India self-reliant. If you look at self-reliance, according to me, there are 3 ways. One can transact, lena dena, so one can take, so you can buy, or you can make yourself. Uh, if you look at Indian industry context, if these are the options before us, according to me, none of this would alone would serve the purpose. If you can look at transacting, doing business, then the challenge is Indian manufacturing our skill sets are unique, and many sectors are traditionally developed. The poor documentation and the protection, particularly when we are looking at Jugaad innovation. But at the same time, Jugaad innovation is still remaining as a USP for many of our manufacturing units. If you take, that means I'm buying, okay, I have a cash rich company, I'm able to buy. Buying a technology is easier than adopting and absorbing the technology capabilities. That only ensures the ROI. So that is the challenge in MSME itself. Even if you have money, it doesn't mean that 3D technology could be purchased and absorbed, because there are its built-in challenges. One can always ask, this was the approach we used in 90s. Maruti Suzuki bought the scientific manufacturing techniques. That is the starting point where we are in India in kind of auto sector. But now 90s and 2022 is entirely different. It is very difficult to if you only look at buying the technology elsewhere. It is technology acquisition as only means, I think we will not be able to reach our real dream of Atmanirbhar, because there are so many challenges. There is ungated globalization, demands are slowing down. If I look at developing everything in-house, that is also not going to happen. It is not that easy, because they're kind of, okay, if it's a development engineer, a development team, company, so there are options like reverse engineering, re-engineering, original design, innovation design. Even many cases, it is difficult to define in the global context whether it is original or novel or new, because there are a lot of technology gaps, there are a lot of restrictions with respect to patent operability, and then capacity building and capability building will not happen overnight. It is invariably kind of S curve. So naturally, you have to follow that S curve. And second is, though India was well known for cooperation and collaboration, but somehow this is now gradually missing. Everybody look, my neighbor, I always look at my neighbor as my competitor. I think that is another problem. We cannot develop everything in-house if you close your doors. There are other things, okay, investment, then sustainability. But end of the day, no matter what approach you use, to me, none of these are as a best if you consider as one option. But I think somewhere we need to collaborate and cooperate and then innovate, so that we could able to survive and we could able to reach our Atmanirbhar. That is what my understanding goes. And another is that why we should look into this. These are our drives. Yes, addressing 4P related challenges, that is product, process, people, and production, whether I want it or not, one has to do it for their survival, no matter whether you make a water bottle, whether you make a 3D printing machine. And at the same time, any development essentially has these 4 kind of stages. I call it as research, technology, training, and then application. And these are well known. So that means if I do how to do things, then by own hand, definitely I will be more skillful, and you will be more free and independent individual. So then you can depend on yourself and your community. And if you do yourself, yes, you are well prepared. You can stand at the technological crash. I think some of our majority of the Indian companies who are always depend on Chinese import, even for the capital goods or the supply chain. I think they suffered severely in this COVID time, right? If you are rooted, the more rooted in the real world, definitely you are more confident. You as an individual, you as a company, you as a businessman. And now that I think COVID is one of the example which taught us no more luxuries are expected. So more interest or more concentration goes towards the cost of ownership of the technology or cost of ownership of the product. So naturally, the frugal engineering is emerging one of the kind of viable approach to be competitive in the global market and also sustain in this competition. Yes, being an Indians as a citizen, we should feel proud because globally no one look at product technology for that any matter. It is made for India. That was our weakness, but now no, because our buying capacity is as par with any global any developed country. Make in India is just a process. It is a journey to reach towards made in India, if not the originated India. I think if you look at self-reliance, we have to transform the reach that kind of target, that is technology product originated in India. I know it is long way to reach, but yes, nothing stops to see the dream. And that only possible when we open our door, collaborate and cooperate, and work for us, not for me. So if you look at this, so is more of automotive community. I just show take the picture. Some source is an old picture. See, now the cars are becoming smart, reliable. So naturally, it is getting complex. If you Google number of parts in the car, it shows about 30,000 parts. So we know that is variety of materials, huge number of manufacturing process, varying degree of assembly accuracies, manufacturing accuracies, and they are need not necessary to manufacture within the same shed. It's been manufactured across the globe. And but unfortunately, as an user, yes, I want more features, more level of comfort. It should looks good. Again, the car which looks too good to me, it may not looks good to my wife. Small, big, there are different options. The cost, yes, I will be happy if I get it free. Then time, right? We need a car. So it means as a customer always look at I will go to showroom and buy. So that is why basically if you look at all these things, making just car is not that easy. And another is in our work environments, is always trend is like this. I'm not a manufacturing engineer. Am I responsible? Is it my headache? So that is what the different friends in the industry talk. I think that is the system. This in this system, the technology matters. The technology integration into the manufacturing value chain is inevitable. There are technology developed in three different aspects. One is there are several technology, no matter whether it is auto, no matter whether it is semiconductor, significant number of process technologies have developed with respect to manufacturing processes and manufacturing of equipment, machines, then manufacturing systems like when your Industry 4, Six Sigma or TPM, those all kind of manufacturing systems, trends, even miniaturization of the factory. The people are talking about micro factories, nano factories, or virtual factories. That right. So end of the day, yes, this is what our target to realize our the vision of our honorable Prime Minister, that is Atmanirbhar Bharat or self-reliance, at least in let us in technology. So yes, one has to look at the technology, made in India, if not originated in India. And at the same time, this is the golden rule. Engineering of any product is a process. Nothing happens just like that. This essentially one has to, whoever is involved in a product development has to address these 5 F's: form, function, flow, physics, and fabrication. I'm not getting to details. I'm sure this is known, but I'm just emphasizing that yes, engineering of products has to address this. So when you addressing this, the engineering of manufacturing systems, though it is not an end product, but it goes as an essential component in the manufacturing value chain. That means engineering of product is, or engineering of manufacturing systems which addresses the 4P challenges that leads to the desired products. So therefore, you can't look at engineering of product and engineering of manufacturing system as a two parallels. The moment you look at a two parallel, I think you will not be able to do or will not be innovative or competitive. Unfortunately, whether I like it or not, in engineering, 1 + 1 will never be a 2. It is always either 2 plus or 2 minus. So only we are trying to reach as close as 2. This is the approach we at CMT follow. We call it as a DISC approach. Whatever we do in CMTI, it is a new to India, and try to address these 4P related challenges like data to design, that address there are several aspects like customization, localization, new novelty, frugal design, cost of ownership, when, why. If you look at innovation to inclusion, that connect, commit, inquire, investigate, design and develop, implement and iterate. And then cooperate and collaborate. Yes, CMT, we try to reach, teach, train, skill, regenerate, normalizing. Then yes, not for me, not we for, that is for us, it is for us. And of course, scalability and sustainability. That means CMT is also built the capital goods like machines, automations, knowledge harvesting, and solutions to productivity enhancement, modularity, and flexibility. That means CMT try to cover the technology which they develop, which are new to India at least, and at the same time, these technologies being implemented to manufacturing value chain. And while technology development, we try to address these challenges related to product process, production, and people. If you look at the new product development, yes, there are first generation, second generation. I'm trying to reach is what it, how the RP, I will try to give a back kind of history of our rapid prototyping. First generation, like make to work. Then second generation, people look at the quality. Then third generation, like design for quality, manufacturing, cost, like design for X. These are appropriate tools they use and prototypes they use. And rapid product development, like time. So how to reduce the lead time. A lot of simulation tools, and then a lot of rapid prototyping tooling process were developed, which could able to produce at least small batch production of ready to use, if not the direct manufacturing. And then we look at like innovative, flexible manufacturing, modular, responsive. Then a lot of tools get into the digital tools, PLM, mass customization, knowledge management, smart distributed manufacturing. So the idea is now people are looking at, can I make direct manufacturing, self-assembly of materials, digital twins, like, yes, now 3D printing or additive manufacturing is also considered one of the technology pillars for this 5th generation, that is like direct manufacturing or smart manufacturing. So people are looking even 3D printing to produce manufacture like self-assembled products. But still, in spite of all, our presence in India is very poor. This is not only for the kind of 3D printing, but this is in terms of industry novelty or in novelty of innovations in Indian industry. This is a survey conducted by Ministry of Commerce and Industry in 2016. Whatever we do, still our solutions are new to our company. This is about 56%. and they are new to India is 9%, new to world is just 3%, right? I think that clearly shows that yes, we are not so good in the kind of innovation matrix. Yes, prototyping in new product development. I just to recall that there are 4 focused prototypes we use: physical versus analytical, and focused versus comprehensive. The analytical is intangible, mathematical models, prediction models, investigating the interesting aspects, right? Physical is more of tangible, approximate product, or maybe that includes even the functional pre-production parts. And similarly, if you comprehensive and focus, comprehensive is more of fully operational, and focused is only adding one attribute. So that okay, it looks like this, it works like this. That is how basically you can appropriate tools are there. Of course, this is little old slide. There are several tools have emerged, which could be categorized or filled into different quadrants. But this is a quadrant that second quadrant is alpha prototype. This is where the cost involved, time involved is more. Uh, the major part is, particularly if you look at a prototyping, tooling is the challenge. And I think rapid prototyping evolved to solve some of these challenges in late 80s. And also similarly, if you look at again different discrete value order addition or value order addition people entity in the manufacturing value chain, if you look at a product designer, the requirements are always changing. He's isolated from manufacturing. He sits in his AC room somewhere, and he has to address the huge data handling, then preparation of 2D drawings to simulations, and of course, these are all intellectual manpower. It is always difficult to retain the HR in the company. And if you look at a tool developer, we are looking tool developer means including supply chain. That is why processes are not documented. Automations in design is limited, and analysis are again still on approximations. This all depends on the process, and that too in additive manufacturing, I think there are a lot of iterations are required, and it again leads specialized expertise. So here too, the changeover of HR is there. But as a discrete part manufacturer, his problem is as the change in product design before your product is delivered, and tooling always is an expensive, and more of iterations are required. Then there always are to modify because he is involved both involves capital items as well as the facilities or utilities, right? I'm talking about manufacturing utilities. Then of course competition. But as a CEO is always look at, yes, I have to be innovative, flexible, and responsive, and I should introduce the product in right time so that I be remain as a globally competitive. That is where basically this direct, net shape, NRS manufacturing, I just sample listed, and even additive manufacturing is also. That means, yes, there is something you look at, can you implement additive manufacturing, whether that would solve your purpose. I think that is where the kind of scenario I try to capture in this slide. But in spite of all technology, whatever you do, finally the 8 resources, technology, means you should one should plan, do check out, and then control. Then also technology is always changes, so one has to be open and you should improve your technological capacity and capability. Then the people. So other than people, everything is a dead body. So one has to design, build, consume the technology, and apply the technology. Then the material, that the starting point of value addition process, information, the driver in the value addition process, energy, that is the resource pushes your manufacturing value chain. Then tools and machines had heads for the manufacturing value chain. Capital, that brings the confidence. The time, of course, time is, every process has a time we need to have. So therefore, I think one has to, it is very well known, one has to develop these resources precisely, use decisively, and protect efficiently. If I look at the tool engineering dilemma in view of additive manufacturing based tooling, I try to cover here is yes, the demands always toolings are the more accurate. General manufacturing thumb rule is the tool should be at least 10% accurate than what what accuracy level desired at the product level. And unfortunately, tooling is should be inaccurate. Lead time has to be reduced. It should be less expensive because art tool have a more life, but there is no demand. So then flexible for changes because in the new product development that is another difficult. Your tool is hard, it is difficult to change. Then of course other finish like surface finish. Then if you can able to process multiple components, family of the components, that is the kind of thoughts for the tool engineer. And then of course special expertise, and this is required because tool engineering itself is specialized expertise. If you look at a conventional tooling like machine tooling, lot of machining time, more, at least lead time is 2 to 3 months. It used to be 2 to 3 months, and lot of experience is required. Lot of capital is required to manufacture the more toolings, particularly dice molds. Of course, AM-based tooling have reduced some of these, less and no machining, moderate cost, particularly for the low order quantity. You can get the tie in a few hours, few tens of hours, irrespective of what complexity is issued. But yes, there are limitations with respect to technologies. There are several technology being developed in parallel, but they are all immature. And accuracy wise, yes, there are still leaves a lot compared to the machining process. Surface finish, that is also true. So invariably, if you look at a additive manufacturing tooling, surface finishing is mandatory. It is very difficult to use additive manufacture tools as it is without secondary operations. But there are also challenges. Manufacturability is unknown. The performance, part quality are yet to standardize. I think that is where the tool engineer has to make kind of shuttle between the conventional tooling and the AM based tooling to meet these requirements. Yes, at the same time, this only happens with the iterations. I think at least I'm strongly believe that is through practical learning, practical or experiential learning. So that driven by the statement like I hear and I forget, I see, I remember, I do, I understand. That is where I think our graduating engineers lacks. There are limited opportunity for the engineers or the diploma holders or the technicians comes out of the engineering college to realize these kind of challenges being used. Now let us look at what is additive manufacturing. So I will not get into the individual manufacturing processes, but otherwise, no matter what manufacturing process, invariably these manufacturing processes could be grouped into four categories. Manufacturing process is to create desired geometry that are being done either by removing a material, shaping a material with phase change, without phase change, or adding a material, that was your additive deposition and all, or assembly at atomic level, that is like self-assembly, bio-inspired manufacturing, biomanufacturing, all those falls under this. So that means our additive manufacturing is basically we are adding a material. It may be a parent material, then you add build over that, that is there, or you add the same material layer over layer, so to get the desired shape. That is what the additive manufacturing in common sense, right? It is basically layered manufacture. You can create a geometry by adding a material of desired property by using different energy resources like laser and all. And we are fortunate currently this 3D printing technology have multi-scale capabilities. That means these are the few examples I just populated here. You can build infrastructure, buildings by 3D printing. So you look at even this picture, this is built at IIT Madras in 2000, if I'm correct, it is 1920. right? So you can also see that kind of, this is there in China, is a 3D printed apartment block. Even in Africa, this is 3D printed 14 tree kind of apartments are built, right? And this is like beautiful heritage places are also being created using 3D printed technology. So you can look at 3D printing is not for shop floor alone. So 3D printing can also be used to build massive structures like this too. And at the same time, this is just opposite scale. This is our CFT technology. I will give you a little more detail, but this is just to show that 3D printing can build a features in the few orders of microns. You look at the micro readers of 3.75 micron built by this machine, which is developed by CFTI. That means you can also create the micro scale. That is what the multi-scale capabilities of today's 3D printing technology. Um, and also, like, okay, there is 3D printing technology is there, but also there is a secondary processes. This work I think we did in 2002, if I remember correctly, at CMERI for LML Vespa cylindrical engine, right? That time what we tried to do is that you can use the 3D printed part that we used SLA, stereolithography made, quick cast pattern, then quick cast we can directly use it in investment casting, but otherwise you can always use this, make a vacuum casting mold, silicon rubber mold. Then this silicon rubber mold is used to wax pattern, then you produce, then after that follows typical investment casting. But you can also avoid the multiple steps if SLA quick cast part can be directly used as a pattern over which they can make a ceramic shell and then produce the casting. I think these were all were there. I'll show you the status. And then in this is another work I did in CMERI. This is the laser system which we built, which we integrated. We sourced the lasers from a different source from Italy Quanta, and the rest all we built, engineered here. This happened in 2010-11. The same machine we try to use kind of creating a microscale, nanoscale features, and at the same time, we also use this system for selective laser sintering of a copper powder. Our intention was, it was a nanopulse second pulse laser. Our intention was to produce the features like to less than 200 microns for ablation and sintering of less than 10 microns scale features. It was beautifully we have done. This is in fact first baby of my PhD student. Where we sintered 5 micron copper powder, not from commercial system. This is the laser system which we integrated. We bought only the laser source, and we studied. Okay, this is all theoretical interest. There was a beautiful acceptance. We could able to build up to 22 layers. The size of the component was 5 millimeter by 5 millimeter. Image is the quality is poor. It has some small features like about 0.5 microns. Sorry, 0.5 millimeter, 500 micron features. So here I just summarize before I get into what we do in CMTI. Additive manufacturing, if you look at additive manufacturing, is an alternative manufacturing process for industry production. This was the journey. Until 2000, rapid prototyping was primarily used as a prototyping, and little bit of expansion that people used to call soft and bridge tooling to produce few hundred or thousand components. There were several processes were there. I'm not getting into the processes. Then after 2000, people will look at, okay, I will make it dies as comparable to our conventional molds and dies. In fact, my PhD was surrounding this problem, how to manufacturability evaluation of dice molds, injection molds using these approaches. And then idea was, can I use this rapid prototyping, the people call rapid art tooling. So I can produce functional parts. Okay, maybe first few batches or batch order could be produced. The beauty of this is you will get the mold in few tens of hours, which is otherwise takes 2 to 3 months. Then now beyond 2012, so though there was a direction, people look at that is rapid production, rapid manufacturing and all, but it was little slow. Did not happen that fast. But yes, Now people are looking AM for a regular manufacturing of safe products, bimetallic products, composites, and also processes have been hybridized. Then even there are attempts that can I use this AM machine or the smart AM machine so that I can able to produce the component inbuilt so that you can avoid even the assembly operations, means ready to use systems level, not on the part level. But still, yes, there are a lot kind of routes to improve. I just try to list, these are only few selective, but yes, there are, one can get into that. There are more opportunities for particularly young researchers and young practicing engineers to explore, because I will call it as the sky is the limit. The product is, with respect to product, yes, we don't have a machine which can address range of uh, geometry. That means like we call not three axis, 5 axis, like that. Then the tolerance still they are poor compared to machining, and still there is a limitation with respect to materials because every process will not process every material. Like that is the kind of, you cannot select. You don't have, you have a limited option, I will say. Then the size limitation, typically 300 by 300 is the current machines could able to handle. And more required here is design for AM, because you cannot get an AM machine as you want, but can you look into designing a product design which is suitable, which is manufacturable by a selected additive manufacturing process. I think there are a lot of emphasis goes on design for additive manufacturing. Yes, as I said, process, there are many processes developed parallelly, but still the low maturity level. Either there are processes specific to specific material, specific combination, and invariably majority of the additive manufactured components has to be processed for some purpose, either for assembly purpose or some finishing purpose or some aesthetic appearance purpose. And then, yes, manufacturability is still an issue. You cannot produce what you want. So that is what I was saying, that you have to design the parts for AM. Optimization and hybridization is the approach people are using. Then no training. So still additive manufacturing is not a regular course. Although there are some schools offering as a electives, and though there are post diploma and master's courses are getting introduced now, but still it is not that additive manufacturing is taught as one of the course. Maybe additive manufacturing is taught as a part of manufacturing processes as one chapter. So still they are covering SLA or what is that, your SLS, FDM, the process only they are describing, nothing beyond that. But what is required is one has to understand science behind the technology, specific technology. I think that is where the gap is existing. So we won't get a people who have fairly good knowledge about the process science and the technological aspects, because there is no proper training is there. Then the production, yes, these machines are made elsewhere. They are very expensive. In many cases, they work like a black box. And supply chain, yes, because particularly the energy source, laser, ion beam, all those kind of things are still yet to be imported. I think that is where the lot of importance is required. If you really look at Atmanirbhar in capital goods like additive manufactured machines, I think that is where the CMT is more focusing. Yes, this is just to summarize what we do in CMTI. We develop range of machines, ultra precision, special purpose machines, so sensors, controls, or subsystems, then textile machinery, aircraft LRU, test rigs, then micro nano manufacturing, metrology, smart manufacturing, industry 4, and additive manufacturing is also one of the major focused area group is there in CMTI. We offer a lot of training programs, services, and we also have a 54 technologies which are ready for licensing. So still, all these 54 technologies are new to India. It is not made, not manufactured anyone in the country yet. I think maybe some of the industry can interested, so we'll would like to talk to this. We always see the dream of using this 54 technology by fascia floor. Okay, these are just skip this. This is just a research centers and some of sample technology which I listed here. We also offer a services, about 10 category of services: machine tool and aggregate, measurement, calibration. This is particularly 3D printing, re-engineering of high value replacement components, aerospace qualification, material testing, nanomaterial, nano characterization. And these are the training programs. There are training programs with a scheduled calendar, and also we can able to offer a training programs customized to corporates or academics on specific topics. There are a lot of finishing school, 6 months training finishing school is there, is paid stipend. Then summer internships and all, some of the active learning workshops for engineering students are also organized. I'll just brief what we did in additive manufacturing at CMTA. We developed microstereolithography machine which is capable of creating any complex shapes on photopolymer as small as about 5 microns. Though much smaller we tried, but I can, if anyone buy this machine or anyone bought this technology and suitable, comfortably we could able to demonstrate you 5 microns on photopolymer. We also made IIoT enabled smart 3D printer, because now, as I said, 3D printer is one of the vertical technology pillar of Industry 4 or smart manufacturing. So we have the capability. You have a 3D printing machine, no matter how old it is, we can convert that into a smart machine. Or if you want IIoT enabled 3D printing machine, we will be able to develop for you. And then we offer a lot of services like this is, see, you got to look at automotive turbocharger shafts, reconditioned, pump gear shaft, again it is a reconditioned for aerospace applications. These are the services. Since 2000 we are offering the services. And then finishing of AM components, as I said, secondary process is obvious at this moment in the abrasive, sorry, what is that, additive manufactured components. So we have built a machine that is works on abrasive flow finishing. You can kind of, you can 3D print the part like this and use this machine to finish it. It gives you the RA value in the kind of fractions of or decimals of microns. And these are current projects which we are doing. So we are developing some of the subsystems, indigenizing, modular cladding it, and we also working on some of the process like dialess-based casting without laser, without energy source. We wanted to have a additive manufacturing machine. We could able to make some prototypes, but yes, this is still, we can say, TRL level 3. And then we also wanted to have a AM machine which is pack you can pack it and take it, particularly for in situ repair, coatings and all. If any industries wanted to join this up, we are looking for collaborators, because many systems has to be repaired in situ, even the larger dies and modes. I think that is what we are building. And then modular quality assurance module, that is some in situ inspection of 3D printing parts. This is to one of the tools to convert your additive manufacturing machine into a smart. And we are also building a scanning system as an alternative to galvo scanners for a powder bed fusion system. Then we also have kind of diode source for particularly the photopolymer. And now we are building with one of the industry kind of partners, 5-axis AM metal-based machine with a little larger built volume. Our further research interest is, of course, these are all not in project mode yet, but we are interested to do this. Design for AM. We wanted to work AI and ML-based algorithms that to evaluate manufacturability evaluation, particularly for the additive manufactured components. And then testing and functional validation of 3D printed components. As of now, globally, there are only 2 standards are there. I think BAS is also looking, because I'm part of BAS committees, is also looking to standardize, introduce the Indian ISO standard, Indian BAS standards. I think this is, there are a lot of research. None is practically, there is poor as far as standardization in additive manufacturing. Okay, there are a few exceptions, but we can easily say as a user industry, if you look at, I think there is no standardization as of. Then a lot of requirement is process hybridization. This is both additive metal and also even within that deposition sintering, because people are looking at self-assembled or assembled subsystems manufactured through AM. Then finishing of AM, one we have now abrasive flow, but now we are also looking for a aerolab machine for aerolab finishing machine for AM machines. Again, we are looking for the collaborator, industry collaborator for this. We are also working with MIT. So this is multi-institutional program. This is still under the proposal. We have already submitted a proposal. We wanted to use additive manufacturing for agro food processing. So CMT has committed to build 4 such machines for various applications, both agrophotonics, frozen food, medical nutrition, and agro infrastructure, vertical farming infrastructure, built by additive manufacturing. CMT will build a machine, and our other collaborator is the technology facilitators. This is the proposal stage. In fact, our chief guest was mentioning the additive manufacturing strategy paper released by Honorable Minister of MIT. I think that picture was also cover page picture. Sushma 3D was there. So we are already into that strategy. I am leading a committee of additive manufacturing expert committee there. You look at this machine. As I said, technology development will happen over time. The first picture, what you have seen is a laboratory setup where the constant demonstration was done on workbench at IASC. And this is the last one you want to see is the picture. In between, there was one prototype built at CMTI. But this is now Sukshma 3D, which is capable of producing any complex shapes like this using photopolymer. You can look at microneedles, scaffolds, cardiovascular. And the cost component, this imported machine would cost you crores plus, but I would be able to say, well, even being R&D institute, which is not a regular manufacturing, I will be able to sell at 32 lakhs if only somebody is interested in the machine. I think that is what that advantage. It is a DLP based machine. Okay, I will not get into little more details. The process is otherwise is a DLP, direct light projection mechanism, and all this micro positioning, nano positioning tables, everything. The complete system is engineered except DLP. DLP was the only button items. And this is a picture, what I said, that technology, basically 3D printing, FDM machine has been converted into a smart machine. We developed the mobile app, so you can operate from sitting at your office and print. You just make the CAD model and send the CAD model, and it gets downloaded there, and through mobile, you can operate your own machine. And it is, yes, embedded with all some sensors. You can also monitor the process, what is going on the machine. And this is what abrasive flow nano finishing, I said, this is a machine. You look at the values, any complex shapes, you can able to finish it. And additive manufacturing, several additive manufacturing components we tried. This performance is really good. And this technology is again not made in India yet. So this technology is also ready for available commercialization, and also CMTech can supply these machines. And now for a machine, we are basically building a parallel kinematic based machine structure for deposition. Our target is to build 1,200, 1,000 by 500. Another target is we wanted to build this machine with 95% Indian content. We don't want to import anything. Otherwise, I think winning the market is very tough, except the cost component, because there is a visible delay of a kind of gap of about 10 years. That is the reason we choose. There is a reason why we choose PKM, because small machine, larger build volume can be done. Our dream is to have multi-axis, so you can deposit even from the bottom. I think that is what we do. And some of other things, but there is also an attempt what I mentioned: no laser, no ion beam sourced additive manufacturing. This I will just run through. There are a lot of services we offered to various industries. These are all industrial component. functional parts like this, CDM tool electrode, and hybrid materials like bimetallic parts, the remanufacturing of wear out components and high value products, replacement components, and also some material development, new material development, because it has a bimetallic applications for some specific applications. Then as a coating also we tried using deposition based process, layer of functional material coated over this. And this is another turbocharger shaft. What I said is a little more details how we did developed, studied for means whatever we do. Basically, we try to understand the process and develop the process technology so that our industry partners can use it directly in their regular manufacturing process. Or if you want to use AM as a manufacturing process, the total solution will be given. Similarly, this is another, like what I said, pump gear shaft. And these are some other components like bimetallic inconel and stainless steel bimetallic parts. And these are like specific bimetallic parts, but more of aviation applications. I mean, if you look at, we do the systematic study, characterize. It is not that we just make and play with a component. Unless we get into this, it is very difficult to see the dream of replacing the rolled or cast products by 3D additive manufactured components. I think this is where the challenge is there. And again, yes, this is another material which we developed for some strategic applications. And this is again for strategic applications, nitty alloys, right? Then some odd material for some sensor applications we built, hybrid materials, which is like customized design by the material scientists. So then we made it for them. And at the same time, yes, this is what I mentioned in the earlier introductions there. We used like 3D printing integrated into a foundry so that metal casting could be done. Up to 1 kg casting, we built a 3D printing kind of smart foundry. This project was funded by Department of Science and Technology. 10 collaborators, 3 R&D and 7 academic institute, both centrally funded institute like IIT Bombay, VNIT, College of Engineering Pune, Jadavpur, and also there are private universities. So we all joined together to, initially we thought that we'll make foundry like, which looks like left side to the right side. One operator can able to cast 1 kg casting. That was. Then this is little more details on that. So now this is the right side, which is ready for smart foundry, which has a footprint of 16 feet by 8 feet. It is pattern, 3D printing is there. Pattern can be built by, this is a 3D printed pattern. Use that, and automatic molding machine is there. Then you can use it, cast it. So it is industry deployed, we call iFoundry. This is now ready for demonstration, and also industry can able to, if you're interested, so they can reach to us, we'll do it. Yes, there are smart manufacturing and all. I think I took consumed my time. I will stop just going through another 4 slide. We CMTA work on different challenges which are associated with smart manufacturing like this. And our MHI is funded center, one center at CMTA. Our center is primarily try to address, to develop the technology which are required to demonstrate smart factory like this. So CMTA has this smart factory, and what are the technologies which are required to demonstrate this smart factory? We expected to develop by us a consortia of 6 industry joined together, and we're developing as a consortia all the technologies which are required to create or demonstrate smart factory. You can look at this if you want to know. These are some of the solutions which are already ready for industrial applications. You can note down this login, and more details are there, including like OE of the company, of the production units can be monitored with our own solutions. These are all solutions developed by CMTI. Nothing is imported. And the sensor technology also, we have a fabrication facility. Here So if someone is looking at packaging, yes, we are also trying to use the additive manufactured process to package this, but we are still not succeed. But yes, we can able to package your sensors, 3D printed functional components. If you are looking for a packaging, we can able to do it. And this is the last. This is like scanning technology. This is an handheld technology. So you can use this scanner, capture the complex shapes, then send this data to your 3D printing. I think the total solution is available at CMTI, our own solution. You can capture as small as about 30 micron features. This is what the summary slide. Again, I brought back. I think this is where the opportunity before us, when we can be able to do a lot of development as well as research applications, and also one has to address this if you really look at additive manufacturing as a alternative manufacturing process. If any of you looking at solutions you want to develop, there is also platform drishti.cmti.res.in. You can host the challenge. We have 5,500 users. They will participate and provide a solution. It is just like a marriage bureau. So you can always find your solution providers and then find a solutions for your problem. This is an open innovation platform we call. Thank you. So the my again same closing remarks is in order to realize Atmanirbhar, I think we need to reach to made in India, if not originated in India. And it is also which one should realize it is always there is no shortcut. It has to be an S-curve. And but at the same time, this all innovation is a demotivating, but there is nothing wrong reason. I find no reason to demotivate myself because all this Einstein statement you look at, everything that can be counted does not necessarily count. Everything that counts cannot necessarily be counted. I just we kind of restated as applicable to research community. It is difficult to measure what is important in innovation addressing the 4P challenge. The reason is measurement of novel or new are likely to be incomplete. The things looks new to me may be novel to you, or which new to you to me it's a novel. So thank you very much. Thanks, John. And if I've taken more time, I'll close it here.
So thank you so much for your insightful presentation. I think it had covered a lot of aspects, including your setup for machining and 3D printing and also scanning solutions. Thank you so much for your time, sir. And there were some questions posted. I think the first question was how to incorporate 3D printing additive manufacturing in undergraduate level at this moment, Doctor. So quickly we can.
I always say I'm a part of undergraduate curriculum development committee constituted by AICTE. A lot of deliberation gone into that. We have recently come up with the course curriculum. I would suggest academic faculty, though many of academic faculty may not accept, but my own experience, because I also taught MTech and PhD students I guided. The laser system which I built, I have taken a quote, it was 1.82 crore. I had only 100 lakhs. Then I thought, let me take a risk. I've taken a risk. We bought the laser source, everything we integrated. I will tell you now advantage. I built a system which costs me around less than 60 lakhs in spite of buying the laser system that itself was expensive from abroad. But advantage I will tell you, if I bought 1.8 crore investment, this warranty applicable only if XYZ. And I would not allow my student to touch that machine, at least for warranty period. But here, this becomes a toy. My students, some of my students and my fellow colleagues even machined a bone. And we also machined a copper, and the component which I shown that was supplied to bark. And also we made a sintering of a copper powder. I think that is what kind of beauty. I think academic institute has to first, I would suggest there are many faculties, even NPTEL course and all is there, which is lot of material is there as far as processing is concerned. but that is only limited to definition of the process. Better you build a lab first, use your MTech, BTech students, then you introduce undergraduate course. That is what my suggestion. But I know it is not tough, but it can be done.
Okay.
You ask students to spend 10,000 rupees because many engineering college students they pay 1 lakh. Even in IITs, the fees are more than a lakh. If a student able to afford to spend 1 lakh for tuition fee, I'm sure he will be able to afford 10,000 rupees during his entire undergraduate student. Catch hold of 5 students, 50,000. You build additive, no matter you don't worry metal, a specific material, so let this machine works 10% of the imported machine. Still, you will enjoy, and your students will enjoy. And you bring next batch, you will improve further.
Thank you, sir. Thank you so much. There are some more questions, sir. What we'll do is we will, since we are actually cascading with time, we will have all the sessions done, and we will definitely, for respondents like Jaideep, who had actually asked some more questions, we'll try and address this. But we just want to catch up with our time. Thank
You
you.
can send an email.
Yeah,
So
surely.
I will be
Surely.
responding. No
Yeah,
problem.
I will share those details with you also, sir. Thank you.
Right.
And also the
Thank you.
respondent who asked questions. Yeah. So thank you so much, sir. And may I
Thank
now
you.
invite Mr. Rafiq Somani, who is the area vice president with and South Asia specific with ANSYS. Now, ANSYS happens to be one of the leading software solution companies in simulation and various other aspects. So we all talk about 3D printing and metal 3D printing because printing, but the key is the simulation softwares which actually help us to derive in terms of what the construct needs to be done. So I think it will be a great opportunity for us to get the insights from the man himself, Rafiq. Thank you so much, sir, for your presence, and we can start your presentation, sir. Thank you so much.
I'll request Doctor to stay
visible.
on for next 20-25 minutes because, thank you very much. I'm audible also, correct, Subbu?
Yeah, you're audible.
Yeah, so I would like to first thank you, Shibu, for inviting me, and also thank Doctor from CMTI. Actually, the presentation was very, very interesting, and I think he has laid a foundation for my presentation. And what I liked about his presentation was that he talked a lot about additive manufacturing process and how design for AM is equally important or very, very important. So I will talk about the challenges which the additive manufacturing industry faces, and what are some of the processes prerequisite one has to take care of. So I would like to thank Doctor and request him to go through my presentation also. Yeah. So I think very clearly everybody knows these are quick facts. Even in pandemic, the last 2 years, the additive manufacturing industry has been growing at least compounded 21%, and is scheduled to grow much higher. There are some reports which are showing aggressive growth, which you can see in different graphs are there, color coded. But even if you take the average, it'll grow at least minimum 20%. Yeah. I think everybody knows what is the role of additive manufacturing in automotive. Each and every component and part is now people are going more and more converting that into additive manufacturing part. This is a survey and a graph from Deloitte University Press. Talks about which are already very actively used currently in manufacturing or automotive, and what is the future looking. And as we speak now, a lot of the future part, including the electronic and OEM components and powertrain technology, are already getting manufactured or done through additive manufacturing. This is one of the examples where you can source out your parts to various suppliers for manufacturing, traditional manufacturing, and it can take weeks and months and can be very, very expensive, whereas you can make this entire housing part of an engine in a matter of few weeks, with very, very less tooling costs. Yeah. So I think everybody on this call knows the advantages of additive manufacturing, and the promise is very, very clear. Very, very, you can see on the top right hand side, very, very complex parts which one cannot imagine can be manufactured. Additive manufacturing gives that opportunity. Very clearly, lightweighting, reducing waste, distributed, especially in COVID kind of situation with all the geopolitical situation happening, distributed manufacturing. Say, doctors spoke a lot about design and develop and innovate in India, and a big company has to have within India distributed production. Additive manufacturing gives that. Various new material properties, sustainability has become very, very important. Environmental effect is very, very important, and replacement of part again, is a great promise additive manufacturing offers. But as doctor said, like there are many challenges. In fact, very honestly, I don't want to use a word. One can end up buying a white elephant, and doctor talk about very innovative ways how CMTI was able to make and design some of these AM machines locally. But if you are buying any additive manufacturing machine, it can be a white elephant if you don't know how to use it, and what is the material science required, what is design required, what is the process involved, because it is a very, very expensive affair, and reliability, repeatability, and qualification is a continuous challenge. I'll give an example. Yes, and doctor will totally appreciate and understand that what you design and what you manufacture can be totally different. Correct. So here is a distorted part. Post manufacturing, and in design you have done everything. In CAD model you have done everything right, but a simulation technology like ANSYS will allow you to kind of predict where the errors and deformity will happen, and kind of even take care of some issues post manufacturing, which happens mostly in additive manufacturing, like crashes and cracks. Yeah, very, very repetitive example. So what we are talking is that anywhere from 10 to 20% part or manufactured part will get wasted or lost if you have not done, as doctor kept telling through his presentation, how the process is very, very important. Design for additive manufacturing is very, very important. Otherwise, you will end up with at least 10 to 20% loss in production. And again, we are talking of this very, very expensive. It is not just the parts which are expensive, but the material cost, the machine cost. You know how expensive per hour rate of these machines are, the labor cost and everything, and cost of loss opportunity. So if you are not designing for additive manufacturing, and if you're not following the right process, you will end up making a lot of wastage, and you will burn a lot of money, and that impact directly to your profitability. Yeah. So I will take another example. This is of crop filters in UK, and you can see as the simulation model. On the left hand side, you see a typical CAD model. You have done it well. You're very happy. You've done a fantastic job on CAD model. But when you manufacture it through AM, there is a bulge, and you can see the simulation can predict that bulge. What we are talking here is to add, and I'll go into more details as we speak, and I've added a lot of examples. How do we upfront using simulation technology, add some design for manufacturing? Like in this example, the compensation was required to be done, and you have done that compensation at the design stage itself, and you can see a perfectly manufactured additive part. So this is just one example. So our experience in additive manufacturing over the last 10 years, and even if you look at various industry report, it is very clear that simulation can help you reduce your manufacturing cost almost 75%. It will cut down lead time up to 80%, and can also help you reduce the weight. So this is a combination of both additive manufacturing and simulation. So using both in combination vis-a-vis the traditional manufacturing. Yeah, you can get these kind of amazing results if you use the additive manufacturing right way. And my next 15-20 minutes is focused on what is the right way. Before I start that, who's ANSYS and why we can talk about manufacturing with confidence is we are, for the last 50 plus years, we are in the field of automotive industry and focused on simulation technology. And we very, very clearly, we are a market leader over here as far as automotive and simulation technology is concerned. We are almost a $2 billion company with a market cap of 35 billion. So if you can add all the simulation companies put together, their revenue, and you look at revenue of ANSYS, $2 billion, we are much greater. Simulation is our core business, and we are growing, at least in this kind of market situation where our industry is growing 7 to 8%. We are growing over double digit continuously for the last 10 years. And we have that projection of growth also. And kind of, as far as disruption and innovation is concerned, that is kind of a second nature to ANSYS. Again, thanks to all our customers, which inspire us to push our technology. So be it a world-shattering electric car from Volkswagen to autonomous cars from all the top OEMs, very much, ANSYS is there. You're talking of, again, autonomous aircraft which will fly to, improve the carbon footprint from Airbus and Boeing. ANSYS is working with that. You're talking of 12 nanometer, 5 nanometer, 4 nanometer. Our phones are getting smarter, our chips are getting billions of transition getting added, and we are working with companies like Samsung, Qualcomm, and Intel, and putting billions of transistor on a small chip. And again, that cannot be done if these companies are using simulation technology. And again, our technology is used by companies like GE or Medtronic to save lives. Yeah. We've been working with all kinds of companies, be it aerospace, automotive. I said very, very clearly, it's one of the major market for us, industrial, semiconductor, and white goods. We are, in that sense, have varied industry experience, and we work with marquee customers all around the world. So this has given us, confidence to build our product much better. The demands of this marquee Fortune 100 and 500 companies push us our technology, and we have a comprehensive technology piece, very, very accurate solution which the engineers can depend on. And we are a great partners. Our systems are more open, including additive manufacturing. I'll put some slides in the end on that. And we are considered in our industry expert in design and manufacturing as far as automotive and additive manufacturing is also concerned. So Dr. from CMTI did speak about some of these things. I'm trying to now go into some of the details. So it is just not you take a CAD STL model and boom, you put in a AM machine and print a part. No, it is not that simple. You have to start with design first. You have to do a topology optimization. You have to set up. You have to put the process simulation. You have to understand. Dr. Did speak about material science and material analysis is very, very important, and more important as our technologies are becoming part of a enterprise solution. How do we add additive manufacturing as a part of our entire product development life cycle, and how do we kind of do some smart part analysis and reduce number of parts, reduce the number of materials, and have, as Sir mentioned, Dr. Sir mentioned, about having generating a cheaper material cost, which is still quality wise and reliability wise far superior, and from sustainability point, very good for the earth. So I think these are important things. This is a very simplified diagram of what I meant by the entire additive manufacturing process. How you have to, at the design stage, do topology optimization, do some validation, and follow the print process, and also study the microstructure. If I have to expand this simplified model, this may look little heavy slide, but everything Dr. from CMTI spoke about, it kind of captures and kind of addresses those challenges and some of the example from Croft Engineer, which I spoke about, correct? So you start with design for additive manufacturing. What are you taking care of? All the design constraint. We saw some example of bulges and cracks. How that can be taken care. And building up the right geometry very upfront. And then you do using simulation technology, do the validation. Then you set up the build up on the orientation and support system of the entire manufacturing process. You go through the print process, what will be the heat treatment and all the thing. And very important, which we should not forget, and as more researchers, and you want to do further improvisation, then the material science and the microstructure analysis also become very, very important. This piece of the additive manufacturing is in a very, very nascent stage, but this is a huge focus in coming years. Not many companies talk about it, but ANSYS strongly believes that the qualification and validation and doing the material microstructure study, on the longevity and the reliability of an additive manufacture part on a long term will be, very important. Remember, we used to talk about prototyping, 3D prototyping, 3D, and now when we are talking of additive manufacturing, meaning you are replacing with traditional manufacturing and putting parts and component in aircraft and rockets and automotive thing, then it has to last that much longer than the traditional manufactured part. And that is where the microstructure and validation and quality and reliability will play a very, very important role. ANSYS has technologies over here which takes care of this. It is not just be very happy, oh, you know what, I have additive manufactured part and I've replaced the part. Okay, good job, but what about its reliability, and what about its sustainability? What about its impact? What about the carbon footprint? What about that? A lot of people don't have answers for this. So I think this is very, very important. And the next piece of important thing as we get into MBSE and enterprise manufacturing process and IoT, Industry 4. Doctor did speak about it. Then how do we integrate our additive manufacturing in the entire process? So I think that is also very, very important. Yeah. So let's take an example of this is a Hyundai manufacturing. This company also got an award for their additive manufacturing in Korea. If you can hear the voice, it may be in Korean, but please, there are. So we're talking of entire process. To start with an over design. It is topology optimization you do. Validation. Or optimize it. And the process of manufacturing. this is very important, which I spoke about microstructure analysis. So this is another example, which again was a award-winning additive manufacturing part from Hyundai. And here you can see, the design goal was to reduce the weight and improve the performance of this hood hinge, which we saw in the video, and how the optimization was done, how the entire process was followed, and the part was reduced. The complex optimized part was manufactured, which was 5 times more stronger than the original design. Yeah. This is another example by engine block. The key criteria was how do we reduce mask in this engine block. And again, I'll just see if the video works. The entire the example which I spoke about, from design to manufacture to following the optimization to the manufacturing process, how dramatically 55% reduction was achieved in engine block, and did not have any cracks or bulges or the typical manufacturing issue which we face in additive manufacturing. This is an example. Electrification and autonomous is becoming very important. More and more as we get into electrification and ADAS. Also additive manufacturing technology will become very, very important. Here is a part of our CAD model from, so again, ANSYS additive manufacturing technology is totally CAD agnostic and ERP or PLM agnostic. And you can load a part from any CATIA, CAD, UG, ProE, or even SpaceClaim, bring it to SpaceClaim, which is the tool, and kind of optimize and go through the entire process of manufacturing. Yeah. This is also the entire process. When we are talking, that is where we have to stop talking about 3D printing word and use additive manufacturing. 3D printing is just one piece of additive manufacturing. As we know, additive manufacturing is a much larger thing. There are various process. Additive manufacturing can be done not just layer by layer, which we talk in 3D printing. So here is an example of challenges faced in the thermal stresses and wrapping during an SLM process, and how ANSYS entire additive manufacturing suite was used to prepare for the design, for the anchoring part, and follow the entire process to bring out not only effective support structure, but come out with a part which is reliable and perfect, and no material loss is used. Yeah. So as I spoke about earlier, don't worry about this complex heavy slide. What this slide is talking about, the data management and traceability of the material which you use in additive manufacturing will become very, very important, because the product additive manufactured part or your car has to last through the entire life cycle. And even if a car which is having additive manufacturing part, it will go through a journey of its life cycle, and in terms of its history, traceability, what material was used, what are the replacement material available, that becomes a very, very important piece. So ANSYS Granta material libraries helps you, in the data management and traceability part, which is very, very important. Yeah. What is more important, I think Dr. Did speak about AI and ML, and ANSYS has its own within Granta a machine learning algorithm, and so engineers need not do various trial and error, and improve the additive manufacturing from learning from failure. But how do you kind of base on that the past experience? How does the ANSYS additive manufacturing technology helps you to manufacture first time right. And this is a great example which our customers love this product as manufacturing and additive manufacturing is also becoming first time right, which was not the case in the early days of additive manufacturing. You have to be used to losing 20% of your material or manufactured part as wasted, not sure about its reliability. So again, this is a simplified chart that using ANSYS AM solution, how you can reduce risk, improve profitability, and improve your business opportunity. So kind of to sum it up, ANSYS additive manufacturing solution is available. If I showed you the dense entire process slide earlier, this is a simplified from the various engineers involved in the entire design to manufacturing process, and what piece of ANSYS additive manufacturing technologies can be used. So ANSYS additive manufacturing solution can be used by all engineers in a company, starting from designers to the machine operators, to the analysis CAE guys, to the material scientist guys, to the project quality and program guys. Yeah. So kind of it is just not a thing. It's not just a tool, but it is a very universal tool which can be used by an entire enterprise. Yeah. Uh, Again, when I spoke about earlier that we are an open system. We work with various additive manufacturing machines and technology companies and partners in the industries, who's who, and top academia who are working a lot, in the additive manufacturing field, who's who, and also, Doctor, if you're still on the call, we would love to partner with CMTI and see how we can, come out with some joint research programs. Yeah. So to sum it up, ANSYS additive manufacturing solution is a world-class, solution, gold standard, which can be used across the entire design to manufacturing process to cut down, your cost, reduce risk, improve your lead time, and reduce weight. Yeah. So thank you very much, Shibu. I'll stop over here, and thank you very much for the opportunity.
Yeah, thank you so much, Rafiq. I think very, very important. You did mention about the data management and traceability for EM. It's very, very important in terms of, trying to measure this tool, because simulation and the software and what it's an integrated tool in terms of what the software is offering today is really uh, uh, very nice to know. And because it needs, so it is actually trying to compartmentalize and try to cover all the aspects in terms of what is needed for AM to really make good sense. You also shared the video on warpage, so if you can trace it well beforehand, it really helps to for a smooth running. So, Dr. Naga sir, any questions for you to probably ask?
Yeah. No, obviously, I don't have any questions, but yes, as I said, particularly design for additive manufacturing is the call. As he rightly said, that what we design, what we manufactured is entirely is like a disordant many
Yeah.
times unless we taken care. I think that sense. And second is, I think there is also required maybe people like ANSYS and the knowledge partners like knowledge generator like us, R&D establishment, maybe can join together with and able to bring a kind of design advisory for additive manufacturing.
Yeah.
I think that is
Good
kind of
idea.
possibilities could be
Sir, that's a
explored.
great point. That's a
Yeah.
great point, sir. Yeah.
Maybe I will be happy in case if like means ANSYS or any other design pack, but basically who handles the data geometry
Yeah.
on the
Yeah.
I think we can able to work out.
Yeah, and we are ready here, sir, to help the industry as we have partnered with various institutes and academia and research, including
Looking
ARI.
at Indian company, so having a expert in all the manufacturing process of additive manufacturing And also, in addition to the product design, I think almost it is unrealistic. Maybe this kind of advisory, if we can have it, maybe people will use it as a guideline. It's not necessary as to do, because the reason is we don't have standardization today.
Yeah.
It's not like I have ISO standard, I can go and take the data
Yeah.
from there. That is not.
Correct, sir.
And
And sir,
CMT has
again,
CMT has an expertise, because even today, CMT design and data book is the Bible people are using for designing a mechanical system. And maybe similarly, if you can able to do it that into the digital platform on, this is specific to additive, but I want to do it on even digitizing our own CMT and data book.
Yeah. And sir, again, I would like to thank you, because your presentation was a foundation, and I picked up a lot of things from that, and was very, very valuable. Yeah.
Thank you, sir. No, it's like a mutual learning, right?
Yeah.
Yes.
Yeah,
Thank you very much.
Okay.
Yeah. Also, there are some questions posted by some respondents here. So, it is what are the professional bodies for 3D printing in India? Is what is asked by one gentleman.
Doctor, you can answer this. Maybe I may not have the right.
Maybe I don't
Yeah,
know
I
if
think
I
Dr.
understand.
Naga, yeah. Please, sir.
Yeah, what I understood from Jaideep, I think Jaideep is the delegate. Professional body means if it is an association, yes, there is a Additive Manufacturing Society of India is there, that is located in Bangalore. Earlier, it was a RPI, Rapid Prototyping Society of India was there. I think it is now defunct. And also some associations that created a chapter on 3D printing. If that is the kind of, but as of now, at least I am not aware any association bodies gives like kind of fellowships and all. That scheme is yet not there in India, at least. Globally, yes, there are several virtual forums are there. One can always exchange, share an idea. These are all like voluntary forums are there. So additive manufacturers forum like that. But as of now, professional body means only AMSI, I'm aware. And now I think 3D Graphy is another. So this is started. I think this is also, I think, if I'm correct, this is also one of the purpose, connecting the people who are additive manufactured professionals are interested who is into this. I hope that must have answered Jaideep. If you have any specific, you can write to me.
Yeah. And also, Doctor, he did mention that earlier in your presentation that he was actually, his query was, can composite materials be manufactured by this method? As in with
Yes, that's what I'm saying. I think bimetallic, the reason is this is allows a selective, that is the beauty of additive. So selective functionalization can be done on the matrix level. Right. But at the same time, it's not like that as easy as what we said, but technology for allows. You can make it. The only thing is, yes, there are challenges like you need to have a multi-jet, for example, if it is a powder feeder kind of things system, you should have a multi-jet kind of mechanism. So respective material gets fused into different, like typically matrix material and the ingredient material has to be fed and energized by the source, whatever you use, laser or ion beam. But it is doable. Our CMTI, my colleagues have done some work. So works.
Great. Thank you, sir. Thank you so much, sir. Now, may I now invite Satyash Kumar, who is a technical specialist with Statusys. Now, Statusys also is a company dealing in 3D printers for many years now. A company is based in Israel and now actively also been in business in India for almost a decade and more. Satish, over to your presentation, Satish. Thank you so much.
Good morning, good afternoon, and thanks, Shibu, for this forum, actually. And we are very happy to be engaged with this forum and to meet with all the intellectuals of this automotive experts and also from the same 3D forum batch who have been sharing the same stage with the different technologies and different solutions. So shall I start my content of sharing?
Yeah,
Shibu?
you can load your presentation and we can start. Yeah.
Sure. Sharing. Can you please screen share? Yeah, I got the content now. Okay. So hope everyone can see my screen.
Yes.
Okay. Okay. So this is actually the content which I want to show about what is happening right now in the forum, especially in the automotive industries. Actually, right now we can see a lot of buzz about in the 3D printing industries in each verticals, and very specific in the automotive industries, a lot of innovations are keep happening into that one. And we are very happy to share that we are also part of the event that we are supporting in this automotive verticals through strategies. So we want to share about some of those updates into that one. So why, first of all, we want to share about this is actually, if you see from this one, we have been supporting our automotive clients in all the aspects of every application. So why it is primarily because there are many kind of possibilities with the additive where people can able to take it from proto to all the production possibilities with other right now the existing solution. And right now, just before I was joining, people also talking about the composites. There are a lot of innovations happening in materials and a lot of things happening in the software. So through this kind of a things, actually, it's kind of a link chain, a hardware and software and kind of a materials. So people can able to advance their applications compared to the early phase of 5 years before people would only focused on proto. Now they are taking to an end application also. So who are they doing? If you look into that one, we have kind of an automotive giants. Everybody who is from are our customers in globally and also in India. So we can name it from Maruti, from Hero, and also from Skoda, TVS, even in the two-wheeler segment like Royal Enfield. Everybody want to take these things to the edge of the technology to get benefit in the way how they can able to create their part developments. So one quick thing, what people like kind of a things like JLR, Land Rover, they are doing into that one. So in the part of their prototyping, they want to really advance kind of capability to show to their team what their products can able to do into that one. So everybody know about this product called Defender, actually one of the very well known for in that kind of an beautiful SUV premium market. They created this car and they want to showcase the real capability of them. So they've been working with kind of a BBC Top Gear. So they want to show that SUV can go in all the mediums into that one. They want to show the real aspect. So they really take a scale down model of this one. So to take it for that one. So why the scale down model? Because even in the industrial design studios, everybody in their kind of a mock-up designs, they want to work out in their design creative process. They want to understand how this product looks. The same thing also done by JLR actually, and they used our technology within kind of with a called Polyjet, a very well known which can able to create multi-material, multi-color, and multi-shot 3D printer into that one. So they really mimic that entire Defender parts and they displaced for their showcase, and the same thing they used within their industrial design team also to look on for how they can able to create a scaled down model for management and also for the marketing models into that one. Is it limited only to a small size? No. If I'm talking about similarly with our customers in Ashok Leyland, they use same our FDM as a technology they are using for proto. So with this time, actually, if you can see that one, how they can able to go from 90 days to just 147 hours. Actually, it's a huge reduction for an automotive because everybody in the automotive team want to be an agile in their way of working. They want to skew their testing time. They want to bring as quick to kind of a product to the market. So they really this helps in the form of fit form function, and also it helps them in the way of functional testing. And here actually our FDM technology with kind of a thermoplastic materials are very durable. They can use it for proto and they can use it for product testing also into that one. Similarly, our customers in Audi, so they want to also have kind of a prototyping evaluation with the different kind of a lighting applications. They are using our technology. So in these lighting applications, they are using with as real close to the colors they can able to bring into that, because this is one of the biggest challenge in the automotive industries. How quickly we can able to get a realistic colors that we can able to get kind of a product realism. So they also uses our polyjet technology into that one, where they can able to mimic the entire designs, because here they are not only just doing a fit form function. This helps them in evaluating their colors and also make the design decision that helps them to make their advancement in the product design cycle. So whatever you see, this kind of a full translucent light and also kind of a full transparent part, it is easily can able to doable with our polyjet technology. You can able to adjust all the level of transparency. You can able to create a multiple level of translucency also you can control into this one. And is it only one color? No, you have kind of a limitless possibilities you can do with this one. And that is the beauty of this technology. So you can adjust the level of transparency. You can adjust the level of like amber color or kind of an orange color. If you want to do it for an indicator like transition light, tail lamp light, everything is possible into that one at a very easy single click button, which will do all the thing. So just I give you a glimpse what is happening in the area of prototyping. So if you see from a tooling application, because this is one of the core right now, every manufacturing team want to advance their product development. So here also, if you look into that, we have a lot of advancement, especially in the jigs and fixtures, how we can able to make lightweighting. Everybody industry is talking about smart manufacturing and industry 4.0, and we are truly making through our advanced enterprise connected software where you can also do with MT Connect, and you can able to do advancement in the way of lightweighting. A single click button which helps you to do directly an entire part in a honeycomb structure. So this easy the way of user can able to look in lightweighting. And wherever you need a strength and wherever you want to add a metal insert, because if you see these kind of parts, people already moved from steel to aluminum. Now they move from aluminum to a lightweight FDM parts for their durable application in the shop floor requirements. This is an example in India from Honda when we work with Mr. Talib on our plant operation head earlier in that Honda. So he gives us a challenge how we can able to go from steel to kind of an FDM parts. So these parts right now made in Honda Amaze all are transformed into FDM parts. These are close to 1 meter size actually. So they get not only just a weight reduction but also the cost reduction, and it simplifies the way when they move from one product variant to another product variant. So just an easiness of the way that you can able to move the level, we have made that fixture entire way customizable. So that is how it has been really helped them even in the cost reduction and easy handling for all the operators, because the weight reduction is also made close to 50 to 60% in most of the cases in it. So many things actually right now we are evolving in tooling. So but nowadays actually people want to go for an advanced level. So once upon a time every car is actually made in a very common design, but nowadays people want to advance in their way of their mass customization going into that one. What we're doing is actually when we work with BMW, so this is a thing called side scuttle plate actually. So right now people can order the side scuttle plate based on their family name or girlfriend name, and they can select their own colors, and this completely made in polyjet technology, and it is going into an end to the customers. So you can able to customize all the requirements, and it is going to within kind of an area which you can able to work out in the direct environment like sunlight. It will work in the rain, everything into that one. So that is a level of advancement people will going for right now in the mass customization. And similarly all our FDM parts already people are using in other automotives and also in aerospace application, which known for it already. 3D printing is the near future right now. People are using right now. No need to take it into that one. And now continuously exploration in the way of advancement materials, and also in the way how we have been innovating with the software solutions. Right now we are taking it to the things how easily it can able to make it for mass customization, and how people can able to use it for spare parts replacement also. So just to that one. So this industry is right now in agile actually. People need to make it everything quicker. So where we can able to get that solution, so Stratasys is there to provide such solution into that one. So we are the world leader in this 3D printing technology, and we have been 30 years of this industry, innovative continuously and making our technology forefront to our customers, so they can able to make their proto parts or tooling and end use parts in that way. So for this continuum of application and technologies, we have all the product life cycles from design to engineering and manufacturing and production grade solution. And recently also we have launched some of the new technologies and some high performance materials, like some of them can able to go to a temperature of 300 degrees Celsius in an end requirement, and very specific to a first requirement called flame, smoke and toxic resistance materials, and well known able to cater in the area of high impact load. All of them is a part of our kind of innovations for our customers we are taking into the automotive ecosystem. So with this, I can able to take up some questions to the team.
Yeah, thank you so much, Satish. for the presentation. And what we will do is we will like to go into the next speaker. Subsequent to this session, maybe we can also take questions while people would also want to post their questions.
Okay.
Please be around. Thank you, sir.
Thank you.
So may I now invite Avinash Ibrahim, who is the regional manager with Materialize. Materialize also is in the business of software and being a regular form of software that they've been able to design as with their expertise for design to then also for modeling and also for conversion in terms of STL. So may I invite Avinash to start his presentation. Thank you, Avinash.
Hi, thank you so much, Shibu. I'm just trying to share my presentation. Just let me know if you can. So thank you so much, Dr. Shibu, for this platform, a consortium where all the technology leaders can share their experiences of what we've been innovating until now, and then bring together one place where we can actually speak about manufacturing and its challenges. So I'll keep it very short, where through my short time, I'll speak a little bit about what Materialize is and what we do. A couple of case studies very specific to automobile industry of how Materialize has collaborated with a couple of industry giants in helping them design additive manufacturing parts or into their tooling industry, and what you can expect from a company like Materialize, and then probably summarize on what we have discussed. So getting into what Materialize stands for, we have been empowering meaningful 3D printing applications since 1990. I think we can proudly say that Materialize has been one of the only companies who has been giving out software solutions focused only on additive manufacturing. So we are exclusively out and out only for additive manufacturing. A quick look at our global presence, and also I work out of India, Bangalore, handling the India-specific requirements for additive manufacturing and how Materialize can address those issues. Right. Materialize software, our penetration into the market in the last 30 years, Materialize software has been used in about 75 countries plus. If we look at the AM system manufacturers, about 92% of the largest metal AM system manufacturers use our software. If we look at the Fortune Global 500 companies in automotive sector, 85% of it is our market share. If we look at the industrial AM system manufacturers, we are at about 68%. And then the top 20 companies of the Fortune Global 500 use Materialize software already. Looking at our partners here, we work with all the additive manufacturing pioneers who have been making printers and then adding value and technology to the additive manufacturing segment. Here, how we partner with these additive manufacturing printers is something that I would like to touch base upon a little bit, where if we see any of these companies that we are looking at, we not only team up with them in giving up just the off-the-shelf product that we have, but then we also give them build processes, which are the slicing software, which is very specific and customized for their printer parameters and the material that they would want to print using their printers. So we've gone a few steps ahead and then partnered with each of these companies to give a customized solution through their printers. So diving into the couple of case studies that Materialize has worked along with the automotive companies. Before that, just to put a perspective on the automotive industry and then a few statements from large companies that probably we should take notice on. One by GE in the State of Automotive magazine says automotive industry is entering a period of intense change. Over the next few years, what has been known as the automotive industry will come to be known more broadly as the mobility industry. The next generation of products and services enabling the transportation of people and goods, combined with new technologies in material and digital sciences and business models such as ride sharing and shared ownership. Another perspective from Merrill Lynch, which is an investment bank company from America. On an average, between 96 to 2015, the industry replaced about 16% of its volume each year with new models. At this rate, the industry turns over its entire model line about every 6.3 years. Over the next 4 years, we expect the annual replacement rate will trend higher at about 20%. All the automotive OEMs with the highest replacement rate and youngest showroom age relative to the industry have generally gained market share. I think this kind of summarizes the speed or the rate at which the automotive industry needs change and how the parts need to be replaced, the designs need to be replaced. I think these are points which Mr. Dr. Nagahanumayaji, Mr. Rafiq, and Mr. Satish kind of very extensively laid a platform about what the drivers of additive manufacturing are, what the challenges of additive manufacturing currently are in India, very specifically, and then where we need to address these kind of challenges and how we can not only look at it as a place where we've hit a plateau in manufacturing, but then take a higher stance in achieving the efficiency that additive manufacturing offers to the industry. So looking at one of the case studies that Materialize has worked with, this is a company called InMotion Automotive. Here we've helped develop and design and print a titanium part, which is a wishbone or a Y joint. So if you can see the part there on the bottom left, that's the Y joint which has been printed using titanium. We have helped them. We have a team of design engineers who help in design for additive manufacturing. We work together with the company in getting the part consolidation done, where a couple of parts had been consolidated into one assembly. So to give a little more detail on what software has been used, we've used Materialize Magics, which has ensured the print is successful by creating proper supports. How did we create the supports? We've used cone supports for better heat dissipation. Support generation is not only to hold the orientation of the part, but then also to dissipate the heat that is generated while printing. Perforations are used to allow easier removal of supports. I think Mr. Rafiq also mentioned how difficult it is to remove parts supports after printing. So there has been quite a lot of advancement that we have done in terms of our software giving out supports which can be easily removable, and then it would not affect the surface quality of the part, which in the later slides, I will show you a few slides and maybe a video which shows how supports are created without affecting the surface quality of the part. And then we've used angled supports to improve the surface quality by reducing the contact points of the surfaces. Our design engineering team also used a software called 3Matic, which is Materialize 3Matic, which is a post-topology optimization software. Using this software, we have used lightweight structures which are self-supporting internally. This is an advancement where, to avoid loose powder to be trapped between lattices, these self-supporting lightweight structures are specifically designed by using an algorithm which is complicated but then available for all the additive manufacturing enthusiasts to be used through our 3Matic software. So if we see the entire product line or the manufacturing line, we have used Materialize software in preparing the files for printing, and then the post-processing has been done by InMotion themselves to get the accurate tolerances that are needed for the assembly, and then you can see the assembly at the end, which is the final intention of the part. Looking at another case study that we have done with Volvo Car Ghent, which is a subsidiary of Volvo in Belgium. So we are looking at logo gluing fixtures, which is more into a tooling domain. So a bit about Volvo Ghent, they have an assembly line of the Volvo. I think these cars also are pretty visible in our Indian market on Indian roads as well. So their capacity is at about 270,000 cars a year, approximately about 5,000 employees, and like I said, it's part of the Volvo group. So looking at what we actually help them work out, this is a fixture to apply logos on the trunk of the car. And then it needs a few specifications where it has to be aligned properly according to the brand standard. And they've had different options to be available. The component requirement, which is quite obvious in itself, where the alignment is of prime importance. And then the repeatability, because when we see about 270,000 cars assembled a year, repeatability is a key there. And then the finish, no marks on the paint. If we look at the image here, this is the original design which Volvo was working on. It's a complete metal-based fixture. So if we look at a little more details, it is an aluminum welded frame. It was milled logo parts. It had milled position points. So the customer requirement was they wanted to improve the accuracy, they wanted to reduce weight, decrease cost, and lead time. I think these are the basic drivers of additive manufacturing, which my distinguished previous speakers have very emphatically emphasized upon, where AM will come into picture. This is the image of the new design which our design engineers worked along with the team of Volvo and helped them overcome their requirements. So if we see the solution in detail as to what specifications went into it, we used PA connectors with integrated gluing channels. We used ABS pads covered with leather and the POM, which is the mill positioning points. The technology we used was laser sintering and FDM. The materials used is PA, ABS, and carbon tubes. The finishing, we used color dyeing and assembly. I think these are very interesting examples which could encourage OEMs to start thinking about DFAM, which Dr. Nagamaji has been very clearly putting across, that the product development needs to be thinking more on how to design the part, keeping the design for additive manufacturing principles in mind. And design for additive manufacturing principles in itself has to be a subject. I think a couple of attendees have been also speaking about how it can be, a part of the undergraduate and the postgraduate programs. Materialize as a company, as I'm handling the India market, we've been very actively working a lot with all the engineering colleges, including the IITs and the NITs, to see how we can actually partner and then position an industry software where the candidates that are coming out not only understand DFAM principles, but also the software tools that are needed as a prerequisite as a plug-and play and to deliver to the industry. So we look at the results of this additively manufactured fixture. There has been a 0.2 mm accuracy, a 64% weight reduction, 48% cost reduction, and a 67% lead time reduction. These are amazing results which Volvo has seen, and then it has trickled down into their entire assembly line, which has given them a lot of cost benefit. So getting into what you can expect from Materialize. Materialize is split into 3 verticals. We innovate in our software. We provide manufacturing services. We have close to about 200 plus 3D printers based in our Belgium office, more than about 30 metal printers only in our German office. And then we provide additive manufacturing services and print parts for the entire industry in the European market. We have another very dear vertical of ours, which is Materialize Medical, where we are making a healthier and a better world through additive manufacturing. But here, I would be focusing more on the Materialize software portion of it for the India market. Materialize Magix is our flagship software, which has been a base for all the printers or the 3D printers that you can see across the world. Very important or a very unique feature is Materialize software is machine agnostic. No matter what technology you're working on, Materialize Magix can help you prepare the files. Where Materialize Magix comes into picture, we are bridging the gap between the CAD files and the 3D printers. There is the STL that needs to be the standard triangular language file format, which is the base input for our printers. If we understand STL and then why Magix is important, just to get into a little bit of a detail, the CAD format's basic is a hexagon, a pixel is a hexagon. And then when that is imported into a printer as an STL, the hexagons are converted into standard triangles. So during that change, there is a lot of inner triangles and then upskins and downskins that are created because of this change. This bad STL can affect the print quality to a very large extent, where the drivers of AM are completely based on time and cost, which is very crucial. Materialize Magix comes into picture where you are converting all these bad STLs and correcting all these STLs with just a push of a button. Materialize has been one of the forefront softwares where Magix has been used extensively, where we have auto fix tool, where you don't have to spend a few minutes as well, and you get out a superb STL to be printed. Like I mentioned, no matter which printer you have and which 3D printing technology, Materialize software and our R&D, where we are coming up with our innovations every year, the future will be favorable. Materialize has been working on a mission statement where we help our customers take full control of data preparation. Like I said, we have one of the most powerful data preparation software, where we cater to the entire process flow. We import the data, we repair it, enhance and edit the files, we prepare the build, export it into the parameters, the slicing software that I mentioned earlier, to any kind of printer, and then we have the quality control devices as well. Maybe instead of me just talking about it, I have a short video where all these phases can be shown through the actual software. This is a quick video where it shows all the modules of Magix, where the STL repair, functioning, simulation, slicing, and the automatic support generation. We've tried to cover a very extensive topic in a couple of minutes video. If any of the points in the video are interesting to you, please reach out to me. My details are on the end side. I'm trying to play the video. Hope it works. Great. I hope that video was interesting. There are a couple of points which I want to emphasize on from the video, where we saw support generation, which is available with Materialize Magix as a software and its module. But then there was a short description where we created supports with Magix, and then the support generation module in Magix. And then we created support generation with eStage for Metal. eStage for Metal has an advanced algorithm where it automatically creates supports, but then the advantage here is the support connections. We have something called as a toothpick kind of supports that are created, which are very easy to remove, where you can use your bare hands to remove the supports that are created using eStage for Metal supports. Where eStage for Metal, like I mentioned, we have a 3D printing metal division in Germany, where we have about 30 plus printers working out on various industry requirements in printing out parts. eStage for Metal was used by our team in Germany, Bremen, and then these are the results that we have internally seen, where there was a decrease of 90% in the data preparation time. We have decreased our powder consumption by 20%. and then 50% of decrease in the support removal time in itself. If you see all these things, the common denominator is not only time but also the cost that is involved in it, which is a very core driver of additive manufacturing. We also spoke a little bit or showed a little bit about the simulation module, which can help you understand if a build is failing or is it successful, where the heat concentration is happening, where you would need to use supports for that heat dissipation. That is also available as part of this single platform, Materialize Magics. So all these modules that we've shown you, you must have noticed that everything is formed under one single user interface. So once you have Materialize on board on your system, you don't have to move across computers or systems or teams, but then a single engineer can work on a single user-friendly interface and move across or glide through all the modules that are available from the beginning to the end of the entire AM process chain. So summarizing a bit about what we have discussed right now, Materialize is just not a software package. We are an open platform, like I mentioned. One license which is compatible with all technologies. So we are scalable platform from design to production, one-stop solution to all your additive manufacturing needs. Like I mentioned, there are all these extra modules depending on the complexity of additive manufacturing phase that your organization is moving through. At each complexity of the phase, Materialize modules will be there to handhold you through that complexity and have the efficiency that you would need from your own design requirements or the requirements of the customers that you're serving. Like I mentioned, we are one of the most powerful software tools that are available with high precision. And then we have a proven track record, which is very evident from the kind of industry partners that we already have across the world. So with that, I finish my presentation. Thank you so much for your attention. My details are here. If you find something interesting, please feel free to reach out to me. Thank you.
Thank you so much, Avinash. The video was very interestingly, shown. As in, it's a very user-friendly platform that you have been able to make. For what I also know about Materialize Suite, I mean, it is really convenient for even students or engineers looking at getting the best solutions found through the technology. I think very interesting. So we will have questions if there is any, because we still have time. Though we are actually we've scheduled for lunch from 1 to 1:30. As we progress, the questions can be posted by the participants here. We've seen respondents coming live, and then so we can have these questions posted on the platform, and we will definitely want to respond to each of these questions as we progress to the day. And also, interestingly, now the next session would be actually on. It will be very technical. It will actually cover a lot of aspects when it comes to 3D technology in metal and polymers, and also software solutions and experts, the same that we had now in the morning with Rafiq, and also Avinash share their bit in terms of what software solutions and simulations can do. And it's a very integral part of additive manufacturing as a value chain. So I think that would be interesting. And then towards the end would be also a panel discussion. We are very happy and to introduce ARAI, who happens to be also our industrial association partner, and also CMTI, coming from the technical innovation side in terms of having been able to contribute their efforts in terms of indigenously also manufacturing these machines. So many of them would be sharing that in the second session. So we will take a break now, and we will join at 1:30 sharp for the first session. We will have the first presenter, Fedor Atono. So thank you so much. And then subsequently after that would be all the other sessions to follow. Thank you, ladies and gentlemen. Now we'll break for lunch, and then we will be joining by 1:30. Thank you so much. Yeah, ladies and gentlemen, sure, with a very sumptuous meal, you are all back, and we can see respondents live coming. So we are very happy to know that we have actually have some 200 respondents join in today to actually be a part of this session to understand and learn how this technology can help and benefit the automotive industry at large. So for many of you who had not joined in the morning, let me update you that we had a very good session in the morning. We had an inauguration of the 3D Graphy News online portal, which is now going to be substantiating its effort in terms of promoting 3D technology in the country and also globally. And we had the chief guest, Dr. S. Chandrasekhar, who is also one of the key respondents for industry vertical for the Coimbatore Chambers of Commerce, who also wanted to understand how 3D printing technology can be of a technology which can be a part of the other technologies like machining and the others. So I think it's a good time that we are all in, and it's a great privilege to invite Fedor Antovo, who is actually the CEO and one of the main, champions of composite fiber, 3D composite fiber, and his company by the name. And I think it will be very exciting because morning we had a discussion on various new technologies like metal and resin, and also software solutions by ANSYS and Materialize, and also Stratasys, sharing their insights a bit, and also CMTI, which is an indigenous manufacturing company run by them as a part of the Ministry of Heavy Industries. So I think there's a great prospect. So thank you so much, Fedor, and we'll start your presentation to begin with your slides, and then we take
Thank you,
us
Dr.
through.
Shiba. Yeah, it's a great pleasure to me to participate in this event, and thanks for the opportunity to share knowledge about what we do at Anisoprint and to share it to such a knowledgeable audience. It's a great pleasure to me. Thank you again. So what I'm going to talk about is 3D printing of composite materials and structures to manufacture lightweight, flexible way and sustainable complex shape composite material parts. My name is Fedor Antonov. I am CEO of Anisoprint, where we are developing this 3D printing technology. So what's it about and what's the problem behind the technology that we are offering? Basically, there is a huge demand for in manufacturing for both lightweighting, it's an obviously an important trend, and flexibility of manufacturing. So there are modern technology approaches, technological trends such as 3D printing, which bring this on-demand, digital, fully automated manufacturing approach, revolutionizing the manufacturing the way we do it today. And on the other hand, there are composite materials that are most high performance among all other structural materials, providing high strength and lightweight for critical end-use parts. And the idea is, if we unite these both worlds, the strong and lightweight composites with flexibility of 3D printing, and also flavor it with the simulation and generative design approaches for designing optimized parts and structures, we will have as a synergetic solution that we call anisoprinting. Basically, what is it? How the technology looks, how it works. It's a material extrusion technology. So in this regards, it's quite similar to extrusion, to material extrusion 3D printing technologies such as FDM or so. But the main difference is that it's actually a co-extrusion. So there are two materials extruded simultaneously. One is thermoplastic polymer, and a second one is a continuous reinforcing fiber. It can be carbon, it can be glass, it can be any other structural fiber. And during the process, fiber is extruded together with the thermoplastic. Thermoplastic in this case serves as a binder, and the fiber itself gives high strength and high stiffness to the material that we print. This is how it works in a few words. And with this approach, we can get a composite material with of a very high quality. So it means the material has low porosity, high fiber volume content for higher properties, good bonding between reinforcing elements and metrics. The 3D printing approach gives us a lot of flexibility for complexity and freedom, so we can really manufacture complex shapes with tailored fiber trajectories, fiber steering, complex 3D geometries, and so on. We can use different thermoplastic polymers as a matrix material, so it means that we can reinforce different polymers with high strength fibers, and the choice is virtually anything. So from classical modeling, PLA or ABS, to engineering PE, PC, and even high temperature polymers such as PI, PEEK, and so on can be reinforced with continuous fibers. And another important feature about the co-extrusion technology that it actually allows to manufacture complex optimized structures such as fiber reinforced lattices, which gives a lot of flexibility for design and optimization by varying the density of the lattice and the directionality. We have several solutions which are based on this composite fiber co-extrusion technology. And when I say solution, it means it's several components in there. So it's hardware, basically 3D printers, and it's software, so slicer or toolpath generation software for continuous fibers, for continuous fiber placement, for choosing different reinforcing schemes and patterns, and obviously materials, so fibers and polymers. In hardware, we offer desktop systems, so that are fairly small extrusion machines, easy to use and tunable, which allow to print continuous fiber reinforced composites that are 30 times stronger than pure plastics, and at the same time 2 times stronger and 2 times lighter than aerospace grade aluminum alloys. The machines are actually available in 2 formats, A4 and A3, similar to the paper size. It's an open material system, so any polymer can be used for co-extrusion, for reinforcing by fibers, and you can really manufacture optimized composite structures by using the software that is provided together with the machines. And for the desktop machines, the most important applications are in research and development and functional prototyping. So that's not sort of a classical prototyping, which is mostly for assembly purposes, but functional prototyping, where you can really make prototypes that operate in real environments. And it also can be used for manufacturing of tools, jigs, and fixtures, spare parts, and other low quantity applications, low volume applications. We also have an industrial solution which has a much larger build volume. It has a heated chamber, so it can print with high temperature polymers such as PEEK, PEG, and PI. And it's based on industrial motion control, industrial CNC, so it's really built for 24/7 production run. It has much higher productivity. So the main applications is small batch production of end-use parts for different industries, for different high-tech industries such as aerospace, energy, or automotive, manufacturing of spare parts on site, and rapid production of tools, jigs, and fixtures. We have several material options available for both desktop and industrial, which include reinforcing fibers. For desktop, it's either carbon or basalt, and a certain range of polymers that we offer. For industrial, we have both high temperature, so based on high temperature polymers, fibers, and low temperature ones, and a variety of plastic polymers available. With carbon and basalt fibers, they have very high strength and stiffness properties, as you can see, comparable to high strength steel, and stronger and several times lighter than titanium, for example. We also have polymer materials that are used for co-extrusion and just FDM polymer extrusion printing on this machine for better compatibility with fiber and for achieving good tolerance and surface quality. So this is how the print head, the core of the system looks like. It's actually a dual nozzle. So one nozzle, which is on the right, is for printing with co-extrusion with fiber reinforcing, and the left nozzle is used for printing with just polymer, as in a simple FDM machine. As I said, we also have software. It's a slicer which supports different CAD formats, and it offers a variety of settings, so up to more than 300 settings for adjusting temperature, print speed, and layer structure scheme, and many others. So that's about the solution. Now we quickly go to several important use cases. So what kind of parts we can actually print, and what are the benefits compared to other technologies or traditional manufacturing technologies. So this is one of the example from automotive industry, not mass scale automotive, but it's a race car use case for 3D printing a race car pedal with complex composite fiber reinforcement, and the benefits that we get compared to a classic CNC milled metal is almost 3 times weight savings and about 50% cost savings compared to a milling analog. This is another example from, let's say, a mobility segment. It's a rocker for downhill bike, and here we can also have, due to the complexity of the design and optimization, we have significant weight and cost savings, as you can see on the slide. One of the interesting applications for the technology is actually tools, jigs, and fixtures, and here's one of the use cases from that niche is soft jaws for turning, which are optimized for the part that is being machined. They are soft jaws, so they do not damage the part, and they are very easily and simply manufactured on site and on demand on the shop floor. And one more example of like complex shape and lightweight parts is a leg for an autonomous robot, where you can also see more than 3 times weight savings compared to metal part and significant cost savings. So now, just to finish my speech, I will give a few examples where this technology can be applied in automotive industry, to which kind of parts and structures where this technology can give significant benefits in terms of weight and cost savings. So obviously it's lightweight components for electrical vehicles and for sports vehicles, so for high performance cars such as powertrains, transmissions, seat frames. So all this complex shape medium scale parts. It's lightweight suspension components, because suspension is where weight really matters for the unsuspended mass, such as links, bars, rods, mounts, arms. So all these kind of complex shaped parts can be really printed and made several times lighter compared to metal, to classical metal analogs. And one of the most interesting applications is actually also unsuspended mass parts, such as wheel discs and wheel hubs for sports and racing cars, where you can really get lightweight and cost-efficient solutions by using composite 3D printing. So thank you for your attention. I don't know if the Q&A is assumed in this session, but if yes, then I'm ready to answer your questions. If not, I'm always available to do so through my contacts that you can see. You have my email, and in case you have any questions, you are most welcome to ask. Thank you again.
Yeah, thank you so much, Fedor. I think a very slim and a spick and span in terms of presentation that you had made, but it was full of content in terms of the value that you have to offer. So, interestingly, Fedor, you will also be joining the the evening panel discussion, and I'm sure there'll be a lot of discussion around and various questions to be answered. Uh, as the lunch is over, people are just joining in, so they're just settling down. But
Okay.
interestingly, what we'll also have is we have the auto industry respondents also joining in, and I have the privilege of inviting Mr. Vijay Pankhawala, who is also the deputy director from ARAI, one of the leading registered institutions and research institutions for automotive, which is by the name Automotive Research Association of India, and the team has also joined this event. So I think he will also want to gain a lot of traction and understand in the course, and he's also moderating the session, Fedor, where he'll
Okay.
also be speaking. Yeah. So I think with all the other technologists and technology experts and researchers and material scientists, there is one more research center by the name RRACAT. They've been doing a lot of research on material science and materials and machines. So it'll be interesting. So, but in the meantime, what we'll do is we're ensuring that we stick on time, just because every session is for 20 minutes. We will continue with this session, and then so please be around. And in the
Okay.
evening, once all the sessions are over, it will be a great learning. And we'll also have a panel discussion wherein respondents will be open for questions also. And I think it will be a great meet in the evening eventually as we progress. So please stay around, Fedor. Thank you so much for your presentation.
Sure.
And let me now invite our next speaker, Rajesh, who is a key respondent. Rajesh was there in the morning in our inaugural. So Rajesh, thank you so much for your participation and to also share what Monotech 3D has to offer. For what I know is there's a huge Pandora of technologies that, and with a profile portfolio that you have to offer. I'm sure every technology has its own gains in terms of how it can benefit the sector. But yeah, so over to you, Rajesh. Thank you so much for your time.
Sure. Thank you, Dr. Shibu, and thank you for giving me this opportunity. I hope my audio is clear.
Yeah, you're very clear. Yeah, you're very clear.
Okay. So I'll just share my screen, and I was not able to today give a introduction of myself today in the morning, but I will surely do it now. Is it in presentation mode now? It's fine.
Yeah, it is, Rajesh. Thank you so much.
Okay, great. Thank you so much. So I welcome all of you to this 3D Graphy session. And since morning, I've been hearing out the advisory and the speakers, about how these technologies are being, implemented for the automotive industry, and for various sectors. Of course, we have been talking about various sectors throughout, and I guess automotive is a very interesting field because it is one of the most organized sector, I would say, and hence it becomes more difficult for any new technology to bring in anything new into that. Well, we have seen a lot of success initially with prototyping, but probably going forward, we are looking at manufacturing. So how do we help the automotive industry with the manufacturing technologies which we have? So I will just rush through these points where we will just go about talking about the transformation journey. So we all know that the industry is transforming from industry 3.0 to 4.0, and automotive will be the first to get into that. Somehow, I would say that India, we are still in the third generation where still the automation and robotics is still being implemented. But with a lot of initiative of Indian government to manufacturing India, develop in India, we have a very good chance of getting into the fourth revolution using digitization and additive manufacturing and few other requirements of industry 4.0. If we just look at the additive manufacturing industry journey over a period of time, probably since it was since 1986, it was the SLA technology was invented. As we go forward, we can see that there are certain applications which are moving forward, and as of 2021, we see that when certain end-use parts replacing the traditional methodology is really gaining, and it has come to the plateau of productivity, and it's going beyond. So what something was in the disillusionment in 2017, say tooling and fixtures, today is moving towards the plateau of productivity, and it's going beyond, which means the technology, the materials, and the software, etc., are playing a very important role. And we have to see that how this can be utilized very well in the automotive industry. So why AM for automotive? Now it's we always talk about automotive to be part of the low volume, and prototyping and so on and so forth. But today we should be talking about why AM should be implemented in the manufacturing in terms of automotive. There are a string of reasons which I will go through. I call it as crossing the chasm between mass manufacturing and mass customization. So we are actually going towards mass customization, which is going to be the future. But we are in the mass manufacturing as of today. And believe it or not, maybe in the next decade, probably we'll be moving to even mass customization in the automotive manufacturing. I have a small video just to talk about what mass customization really means.
Hi there. When we're studying operations, we'll come across the term mass customization. So let's spend a couple of minutes looking at what's meant by it, the concept. There is a clue in the word, mass customization. It's about a production process that involves mass production techniques for the mass market. However, the key here is that the customization element enables the output to be tailored to a larger or lesser extent based on the specific requirements of the customer. So where did it all start? It's often said that Levi Strauss, with its original spin jeans, was perhaps the first, certainly one of the best known examples of mass customization. 20 years ago, they ran that for 5 or 6 years and then closed it down, but then relaunched mass customization, having learned the marketing lessons to launch Curve ID, which is its current program. You may have ordered or customized your own personal computer or laptop from the likes of Dell. Again, one of the pioneers of mass customization. And similarly, in the sports market, Nike have been a leader in customization, mass customization, for almost 20 years. You design what the product looks like. They then make it to that exact specification and then keep you informed as your personalized product goes through the production process. But it's not just consumer products. Mass customization is increasingly being used in industrial or B2B contexts. A good example on the screen there, Danfoss, a Danish manufacturer that manufactures a world leader in the manufacture of mechanical drives, millions of them each year, but every single one of them is built to a specific customer order, and they then turn that round in just 24, 48 hours. And the greatest advantage of that is that they don't have to build drives for stock. All the drives are tailored to the specific customer requirements. And that hints, therefore, at some of the benefits of mass customization. The key is you're combining the benefits of mass production and economies of scale, therefore low unit costs, with a product that has elements of personalization and therefore potentially much greater value added from the customer point of view.
The perceived value is high, and therefore you may be able to charge a premium price for the customization options that are provided. You may not, but certainly the added value is strong. Clearly, if you do mass customization right and well and consistently well, it is a way of differentiating your offer from other mass market producers, because it's not easy to do well. And do it well, you may well build customer loyalty and brand strength. And as we saw with the Danfoss example, another benefit of mass customization is that as you're building products to order, you don't have to hold as much inventory in terms of finished goods, which has a cash flow benefit. So what do you need to make it work? Well, firstly, not every business can achieve mass customization. They firstly need to have mass production techniques, but they also need to have a really well organized and efficient supply chain. Mass customization is about very close integration and collaboration with suppliers. And it's also about leading use of digital technology, automation, as well as having fairly flexible production capability to be able to take that tailored customer order and allow it to flow through the production process in good time so that the customer isn't disappointed. But it's a fascinating concept, and that's just an overview of mass customization.
My presentation got stuck.
Hi there.
So we just saw that what mass customization means, and how this can be important going forward for even the automotive segment. I was listening to one of the YouTubes of Rahul Bajaj addressing a certain key. He was speaking on an event, when he said that the reason why they became number one was not that they made 10% difference from Hero Honda, but they made around 40% difference from them. Which means what they did was the value addition has to be minimum 30 to 40% of what currently is the the leader who is having it. So how do you make such differences? In the current scenario of the assemblies and the tight just-in-time networks which we have in the automotive, it's very difficult to make such a large difference, and hence customization is a very important key for this manufacturing. So while we see this is how we are looking at today for the manufacturing of automotives, it's a key network, and it's very complex in many ways. And even if one of these networks breaks, the supply chain is totally stopped, and then we are talking about a huge backlog, and then production stoppage, and so much of wastages. The flow can be digitized if we say that we can bring in digital libraries, and it can be digitalized. We can get in inventory, localized inventory inside. We can have supply chain which can be inside using additive manufacturing and digitization. So this way we are able to simplify the process of from the assessment up till supply and distribution. And considering that the supply points are closer to you, it's very easy to manage, and the critical operations are also managed very simply. When we talk about the top strategic fields of action, now there are certain reasons why automotive, I believe, and the world believes that automotive is going to get into customization. Because of e-mobility now, electric vehicles are coming up in a big way, and it is going to be like 18%, 36% of our cars sold. And as we see it, it is not as organized as the IC engine or diesel, manufacturers. It is more of ownership based, and it is also a lot of entrepreneurs. Startups have come in. They're developing different parts and even the whole cars, which means that they will go for customization, and that is going to be very difficult for the present industry to work with. Autonomous driving again is something which is new, and it is going to have a share of its of a market. Sharing economy is going to bring down the usage of utilization of personalized cars. Probably in the future generations may look at sharing economy. And manufacturing 4.0, which means that now the industries are to be made smart, which means the OEMs will expect the tier 1, tier 2s to be smart factories. and this also will have to be taken care of. And the workforce transition also, you can say that now, because there are so many opportunities in the market, people are not looking at production or just case what we talk about, the core production tooling system. They are all looking at new technologies and new way of working. And and we also talk about the carbon footprint in automotive, which is very high because of various factors, including supply chain, inventory, and so on and so forth. So we talk about how we can help with the additive manufacturing to reduce the overall carbon footprint. And based on the investigations of studies, there are 4 potential futures of OEMs. So OEMs can look forward to these futures in the future. They want to become a technology leader with a strong branding through massive investments and new business models. So we consider this as new business model for any OEMs. As such, it's not the similar way of approach, but it's a different way of approach. And achieve at least midterm stability of the market positions. And when the economies of scale are reversing, the volumes are going to come down. This is going to be a way of getting stability to your business. And then set up strategic partnerships with giants, IT giants, and also universities for technology transfers, and so on and so forth. So this helps us to get Make in India and Atmanirbhar Bharat into us. However, we see a lot of challenges, and this is what I want to bring forth here today. I am always open to talk about technology and what we deal with and all that, but it all remains that though we see a lot of movement in all other industries, there is a lot of challenge in automotive, where we only see that it is accepted only in the prototyping segment, and so we want to go beyond that. So there is a lot of challenge, and this is what we need to, through these forums, address and request institutes, universities, and also OEMs, and also like ARAI, to see how we can marry additive manufacturing with automotive segments. It is very important. uh, Moving to from the automotive industry to the 3D printing, as you all know that there has been a long history of additive manufacturing since 1980s, and as of today we see that there is a lot of investment into materials and also software. So these are all, the technologies are all matured now, and the development is in terms of materials and softwares. And seeing that the current position of the various industries with respect to 3D printing, we would say we can see that automotive is still in the medium, high to medium. So we talk about market growth is high, but the penetration is low, or it's in the medium stage, which means that we have to move from there to the final high market share, where it is going to be end use parts or in process requirements. As 3D Monotech, we believe in working in all the ranges of technologies and various stages. So when we talk about automotive, we can talk about exploratory prototyping. We have machines for that. We talk about even beyond prototyping, which is we are talking about shop floor tools, fixtures, gauges, and also molds, dies using 3D printing. And then we also can talk about producing direct parts, where few parts can be directly low volume can be utilized instead of injection molding and so on and so forth. You can actually 3D print. Now, the future growth of automotive, with AM is set to be quite high. It's steep, and we hope that this works, because very importantly, this will depend on how the market or how the automotive industry takes us up. And it's not just the OEM or the tier one, the tier 2, tier 3 industries also has to implement for various stages additive manufacturing. Only then we can see this sort of growth. And this growth is just not for the AM, it is also for the industry as such. And we have seen that there are a lot of factors which have driven the utilization of additive manufacturing. I have heard very many cases where during the corona period, there were designers who brought the machine home. They brought a 3D printer at their place, and they printed parts at their house to develop prototypes, because this was very crucial stage where they had to spend time on development and they could not stop. So 3D printing actually helped them that way. And this crisis has characterized the rhythm of economic cycles for centuries. You can see that innovations have always been regarded as essential instruments for adapting to a changing environment. But companies have to respond quickly, and though at that point of time we respond, but our response are slower after that. So we need to bring in some systems, like for example, National Strategy for Additive Manufacturing is a good initiative. National Center for Additive Manufacturing is a good initiative by the government. So this all will give sort of confidence to the industry that additive manufacturing is very much utilized, can be utilized. Presently, it is like in the spare parts for classic cars, where expensive cars you can the spares are being changed. But going forward, we are looking at mass production and also with respect to tools, fixtures, gauges. And 3D printing parts at remote locations is a lot of it saves a lot of supply chain, and also the carbon footprint is reduced by having it closer to the place of supply. And mass manufacturing of cars is something which EV, electric vehicles, we have seen some cars being printed, the outer chassis, and many other parts being printed. And even in EV, like bikes, we have seen that a lot of printing has been done. And very importantly, we normally seem to forget that inventories have always been a problem for the automotive industry, because it's so tight that the supply chains are so tight. Even if small disruption, it leads to a lot of problems, to the huge losses. And as per some estimates, it says that inventories constitute to more than 7% of the total liquidity of the company, which means if the inventories are coming down, you could actually reduce that 7%. And so investment into additive manufacturing is not a big deal, basically, if you see this way. And now let's look at the technologies which are in the maturity index. You can see that the metal technologies are mostly in the maturity index, while as the plastics are still in the prototyping and first application stage. So now again we talk about these. We start from prototyping, on-demand and distributed manufacturing to mass customization. So on reflection, the automotive industry must take its cue from the aerospace and defense industry. And I guess we should work on this. So I will just start with what we do at AM. So what are we doing, 3D Monotech? What do we do with respect to this industry? We have been in this for 6 years, and we have the complete range of technologies, right from concept models, functional prototypes, to rapid tooling and pre-production, end-use parts, and customization. So we can provide technology and solutions materials with respect to them. So as you can see, for prototyping, we use large machines which can print actually a bike, a complete bike, a chassis, and we can have multicolor products for evaluations. And if you take automotive industry, we have the technologies to print almost most of these prototypes. And we take about four-wheeler again. Most of the prototypes can be printed with our technologies which we have. And a few other parts, like from the largest to the smallest, with the most detailed parts, our technologies like DLP and few others can actually give you much detailed parts. And then we also work in the in-process, which is investment casting. As you saw in the morning in one of the presentations, investment casting is also not regarded much, but it is one of the major, very important solution. And for low volume practice, we have some few customers who are taking huge projects at very less timelines using these technologies. And then we talk about end-use applications with metals and few other plastics. This is a very important and interesting field where we are working with a lot of automotive companies, where we are providing them fixtures, soft jaws, and various assembly and use parts using composite technology and of course FDM. So composite, as you saw in the earlier, presentation, is basically it's a mixture of nylon plus carbon fiber. And in our case, we deal with Markforged, where they give this fiber reinforcement, which increases the strength of the parts much beyond even aluminum and steel. And this can get into a lot of
Hello.
applications.
हाँ शशि बोलो. No problem.
So a small case study of Markforged, where you get this. This is a quick tool which has been done, and it reads to 19x faster lead time with less than 2.6x cost savings. So these are all some very real-time examples which we have actually utilized them for. And then this is figure 4, which is from 3D Systems, which can actually give you low cost, and low volume injection molded parts just out of it, and very fast, which means in 12 hours you can actually print.
No, but they are not
in 6 hours you
permitting
could print around 150 molded parts.
pay only for 1 year for updating it to current, but they are only permitting you with 2 years.
Sarupji, can you please mute yourself, sir? Sarupji? Shibu, can you ask Sarupji to mute himself? Yeah. So we talk about hybrid systems where we print in metal and also have the composites on top of it, so that we can have an hybrid system where you lightweight the part, but at the area
For
of
license,
you can actually use metal for reducing the the wear and tear.
how many
And then we
licenses
talk
are
about
they giving?
fixtures
20 lakh?
and so on and so forth. So
But how many
we get into
license can you?
consultation where we can give you an actual feedback of if you use technology additive manufacturing, what could be the savings and what
So
you
for
can
all of
work
it
on.
put together, 25 plus 6,
And
31, they are asking 20 lakh, or what are they asking?
Shibu, am I audible?
So 35 plus 20, it is 52 lakh.
Yeah, you're audible, Rajesh.
Sarupji's voice is actually, can you hear him? Because I can hear him a lot.
Yeah, sorry. Yeah, please.
Mute. Yeah, thank you, Sarupji. Yeah, so hybrid manufacturing is the way to go right now today, because we talk about being in between mass manufacturing and mass customization. So we could utilize additive and machining or the conventional technology to help us with the the low cost and low volume production with near net shape parts being printed, and which can help us with going beyond the traditional manufacturing. And this is a small video which I would like to show, which is a gearbox housing and a heat exchanger which is being printed. This is a heat exchanger, and then you would see that there will be a gearbox which is printed. So this is a near net shape part which can be printed quickly within probably a few hours, and in the material, like it could be printed in stainless steel or any other material, and you could quickly take it for prototyping and fixture. And then and then we also talk about integration with robots and CNC machines, which can be a hybrid system for metal manufacturing. We can quickly get you a lot of tools, molds, or even to the repair jobs. And this is actually a very big boon to the industry, especially in the manufacturing industry, because it can reduce a lot of cost of doing away with old molds. You can actually do a lot of repair. And with metal, the other technologies like powder bed, we always talk about optimized lattice structures, which can lightweight, and then that can be utilized because of the cost of materials are high, and it cannot be compared with the conventional way of printing. As you can see, that subtractive, the less material remove, the fastest and cheapest is your process. But when we talk about additive manufacturing, it's the reverse, which means the less material you add, the fastest and cheapest is your process. So we have to move from one side of the coin to the other side. You have to move to the other side of the room and start working that way. And that's what the industry needs to see. And apart from that, we also have a few range vision scanners, which are for reverse engineering, non-touch, and that it can scan the whole vehicle, and also a few parts. And also we have handle scanners which can help you to quickly do some prototyping. Last fact about us, I'll end with this, that we are a 23-year-old company with 400 plus employees. We are in the 2D printing range with 23 years. 6 years back, we forayed into 3D printing. We are more like an integrator partners for our OEMs, where we provide support to the industry with respect to applications and design and various other supports which we give from our 15 plus locations. And we have 10 own brands, which means we also have our own 3D printing brand. We have our own FDM machine, which we have developed for industries. And from there, we have 27 brands, 15 plus locations all over India. And our partnership is an array of business partners, like Shibu said, that we have the leading manufacturers with us. We work with them very closely with respect to applications, and this range is right from the complete material range you can talk about, right from polymers, petals, ceramics, thermoplastics, wax, composite, gypsum, and ceramics are the latest addition to our portfolio. So I would like to conclude here saying that if you want to see where you want to go, which technology to use, whether it is easy to buy printers or go for services, we are here to work with you on seeing the design flexibility, how it works, how the economics works for 3D printing in your industry, and what are the value drivers with which you can invest in this business. And we could give a complete shop floor visit to identify correct applications, the complete thing from our end. We have the complete package for you with all our OEMs and our own machines. So I thank you for your patience, and thank you very much, Dr. Shivu, again. And any questions, please?
Thanks, Rajesh, for the presentation. What we will also have is towards the end in the panel discussion, I think people also would rather respond with their inputs. So we'll keep it for the Q&A subsequently at that point in time. So for everybody, just to ensuring that so that we are catching up with time with all the presentation back to back. Thank you so much, Rajesh. And now we'll go to the next speaker.
Okay. Fine. So let me start my presentation. So as Dr. Shibu mentioned, this whole conference being specific to how 3D printing technology can be widely used in the automotive industry as well. Having known that this technology is currently being used in aerospace and many other industries as well, right? So with that background, let me start with an initial introduction about Altair, who we are as a company, and from there we will dive into the topic. Okay. So Altair is actually a software and a consulting company based out of Altair, US, and there we started almost around 35 years back, right? We started with a simulation portfolio of doing finite element analysis products, and then even we were into consulting, engineering consulting. And from there on, we have added a lot of different tools, basically to do with physics-based simulations, a lot of optimization, and then of course, recently we have also added a lot of new portfolios on the data analytics and high-performance computing as well. And therefore, if you look at this current slide, we are basically telling that our vision as far as transforming the enterprise decision making is to leverage the convergence of simulation, high performance computing, and artificial intelligence. We feel so because from all the multiple years that engineering companies have done simulation and done a lot of testing, of course, they have generated a lot of data, right? And this data, with the help of AI and machine learning, can definitely be used to do a lot of predictive analytics. And that is why we see this convergence happening between simulation, high performance computing, especially because all these physics-based solvers need high performance computing to do these complex physics. And also using this data, the simulation data, as well as the testing data, right? using that data to do a lot of predictive analytics is what we see this convergence for. So what are the solution portfolios that Altair brings to the table is what is covered in this slide. So beginning with on the left side, we have data analytics and AI. I just wanted to confirm that initially because that is the newest of the technologies that Altair has introduced. And we see this as a very powerful technology that engineers can use in their day-to-day activities as far as design and development is concerned, because it is now being integrated into the simulation workflow as well. So for all engineers who are into the day-to-day activity of doing final element modeling, using some of Altair's pre-processing tools, right? We have Hypermesh, SimLab, and many other modeling tools. All these AI and machine learning technologies are being integrated in these simulation workflows. And that is the reason we are seeing a lot of companies using this technology to do a lot of predictive analytics on very complex structures, right? Of course, on the physics simulation side, we offer a lot of technologies on the structural analysis, the electromagnetics, CFD analysis, multi-body dynamics as well, and many such complex physics simulation, which is part of the Altair portfolio. Design and modeling and visualization, that is one of the core technologies that Altair initially began in this world of simulation. So we have right from the finite element modeling tools, that is Hypermesh and SimLab, to even the new generation tools, which are very easy to use, very designer look and feel, that is in the Inspire platform, right? So that is also one of the tools within the design and modeling tools. On the bottom, you'll see a lot of other solutions here. The Internet of Things, as you all know, a lot of these new age products are smart products, and these smart products connect with each other, share data, and then you can use this data to do a lot of predictive as well as prescriptive analytics, as well as use this to build digital twins, which can then be integrated into these systems, right? So the whole communication and communication between these products and seeing that data is wisely used and using the AI and ML technology in the whole portfolio is what Internet of Things is all about. And then, of course, we are talking about HPC, especially because all these complex physics-based simulations need high-performance computing, both in-premise as well as on the cloud, to do all these physics-based simulations in a very quick amount of time. And then finally, Altair has also partnered with a lot of third-party companies, and we make available all these third-party tools within the same Altair licensing scheme. So all the Altair customers can use some of these third-party solutions without any additional cost, right? So this, in fact, is the broad solutions portfolio that Altair has, and customers are widely using some of these technologies. With regards to customers in the various verticals, be it automotive, aerospace, and so on, you'll see that some of the large OEMs as well as very important customers are using Altair technologies. You'll see some of the big OEMs like Ford, GM, Hyundai. Many of these companies are into doing all these simulation-based analysis and also using some of the newest technologies in AI and machine learning. So with that introduction, let me start with this topic on simulation-driven design. Since the morning, we were all hearing a lot of panel speakers talking about design for manufacturing, right? And what Altair has to offer is basically a platform which is completely integrated into a single platform, right? Wherein you're basically looking at how you can use simulation to drive a design, wherein the design has all the attributes with regards to the performance of the component, the efficiency of the component as far as its weight, and a lot of other factors, and the manufacturability of the part, right? So in this single platform, any designer or simulation engineer can actually model the complex physics, do a lot of initial concept optimization, making sure that you are focusing on lightweighting as well as performance, and then at the same time checking whether the design that you get from this whole simulation is manufacturable or not. So the manufacturing feasibility is what it provides in that same single software. So what are these tools, and what are the different capabilities that it brings to the engineer is the whole idea of first initially generating those concepts, the optimal concepts, right? So the generative design of having to look at creating those topologies, the initial optimal topologies, given the fact that the components of the systems encounter various kinds of loads, right? And we have to look at different manufacturing constraints as well, right? So when you formulate such a problem, designers will then be able to idealize and optimize an initial concept, a design concept which is based on the finite element technology and the optimization which runs inside. And eventually, once you get that initial concept, the optimal concept, you can then validate that design. So in that single platform, we have integrated, in fact, a very new age technology as far as design validation is concerned, which is, of course, based on finite element technology, but it does not use any finite elements. So that software is called as SimSolid, and within the same environment of Inspire, which it generates those initial design concepts using topology, you can then validate that design by running these simulations. So SimSolid is a structural analysis tool. It can do a lot of linear static, modal, a lot of vibration kind of analysis, and all that is integrated into the same platform. So you can then quickly validate that design, the initial concept that you have generated. And then finally, once you have done that validation, you can also check for the feasibility of manufacturing. So in that same platform, again, you can check for the feasibility, whether it is a sheet metal component, a casting component, or maybe a 3D printed component, right? So for whatever process that you want to take this for manufacturing, you can check for a quick feasibility and then confirm the final design, right? So this is a single platform that we are talking about, which helps the designers to drive a very optimal design. So what are those tools and the different solutions that Altair Inspire allows engineers to not only generate those concepts, but check for the feasibility for manufacturing. So initially, once you generate that concept, which is based on topology optimization, of course, you can also include a lot of dynamic loads. So with this solution inside of Inspire, we call it the Inspire Motion, you can impose a lot of these dynamic loads. And then with these dynamic loads, you can then check for the different kinematic or dynamic behavior of the whole system, and then even extract all these forces and accelerations at all the joint locations, and use those forces to then look at identifying an optimal concept for each of those parts in the system, right? So in this integrated platform, you can not only impose static loads, but even dynamic loads, right? Once you've done that, you get that optimal concept, which you can then validate by doing a quick simulation in SimSolid, which is a very fast solver because it does not use finite elements internally. And then once your design is validated, you can look at the feasibility of manufacturing using casting, injection molding, sheet metal forming, extrusion, as well as 3D printing, right? So all of these different portfolios are part of the same platform called as Inspire. Here is just a slide which shows how you can actually simulate for the various manufacturing processes, whether it is casting, sheet metal forming, extrusion, molding, as well as 3D printing. So 3D printing, as we've seen since the morning, has come a long way, right? From just looking at the capability to actually looking at production capacity, right? So we were only looking at how a 3D printed part can help us to understand the behavior of the system and all that, but at a very prototype level, right? But now we are looking at how we can use this technology to help us at a production capacity, right? So if you look at the entire portfolio over here, it talks about how you can start with the initial concept generation to generating that concept and even looking at the 3D printing process. So this animation, let me just go back and I'll animate this again. Yeah, as you see here, this is an automotive component and it is undergoing these dynamic forces, right? So now the idea is to look at how you can generate a new concept for this bracket over here, and it is accounting for all the dynamic loads. And once you have designed this using topology optimization within Inspire, you can now look at how you can manufacture that. And within the manufacturing portfolio, Inspire Print will allow you to look at various orientations of the part, right? So with different orientations of the part, the support structure would change. And we don't want a very large support structure, right? That will increase the cost as well as a lot of other issues also which might be encountered in the system. So how you can identify the right orientation for manufacturing and minimize the support structure, and at the same time look at how you can see to it that the thermal distortion which might encounter after the manufacturing is minimized, right? So all this process is integrated into this whole system. This video flow of how you can actually create a design space, impose all those manufacturing constraints in the model, and then run this for optimization. And after having run the optimization, you get the optimal design here, which shows you the clear material retention and the removal of material. And once the topology optimization is done, you can quickly validate that design using SimSolid, which is the fast solver that we have integrated in Inspire. And then finally create this design using polyNURBS, the polyNURBS technology, which will help you to quickly create that design within the same interface. Now, in 3D printing, we all know that there are a lot of other issues which may crop up based on how you manufacture it. One of the concern is how you can actually look at minimizing the printing time by orienting the part in different, let's say, positions. So this software allows engineers to orient the part and then identify how much is the printing time for this particular component. As you see on the left, we have one orientation of this part, and with that orientation, it takes around 6 hours. But if you orient the part in a different fashion, which is what is shown on the right side there, the printing time is 11 hours. So you can, in fact, as an engineer, look at different orientations that are possible for this particular component and thereby understand how much could be the printing time. So it's a very user-friendly environment which will allow you to not only check this, but of course minimize the support structure and at the same time look at the thermal distortion and thereby see if there is any defect in the part, right? So we not only look at minimizing the supports, but even look at part orientation and reducing the manufacturing defects. Let me move on to the next, let's say, section of this presentation, which talks about the material. So since the morning, we were having a lot of discussions on how material really plays a big part in additive manufacturing. So within this whole portfolio of Altair, there is another solution called as multi-scale designer. And this particular tool helps engineers to characterize materials, whether it is a composite material or whether it is a short fiber reinforced plastic injection molded type of part, or even a 3D printed part, a metal 3D printed part. So you can start with creating a unit cell, what we call as the representative volume element, and then characterize those different types of materials in this environment called as multi-scale designer. And once you have characterized the material for various different conditions, you can write out a material model into the macro finite element solvers. So as far as Altair's macro finite element solvers are concerned, OptiStruct and Radios are the implicit and explicit codes. The material model that you can write out from multi-scale designer can be easily integrated into a finite element model, and you can then run the macro finite element simulations. So this whole multi-scale simulations of having to do not only micro-based analysis on the unit cell, or what we call as the RVE, and then characterize that material, but you can also export a material model to do a full-scale multi-scale simulation, right? So the whole idea is to understand how material plays a huge part in the behavior of the component. Now, once you have done that, once you have characterized that material, you may want to use that material for various other components that you are manufacturing in different, let's say, parts of the whole system. So then you can save that material in a database. So Altair has a material data center which provides engineers with a whole list of close to around 45,000 different materials in the category of metals as well as plastics. So Altair has partnered with all these different material suppliers, be it BASF, Dow, DuPont, and of course even on the metal side, Bilstein, Bow Steel, Magdat, and all that. So all this material information comes integrated into this material data center, and engineers can seamlessly access this data and write out the material model in the specific solver that he is using. Not just Altair finite element solvers, but even third-party solvers, finite element solvers. You can write out a material data and then integrate that into the finite element model to run these simulations. So this is a very important aspect, and we feel that this can definitely help in seamlessly integrating these complex materials. I think my presentation got hung, I believe. So I'm sorry about it. So let me restart this. Just give me a minute. Yeah, slides are coming up. Just a minute. Yeah, I hope you can see my screen. So this is the material data center that I was talking about, which is seamlessly integrated in the whole process of design and simulation. Moving on, let me start with a couple of automotive case studies so that you get an idea of how the implementation has been as far as this whole design for additive manufacturing is concerned. So we have worked with a lot of customers, and one such collaboration that we did was on the Volkswagen Caddy. And this particular example shows you the whole process of how simulation and design for additive manufacturing was being implemented. Well, for that 3i print project, there was a collaboration between Altair, AP Works, CSI, WEG, EOS, and TVS. And it was close to a 9-month project of completely redesigning the front structure of the Volkswagen Caddy and coming up with a very innovative structure, which is not only lightweight, but incorporates all the requirements as far as the structure is concerned, be it the passive safety, be it the thermal management, and be it the integration of all the other systems in the same framework, right? So that was a very interesting project that Altair did, and here is this workflow that was implemented. So as far as this front structure is concerned, we have to look at how to satisfy the performance requirements as far as stiffness and crash is concerned, right? So what was done was the Volkswagen Caddy CAD model was imported into the system, the Inspire platform. We built that initial design space, as you see in green, which is the package space as far as the front structure is concerned. And we had to evaluate that for frontal crash, pole impact, as well as ODB. And then evaluate how you can come up with these various topological structures. Of course, the whole focus was on lightweighting, but we have to also look at how we can satisfy the performance targets as well as crash as and stiffness is concerned. So if you look at this previous slide here, if you model and evaluate the design, the topology design only for crash, it would come up with a very different looking structure over here. But if you, let's say, evaluate the same design space for stiffness considerations, the design would be completely different. So the whole idea was to completely integrate the requirements for crash as well as stiffness in a common design space and then run it. So Inspire allowed us to look at the whole space and the various load cases and as you see here, they eventually came up with a design which was then converted to this concept that you see on the screen, and it was evaluated for pole impact, frontal, as well as ODB. Once the validation was done, finally the concept was detailed in this fashion, as you see on screen, taking into account different types of structures: a shell structure, a hollow structure, and different crystallized structures as well. And as you see here, it helps us to satisfy various considerations, not only on the performance part as far as stiffness and crash is concerned, but also look at thermal management of the structure. Because this has to also look at the air and water cooling of the whole system, right? The active thermal management as far as cooling and of the battery packs, the heat dissipation through the ribs, and then also look at not only the crash behavior, but look at the aerodynamic optimization. The airflow to the brake system also had to be looked at, and then the integrated connections within this optimized structure, within this 3D printed structure, of how you can include brake fluid as well as cooling, right? So it's a very innovative design that was idealized as well as finally manufactured with the 6 partners that Altair worked with. So, in fact, this was showcased in one of the conferences in Europe. The final Volkswagen Caddy was in demonstration at this conference, and it was very well received. So here is another case study, a set of 3 case studies that I wanted to just quickly cover. The first one, as you see on the left, is a concept motorbike, which AP Works, which is a subsidiary of Airbus, right? So they use Inspire quite a lot to generate a lot of new concepts, not only on this bike, the electric bike, but even Airbus structures, right? So this particular concept bike had a lot of new, let's say, structures, as you see there, which was all idealized using the Inspire tool. So here is that case study, which I'll be quickly running through. And of course, there are other couple of case studies, but in the interest of time, I may not cover that. So let's start with looking at this case study that was done with Airbus AP Works. So as always, we have to start with the design space, and the design space was identified. The non-design spaces were also marked out, and the various loads and boundary conditions that come to this structure were imposed on those design spaces. And the optimization parameters as far as what we need to optimize for, whether it is lightweighting, weight reduction, or performance constraints, and then the manufacturing constraints as well were imposed. And once you run through the topology optimization, this tool would then show you the ideal structure, which you can then in the same platform, you can then convert that into CAD using polyNURBS, a very easy to use CAD generation tool, which will then help the designer to quickly create those CAD surfaces or CAD geometry using this as a template. Whatever the optimal structure that you see, that is used as a template to generate those polyNURBS CAD model. So that was a very interesting project that Airbus used the Inspire platform for to lightweight the frame of the motorbike. The overall weight of the whole system was around 35 kg, and eventually when it was on the road, it was actually driving at a speed of 80 kilometers per hour. So a very lightweight design, and this was of course electric. So that was another interesting case study. And this final case study on how we were able to implement the design for additive manufacture on engine parts. So as you see there, the number of parts were reduced to, by 200, and the final mass of the whole structure was around 120 kg, a reduction of around 25%. So with that, I'll actually quickly run through the last few slides and close my section. This was another interesting case, but I'll quickly skip that. So what we have to say is that this whole platform, the Inspire Print 3D platform, brings you a very competitive advantage. One is to reduce your overall manufacturing cost, because we know that with any orientation change of these different complex parts, right, the cost would increase. There would also be other issues that may come up as far as part deformation because of overheating and all that, right? So that is very important. So to not only, let's say, design a structure, but look at how the manufacturing will play a huge part in the reliability of the structure, right? The second is the overall increase in the efficiency of the part. So with this whole generative design concept, wherein you can quickly come up with a very lightweight structure, taking into account all the manufacturing constraints with regards to this design that you are looking at. That is one part. And then finally, the whole process of creating these optimal parts, looking at the advanced thermomechanical simulation, all integrated into the same platform. So that is a single platform which will give you the competitive advantage of not only a lightweight part, but a very manufacturable design. So with that, I end my presentation. Basically, what I had to say is that this single platform allows engineers to not only lightweight the design and quickly validate that design very quickly using SimSolid, but also look at how the feasibility of manufacturing can also be checked on the same platform. And that gives you a very competitive advantage as far as coming up with these lightweight designs. So with that, I end my presentation. So if there are any questions, we will take it now or at the end of the talks.
So hello everyone. I would like to introduce myself. I am Krishna Kashyap Singh, working as a senior engineer at Amaze Solutions. Initially today, I will be talking about Amaze Solutions, what we are doing for the automotive sector, and how we are slowly driving the change towards new disruptive technologies at our group, the ACE Micromatic Group, via our company Amaze Solutions. Yes. So going forward, ACE Micromatic Group has been a pioneer in the field of indigenization for the country since 1973. Amaze Solution belongs to a group which has been indigenizing technologies since 1973. Then first we started with grinding, then we went to the tool turrets, ATCs, which was done by our company Pragati Automation, then turning solutions via ACE Designers, then milling solutions via AMS, and now we are into additive manufacturing since 2018, catering the automotive industry at a very large scale since 1973. Amaze Solutions basically via its group company called Micromatic Solutions, Micromatic Machine Tools, shows its presence in in all these countries at the global scale. We have sales and marketing offices at the global scale, services offices at the global scale. We are represented in this country directly via our offices, our international branches, or via our dealer partner network. So yes, enough about the group. Now, what are we doing at Amaze Solution? What are we trying to do here is that we are trying to adopt additive manufacturing for most of our customers, which belong to various industries such as aerospace, automotive, medical, defense, but a large part of it is constituted by the automotive industry. And AMS, which is a company for milling machines, they make machining centers and they have more than 25,000 installations. And then there are ACE designers who have a similar position in the turning center market. They came up together in 2018 to form additive manufacturing from the ACE Micromatic group called as Amaze Solutions, where we are catering to end-to-end additive manufacturing solutions. I'll be showing some case studies that how we have developed the end-to-end solutions for various areas in automotive and how similarly they can be adopted in the industry for all the participants who are or all the viewers who are witnessing this presentation. Then how we have catered to the one of the very basic challenge in the adoption of additive manufacturing, which is productivity using metal additive manufacturing. And we have done all this with our vast experience. We have been able to do this because of our vast experience in the machine building sector, because machine building is something which is very natural to us. We have been doing it for decades, and similar efficiency, similar expertise we tend to develop, and we have covered some distance in that perspective in additive manufacturing as well. So moving forward, today I will stick to one particular technology of metal additive manufacturing, which is called as laser powder bed fusion. Currently, we are offering metal additive manufacturing machines in the same field, but why I have chosen this technology to talk today is because this technology is the most ready technology where we have proved the capabilities of the technology, the materials in most of the applications, in most of the areas via various applications. And what we need to work now is to work around the application. You can leave the burden of technology, materials, process to us, and the areas that can be explored in terms of application, which will give a boost to the adoption of metal additive manufacturing in our country. So what is the scope of additive manufacturing that we are talking about? The various scopes of additive manufacturing comes from two different areas of additive manufacturing. One is the process requirements, like this process which I'm talking about, laser powder bed fusion process. What is it about? What are the requirements if you want to adopt LPBF for automotive sector? What are the various requirements? Those requirements consist of digital CAD data, an industry-grade machine which can manufacture industry-grade products, which can be used to cater to the different safety standards that we are following in the automotive industry. And then skilled workforce. So there can be aspects related to training, education, which need to train the workforce who will use digital CAD data, industry-grade machine, and the materials and bring it together and make the right product to the process. And then there is feedstock, definitely. So in all these areas, there is a wide scope of research and development and indigenization, definitely. We have started with the indigenization of industry-grade machine. Few companies have started with the indigenization of feedstock. And Such a program is an example of the initiative how we are working towards attaining a skilled workforce. But what are the areas in the automotive where we can cater these? Those areas basically I have summarized in 3 segments. There can be more, but these 3 are the areas where we have worked a lot and we have tried to prove some good case studies, which we will be talking about. One is new product development. Another one is research and innovation. So new product development is making the products for near future, such as electric bikes. And research and innovation comes when we are looking at the farther future, what we are aiming after 10 years, after 20 years. Then we have the ongoing process, which is we are catering to at the production level using additive manufacturing for tools, jigs, and fixtures. So in the automotive industry, why exactly is there a need? And what is that need? That need comes with the increasing demand of complex designs. We need to make complex designs. And in order to generate those complex designs, to realize those complex designs, we need advanced manufacturing techniques. And not just these need to be advanced or efficient in terms of performance, but efficient in terms of cost as well. That's why there is a very wide need of hello. Okay, fine. Yes. We need to have short production cycles. So additive manufacturing helps us. Additive manufacturing helps in really quick. I think there is some noise in the background. Someone is unmute. Okay. Yes. So then comes on-demand manufacturing, that in order to disrupt the conventional supply chain techniques, where there is a requirement of high stock maintenance, high inventory, all these can be catered to if there is a technique which allows us to to enable on-demand manufacturing in a distributed landscape. So all this is helping us basically in reducing the spare parts inventory and then simplifying my supply chain and logistics. And this is very, very necessary when we are looking at the overall cost of the manufacturing, assembly, design, logistics, everything, life cycle cost if we are looking at the projects. So additive manufacturing, via design, it is enabling me benefits in the manufacturing stage as well as at the lifetime performance of the component. So to start with the first stage where we have done some development, which is the new product development using metal additive manufacturing. So what you see on your screen is a bike, an electric bike, which has been built for long endurance. And this bike has completed 1,000 kilometers in 3 days. And we have built three prototypes of this bike. The Aura Mantis, it's a startup based out of Bangalore. And I'll be talking more about it later. But before that, I want to show few images, like what were the parts that we made. So here you can clearly see that components, not just as the fairing of the bike, components like the swing arm, the telescopic adapter, which holds the telescopic handle, the suspension system, the front suspension system, that component also was manufactured using additive manufacturing. And basically 70% of the 3 prototypes that they have produced for a very adventurous event, a very adventurous launch of the Aura Mantis, 70% of this bike components were printed on our machine, and we printed at SLM. We just not printed these components in their actual design. We suggested some design which would further strengthen your very basic of your very structural integrity of these components, because they were building for endurance. What endurance exactly they were building for is this called as a Bharat Mala, where they have started from Bengaluru and they are planning to complete the whole India trip on these 2 prototypes, which will constitute 15,000 kilometers, around 15,000 kilometers. And they have almost completed 8,000 kilometers plus. As you can see, they have reached Srinagar. That is their latest destination. They have reached Srinagar. And the idea is, by this ride, they will not just enter into the Guinness Book of World Record using a 3D printed electric vehicle bike, but the endurance of the technologies such as electric vehicles and additive manufacturing will be proven simultaneously. So this is what we have been doing the development, and the idea is to tell people what are the boundaries of additive manufacturing, how we can use additive manufacturing for very quick time to market. In the previous discussion, it's a very straightforward example of quick time to market using additive manufacturing, and we have just shortened the conventional supply chain in the proto stage, and we have enabled them to start their ride as soon as possible, not only for electric vehicles but also for other automotive prototypes such as combustion vehicles. There are many opportunities. For example, when we had a huge transformation from BS4 to BS6, at that time there was a huge demand when components such as engine components, transmission components, exhaust components for the automotive industry, they were being redesigned. So the technology offered us opportunity to do these design iterations really quick. And what you see on your screen are components like cylinder head, cylinder block, exhaust manifold. These we printed in LSI 10 mg. The exhaust manifold, this is a sample which is in LSI 10 mg. Usually we print exhaust manifolds in Inconel 625 because there we are concerned about the high temperature of the exhaust gases. Then other automotive components which cater to fully functional areas of automotive subsystems, such as gear components, transmission components. Now these gears, they were developed through reverse engineering and 3D printed. So the idea was to go for reverse engineering first in order to go for 3D printing so that we can develop the components directly from the CAD data. But since we were using additive manufacturing, there can be other advantages that can be integrated. So we integrated some designer-induced holes, which the designer thought of from the application point of view and made in the components, and thus we were able to achieve some lightweighting because of this self-supporting hole design. What you can see in the gear here. And on the right-hand side, again, is for an electric prototype. We have a two-wheeler prototype, a renowned name in the country. We have the brake calipers, which are 3-cylinder pistons arrangement, and these brake caliper housings we printed in LSI 10 mg, and they are right now being used in prototypes for fully functional testing. So all these components, they are clearly indicating that additive manufacturing, metal additive manufacturing, components made from laser powder bed fusion can be used for a wide variety of fully functional prototyping and testing. And we will cater to more. We will cater to more. We will cater to prototyping. We will cater to mass production, tooling, everything. Before going there, one more case study. This is a motor housing again for an electric vehicle. This is for a electric hub on a two-wheeler. So basically, the motor is fitted in the rear wheel of the two-wheeler scooter, and you require a material which gives you good heat dissipation properties. And conventionally, the idea to manufacture these components is via die casting. But again, as I told you, the conventional route requires the formation of the development of tools, and then rework on tools, checking on tools, then the finalization of tools will happen. Then the development of component will start. So what we do, instead of developing the tools, we use the advantage of laser powder bed fusion, which is a free form fabrication process, and we develop it directly the CAD model through that. So, and it was this component, the printing time was only 24 hours. Then, as I told you, not only to the conventional side, not only to the proto side, new product development side, R&D side, there are advantages of additive manufacturing in the final production stage. And this is a case study for that. This is an indirect application of additive manufacturing where you are not manufacturing the end component directly, but you are using additive manufacturing to manufacture the tools, jigs, or fixtures which will be used to manufacture the end component. So that is the idea of applying additive manufacturing in the production stage for the automotive industry. Why? Because the volume that is required in the additive manufacturing industry sometimes can only be fulfilled through a conventional process, but the conventional process can be given the advantage of additive manufacturing. Like in this, here you can see that there are very fine holes. These holes, the 1 mm hole, and they were made for passage of compressed air. This is a seat check fixture for an autonomous production line, where when they make the fixture, set the fixture, they blow the this thing from the compressed air from bottom. They check if the compressed air is following from or not, and at that time when it flows, it blows away all the chips that is coming there. So the sitting of the fixture, that's why it is called a seat check fixture. The sitting of the fixture doesn't disturb, because we are, prior to that, we are checking the arrangement, the setting arrangement using this fixture, using an arrangement of compressed air. So this is how we are adding value. Now, if you go for making this component in conventional, the component would be very bulky, and handling of bulky components during automation lines, it will increase only the time taken in the automation line. And even for 1 second reduction, there is a large amount of investment that can be made in automotive production line. Now let's come to R&D side of it. Going to for the future, to prepare the workforce for the future, how we are empowering the R&D industry of automotive as well as the great engineering minds of tomorrow. So what we did, that we collaborated with Team Steer Racing for the past 2 years, and in the 2 years we have developed two components with them, which are designed for additive manufacturing and fabricated by Amaze Solutions in LSI 10MG and SS316L. I will be talking about these two components and their importance in this prototype. This is an electric vehicle prototype developed by Steer Racing. Steer Racing is the team from Ramaiah College of Engineering, in the Ramaiah Institute of Technology from Bangalore. And via this component, by this prototype, they go to an event called as Formula Bharat, and they take part in that, and they prove the engineering design via designing event competitions and endurance competitions. They actually race and do competitions like braking event, drag race, all these. They are judged on all these criteria. What we did was that first of all, we took the challenge for redesigning the rear wheel hub, where we had not much freedom because it's a rotating component. It is the component which is attached to the your disc rotor, which is a fixed component on your disc rotor, and also on this component itself your wheels are mounted. So this is a rotating component undergoing dynamic loading. So the only area that we could explore was in the center, where we could provide some lattice structure to reduce the weight of the component, but at the same time maintaining the stiffness of the component and maintaining the factor of safety. Then for the same team, we did another case study where we have developed a sheet metal brake caliper, which was failing in the event, which was getting damaged due to points of fracture, due to points of failure. And those points of failure were nothing but the weld points actually. So we redesigned into a monolithic brake pedal using Altair Inspire, as the sir was talking about Altair Inspire and telling how we can do various kinds of topology optimization simulations, which is nothing but simulation-driven design. So we adopted that methodology, and the students they were trained in the technology, and they worked along with us to develop this model. And this particular model that you see, it is only 422 grams, 47% weight reduction was done. And this particular model, you can see here, this was assembled on the car, tested, and then take it to the event. So if my estimate is not wrong, this component has sufficed right now already 500 kilometers of testing. And if not, then they have a plan of testing it for 500 kilometers. Then we will be publishing the data as well after the testing. What were the deflections that we experienced? So this is a beautiful example of additive manufacturing and simulation-driven design. So the first idea, where we changed the brake pedals, the hub, was designer-driven simulation, where the designer-driven design, where the designer gave the input for the design. In the second idea, what we've done is, when we understood the technology, process, and the application, the most important thing is the end application. Then we developed that component where we implemented simulation-driven design, and the typical methodology for simulation-driven design was this: that you start from engineering CAD data, put in all the boundary conditions, do the topology optimization based on FEA, and then do the data preparation in Materialize Magics, and then fabricate it on the STLR 400, do the post-processing, and then use the component on the vehicle. This is the machine which has been indigenously designed class 1 local comp product by Amaze Solutions. It's India's first large format metal 3D printer, which we have focused only on productivity, where there are two 1 kilowatt lasers, and we made this component in this machine, and this component was made in less than 4 hours, whereas there were 3746 layers, and the layer thickness that we used was 60 microns. Then we come to tool and die making. In tool and die making, again, this concept I am introducing is because not always topology optimization or a design change is feasible in the end component depending on the mass production technique. So what we do, we apply DFAM techniques to the components which are used for making the end component. And that DFAM technique largely involves conformal cooling channels, where you are making intricate channels which cannot be realized by any other method apart from metal additive manufacturing, laser powder bed fusion to be precise. And these channels will help you in optimizing the cooling cycle of your injection molding or die casting process. And by reducing the cooling cycle, it will improve the yield. Not only it will help in reduce the cooling cycle, sometimes some cases we have witnessed, like in this one where we made a tool, a mandrel sort of sub-insert core, where it was used to manufacture a component for an end automotive customer. And these components with conformal cooling channel helped in reducing the customer rejection rates from 8-9% to 0.1%, 0.2%. Why? Because there were blowholes at certain areas at 3 locations, which were causing the rejection of the part. And by conformal cooling channels, by doing a proper cooling during the injection molding cycle, during a die casting cycle, because it's a die casting mold, we were able to generate a component which was free of blowholes. So that is the idea of implementing. But what are the challenges? Why these techniques? We know we have done with several people, case studies, but why are we not able to scale it up? What are the challenges in the adoption or scaling? The challenges basically consist of the materials. So what we need to do is that we need to develop more materials locally while maintaining the specifications of material, because if you want to have good quality in LPBF process, you need spherical powder material, which can only be generated within the required shape error factor in an inert gas atmosphere. So it makes the powder manufacturing process expensive. So we need to work on technologies which will bring the cost down but keep the quality same. That is the idea, and that is what we are doing with machine development for LPBF that I will be talking about again. Then productivity and size. Now most of the machines in India which are installed, they are of the build volume around 250 mm, 250 mm, 350 mm. Again, I'm talking about LPBF. So the attempt by most of the machine manufacturers, including the indigenized machine manufacturers like Amaze Solutions, is that we tend to cater to a larger build volume. Now, there are many challenges when you cater to a larger build volume, that the productivity will reduce. It might reduce because your one laser has to travel very far and it will take more time to scan a larger area. So there can be further developments like putting out double lasers that we have done. We have put 2 dual lasers of 1 kilowatt to increase the build volume, but not to decrease the productivity at the same time. In fact, enhance the productivity. Then skilled workforce is another area where we need to work on. Thanks to Dr. Shibu John sir, that he's organizing he's taking such initiatives to work on this area. And definitely what we need to do is we need to have a broad amount of localization. Right now, the localization that we are talking about is limited. It's either limited horizontally or vertically. Either we can cater to only certain areas if we look at the horizontal tree of the industry, or we can only look at certain areas if we look at the vertical tree of the applications. But in order to overcome these areas, we need to make products which are dimensionally accurate, which are giving us quality, but at the same time, the high equipment cost is not there. So we want to cater to that. Now, most of these high equipment costs or these challenges that we are discussing about, these largely can be solved by indigenization of technologies, and especially for the automotive sector, where in India, automotive sector is playing a huge role towards the GDP. Then as I told, our attempt from ACE Micromatic Group by AMACE Solutions, the attempt is to develop, to provide the industry a machine which will enable, high productivity, which will enable your limited cost, reduce the cost, and at the same time, we will be able to produce larger volume components with top-end quality, which will not be only suitable for prototyping, but will also be suitable for mass production techniques. And for example, by applying the same formula to our machine called as the STLR 400, I'm really sorry for the image. Please ignore the image. The image shows LM 400. It's an error. It is STLR 400. So when I'm talking about the STLR 400, we are able to reduce the cost of the components produced on STLR 400 by 60%. That we have done for the e-vehicle industry, prototyping industry. So the need is to integrate AM end to end and improvement and to achieve lifetime performance in the end component. At the same time, have improvement in the productivity during the manufacturing stage. So just for example, I would like to show about this component, and this is the interface that we have developed. This is a component built on our machine STLR 400, which was made in Inconel 625 1900. It's a completely user-friendly machine with IoT enablement, and I am not using I'm not talking much in detail, but if anyone needs more details, they can contact me. The idea is just to inspire people to look for more indigenized solutions and how we can bring down cost in the automotive industry, because the automotive industry is an industry where we need to have cost-effective, productive solutions. This is our attempt towards that. Thank you. If there are any queries, they are welcome. I would be able to answer them whenever the forum permits. Thank you, sir.
So, thank you, Krishna, for your achievement. I would say, because actually getting into the space of automotive, since it's been conventionally accepted. The conventional manufacturing space and machining has always been the key technology, which has been the enabler for the industry and the sector. And then to have the initiative of these electric bikes in terms of what you've been able to test and trial as a case study is a great commendable achievement. So hats off to you and your team, and also Dr. Vishwas. I've been actually following up with him, and I know it's immense of efforts been made in terms of achieving that. So congrats to you. And I also have inputs coming from Mr. Vijay Pankhawala from ARAI, as he would also join. He would be the moderator for the session in the evening. I'm sure we will actually have dwell upon this even more to understand in terms of more of a detail, since you're also a panel member in the discussion. And I think there'll be a lot of questions to be answered and discussed upon. I'm sure it will be a great exercise. Thank you so much once again, Krishna, for your very detailed expression through the presentation that you've given on the topic and the technology that is to offer. Now, I would like to introduce Surupji. Thank you, sir. I think we missed out earlier due to some error there in terms of communication. And I think now you're perfectly clear and looking hearty and smart. Thank you. And we can start the presentation, sir.
I will do that. Let me share the screen.
Thank you, sir.
Good afternoon to everyone. And I think I heard 4 presentations in the post-lunch session, and almost everyone is sharing how 3D printing has been useful in different areas of producing the finished parts and the prototype as well as the functional parts. I think the key is to reduce time as well as reduce the cost, and this can be applied from styling to manufacturing and maintenance. After hearing some of the presentations, I did change some of the slides because it might have been repetitive in nature. Adroitic as a company has been working with the customers to enable them to leap forward, which means they can grow, and if they grow, we can grow faster. And therefore, Adroitic as a company has been working in emerging technologies which can be used by the company as well as by institutes. We are in 3D printing of additive or called additive manufacturing for prototyping, pre-batch production, providing tools and dies for regular manufacturing, spare parts, as well as other areas of medical, defense, handicraft, tourism, film and art, and STEM education. So we will cut the later part. We will just focus on some of the areas in the manufacturing area. We do work in IIoT and robotic automation, and we do take projects related to CAD and design optimization. Today we are a team of about 300 plus people which are focused in only engineering and with 9 offices spread across the country. I think this slide, many of the people have talked about that how in different stages of the product development have 3D printing been used globally. They have been used for visual aid, presentation models, doing the fit and assembly, pattern for prototype tooling, patterns for metal casting, tooling components, functional parts, education and research, and others. I think Krishna Kumar did touch upon the conformal tooling. In the Altair presentation, Sunil did talk about optimization. We as a company have been working with different technologies related to plastic as well as metal. We do use HP MGF system. We use an SLA system from Formlab. We work on clay, which used to be used very extensively for styling purposes. We work with the multi-material machine, and this is the machine which we have designed and manufactured ourselves. We do work with Markforge for the Metal X as well as for carbon composite, and we have designed our own versatile FDM printer. This FDM printer, we are very proud because this is the only printer of its kind where on the same machine you are able to print normal thermoplastic, you are able to print high temperature and high wear and tear materials like Ultem. You are able to print ceramic on it like zirconium and alumina. You can print on the same machine metal components using an FDM technology. So we have successfully printed materials like bronze, HR13, Inconel, 316L, and different type of materials have been printed. So on one common machine, one is able to do any of these works using the FDM technology. So today we are very happy and to share that we do work with metal, resin, nylon, thermoplastics, fiber, composite fibers, and ceramic, including the high temperature thermoplastics like PEEK as well as Ultem. Material is a key apart from the technology, and if you see, you can work with the tough parts which are snap fit. You could work with flexible parts which are giving a spring effect, or you can work with durable resins. You can work with high temperature materials which are flame resistant and can go up to about 238 to 40 degree at 0.45 MPa. You could work with flexible resins as well as the elastic resins. So that gives you an exposure of how, based on your applications in the automotive industry, can one apply the technology and the material. So today, your imagination is what determines how it can be used. using a material from Markforged, you are able to get strength almost like actual metal parts. And in some cases, with the reinforcement of carbon fiber, you are getting strengths which are higher than aluminium, but definitely not the temperature conditioning, which is equally required for applications like engine and things like that. As a whole, the Adroitec as a company has been working with metals, plastic, composite, flexible material, clay and ceramic, as well as gel, which is including wax and any warm gel material. I think this is a slide which I can skip to a very large extent because every speaker has been emphasizing the key benefits of additive manufacturing. But I think one part which was not touched upon was the MOQ. Practically 3D printing reduces the need of a minimum MOQ. In 3D printing, you can have one piece or you can have multiple pieces without any problem, and it does not add to the cost. It also gives you the bonus in form of complex geometry, and as Sunil from Altair had shown, there were different type of applications and very, very complex design which came out of the design optimization, and the same could be done. The Another advantage, two advantages which I will like to highlight, is that since you are a digital inventory, you don't have to, for MRO purposes, for maintenance purposes, don't have to store the tools for 5 to 10 years and maintain those tools, because in many of the industries, especially automotive, there are stores and stores carrying the tools only. The people did talk about the fixtures, people did talk about the other applications. I think the other very key benefit which 3D printing is giving, the security of your design and no possibility of a leakage of your design at the time of early part of the design and manufacturing, because when you give the fixtures to outside parties for making, and traditionally all automotive industry give the fixtures for they do the outsourcing. When you do the outsourcing, you have actually given away part of the design of the machine. Sometimes they can be used, despite NDAs, they can be used for spare part development or the gray market. This is an example I've taken from HP, where there were two components. There were about multiple components which had to be, which were being made using the injection mold. The same could be practically converted into a single component, and I think with real life examples, it has been shown how the optimization of design has reduced the cost, weight, and improved the performance of the parts. So today, 3D printing is being used for final parts, for tooling, for functional prototypes, in every possible applications of medical, consumer, mobility, aerospace, as well as defense and agriculture. And that's why combining these needs, today majority of the companies from hardware, material, software companies, FEA companies, as well as service companies are today providing or trying to provide solutions in bits and pieces, which is enabling this industry to grow very rapidly. And today it is growing close to about 27% year on year. A huge list of customers are adopting it. It is not fully adopted, but I would say they don't want to miss the bus at a later point of time. One of the factories where all the fixtures were manufactured using the 3D printing. Why in automotive industry is it critical? And we keep talking about automotive industry. If you look at it, This technology is very critical because the cycle time of a model is reducing. I don't have to emphasize it to you because you are all from automotive industry. But what used to happen in 3 years' time is today the 6 models are being manufactured, designed, and fixtures developed and maintenance to be done in 1 year's time. There is a need of personalization. So companies like BMW, companies like uh, uh, Mercedes are now today talking of, can I provide few fancy things in the car which are personalized? They may not touch the main components of the machine of the vehicle, but some fitments, some styling is being done for individual needs. And of course, if you look at it, the products are no longer dumb products, only mechanical product, but they are very intelligent product. The moment they are intelligent product, we need to work on electronic, mechanical, as well as electrical simultaneously to be able to reduce. And this we do it at different locations. What better way than 3D printing to be able to test what others have designed? Because even if we do the simulation, we are doing a simulation on the component or the assembly, but 60% of the parts in any vehicle are bought out parts. When they are bought out parts, we need to do the testing and fitment with it. So prototyping with the visualization, fitment with bought out items, as well as develop the functional systems is becoming critical, and that is where the 3D printing is reducing the time as well as the cost. Different examples of functional prototype, whether they are the inner manifold, engine covers, manifolds, or some of the fixtures, as well as some of the clamps and adapters. I think my previous presenters have already included some of them, and there is no point in repeating at length all of them. I am very personally very much an advocate that apart from the visualization and functional prototype, there is a huge need of fixtures and tools for the production line. They are required in small quantities. They all have typically the machine setup time is high, variation during the assembly and fitting, complicated part holding and requirements. And I saw a couple of lines, and since we designed production lines for various automotive companies like Daimler, we do work with Opel, we work with Ford, practically everyone in the industry where we design the full production line, including the robotic handling and programming. We have seen that close to about 700 to 800 fixtures go on one production line, and they need to be changed. So because of the variations in the model, because of the variation in the component, whether they are the robotic fixtures or they are the assembly fixtures or they are the holding fixtures or they are the checking fixtures. And the productivity can be enhanced significantly if we are able to ensure that the fixtures available are jigs and fixtures which are available are of the right type, whether it's on the CMM machine or it is for incoming inspection. Simultaneously, employee safety and ergonomic become very critical. So all of them put together are the challenges of the production line. While the planning of the design can happen, the prototypes can be done, but how do we ensure that the manufacturing lines move smoothly? And that takes time. And to establish that whole production line, if we look at it carefully, we would find that there are fixtures, there are units required in the quality control, in packing and logistics, safety, production tools, assembly lines, uh, uh, of course, in the development and the quality control. So traditional methods of CNC and manual processing or through the welding and assembly of the fixtures made in wood, plastic or metal is time consuming and any modification get compromised at the last minute. So 3D printing basically reduces the cost, lead time, weight reduction, customization, as needed quantity, no machining, high accuracy of part. So some of our customers have actually put the 3D printer on the shop floor for the people to design their own fixtures to improve the productivity and also the safety of the work. So what are the various fixtures which go in? They could be alignment tools, they could be holding devices, they could be feeders, hand tools, check tools, surrogate parts, end effectors, milling fixtures, drill guides, hand wrist guards, holding devices, bumper guards, ergonomic conversions, check gauges, work holding devices, text fixtures, go-no-go tools, tool guards, dunnage trays, even the kit boxes for improved productivity or the thermoforming molds. List is very large, and the value proposition is basically increase operational efficiency, lower the cost, and greater design freedom and improve performance. When we were working with one of the customers, they had a fixture which was made in aluminium and weighed 3 kg. When we re-looked at the whole design, it was a drill fixture. And with the drill fixture, the drill had to go at 90 degrees. So and it had to match with the profile of the part on which the drilling is being done. So what we did, we made the whole geometry or the supporting structure in plastic, which was nylon, and we did the insert in it so that the drill can go in very effectively. And when the drill goes in, the wear and tear is taken away by the metal. The geometry and the fitment and the this thing was taken by the nylon. By doing it, we were able to reduce the weight to about 1 kg and also ensure that the design could be done for different parts where the drilling had to be done quickly. Another example of a customer who is using the fixture for doing the alignment in the assembly area. Imagine this factory. This is typical automotive factory. If you look at it, if you look at the fitment of a bumper, right, or under the chassis, these fixtures are something which are critical for holding it during the assembly operation. Or when one is doing the assembly of the engine, these two blue structures or the spots are the fixtures. Sorry, I made a mistake. If you look at this, they are the fixtures and they are needed. If we don't have them, we will be using the V blocks or the blocks for it. But can we get a precise fixture, which is easy enough? It's not very complicated. We don't need any certification for it. We can take these decisions in-house. We don't need to go outside to do the certification of the fixtures. We don't have to bother about what material is originally specified under the ISI or the BIS. We could just make the fixtures for our operation and start using the 3D printing in our day-to-day life. If you just have a look at some of the fixtures which are done, typically this was the UHMW often used for cradles because of the toughness and impact resistance. Today, a combination of Onyx and Kevlar can give you much faster and a much better fixture and with high strength. Robotic automatic tooling. Just look at this robot operation which goes in the welding as well as in the paint shop. Can you imagine how many fixtures go into this? Just look at the parts. All of them are fixtures. So how will I make them? What would be the time? How long will it take? Who all will get involved? All of it can be done with simple 3D printer available on your shop floor. And then if there is a minor change because of the adjustments which the robot has to go in, you could actually make a new fixture rather than adjusting it with the strips which are often put during the operation. If you look at the screw back, if you look at the holding fixtures, if you look at the drilling fixtures, very simple drilling fixture, or if you look at the trimming fixture, or if you look at the wheel alignment, they all cost a lot of money and they all delay or they'll take time to get it done. It could be windscreen fitment, if you see the fixture which is here, or it could be the complete proto plant, which is tradition in the automotive industry. You could actually make it with the help of 3D printing. So another example looks very simple, but you need something to even fix the nameplate of the car. Now, do I need a fixture for it? And every car would have a different location, different profile at which location this has to be fixed. And they are all possible to be done. And we don't need any certification for it. We actually can do it both in plastic as well as in metal. And that would help in adopting the 3D printing in day-to-day industry application, which will definitely lead to your designers getting innovative about its use in the real parts as well. Here are some of the other examples of how Ford is using it for assembly, how is fixtures being used in the Ford pilot plant, how is the fixtures being used for the engine, how are the fixtures being used for doing the assembly, and also the welding fixtures which are critical. So any of the welding belt which is required where you may be doing TIG welding or any of them, you would need fixtures like this, and they can all be made, or precision fixtures for doing the welding. Instead of holding it by two hands, it could be directly made using 3D printing, and you don't need the high temperature material for it, because the material, the heat which get transmitted to the place where the holding is being done of aligning the two tubes is not the place where the heat comes at very high temperature. All these are weld fixtures, or they could be soft jaws, because in some places you do not want your bumper or the plastic to come in contact with metal. The moment it comes in metal, there is a possibility of a scratch. So can I make the fixture in either the nylon or in any other material which is strong enough, which is long lasting, and at the same time does not leave the scratch? So you could make soft jaws, you could make the boring complex part solutions, you could make the CMM fixtures, you could make the laser marking fixtures, you could make the CNC lathe bar pullers, right? Now, when one is doing in the tool room, one is doing a lot of CNC operation, and you need customized lathe bar pullers to be able to pull out the part after the operation is done. So even one such example of lathe bar puller could save anywhere between $700 to $1,000, maybe in Indian rupees, and looking at the Indian cost, it would save you still save you a lot of money, maybe about 5,000 rupees in your case. A company like Dunlop, which developed the suspension systems in an electric vehicle, uses the same 3D printing device to assemble the electric vehicle suspension for an electric car, is helping them out. And this is one of those fixtures which could be done. Now, this is a very interesting example where the company had to make the tool in tungsten carbide. It's a very expensive material and it may or may not fit. So what they do, they actually create a replica of the same in carbon fiber, carbon composite, test it out. It would not have the life. So instead of testing the part, they are testing the tool which they are going to make in the tungsten carbide and then work with it. This could be an assembly fixture for suction. So overall, it is reducing the cost, reducing the risk, and it is giving you cheaper and faster time to market, build and grow, no limitations in geometry, less waste, and less storage space. So in brief, this is what I had to talk about in terms of applications. I have a longer presentation, but I think the time is short, and I'm not going into the technologies which we work with in terms of applications, right? I just thought that maybe EV vehicle is something which is a forthcoming, where the weight reduction, integration of part can become critical, and that is where aluminium part was replaced with plastic part, and instead of two parts, it was integrated into a single part here. We also work with copper, and in copper EV vehicle, the heat dissipation is critical. And if you look at this particular geometry, this gives you the high surface area in a small volume to be able to achieve better optimized thermal design in the limited space. You could also make the robotic welding shanks, which are again used on the shop floor. You could use tool steel to make all these fixtures of blanking tools, punch dies, trim dies, forming dies, gauges, shear blades, stamping dies, and it gives you the similar strength as would be obtained in the material which you are used to it today. You could use the tool steel for making the blades. You can use it for sheet metal dyeing, forming and trimming dies, gauges, splitting cutters, extrusion dies, tire shredders, injection screws, and tip components with similar strength as it comes in the traditional milling or CNC operation. Here you don't have to do too much of a heat treatment, but if you do the heat treatment, it further improves the strength and the rigidity. You could make the cutting tools. I just thought to illustrate the strength of the part. So if you look at it, so you could see that how the strength can be and what could be the weight reduction. Now, another example which I thought would be very relevant is that sometime you need to house the electronic in the smart system. And to do that, today there are materials which are ESD and EMI approved, with which you could actually house the PCBs so that the static charge does not get built up. You could make materials which are flame resistant, and since they are flame resistant, which is the requirement in terms of safety, and with these components you could actually illustrate and can make the components which are fully, so especially in trimming and inside, you do not want flame to catch up and at any point of time, and therefore you want to use all the trimmings and other things using the flame resistant material. There are different technologies. I think you have already got a good feel of what the technologies are. So I'm just skipping these slides. You are not so novice, you are an expert, and I don't have to show you these technologies per se. The parts can be watertight, they can be airtight, they can be isotropic in nature, so the snap fit become very effective. There is a zero wastage of the material, and the process is fairly automated. Whether any of these tools can be used for metal as well as plastic. And with that, I would like to end my presentation with the illustration that how Adroitech can partner with you in providing the solution and services to be able to meet your today's requirement. Thank you. Thank you, Shibu.
Thank you so much, sir. Thank you for your. It was a very detailed one in terms of most of the polymer-based technologies and solutions that you have shared. Uh, uh, Thank you so much for your insights and inputs. We will also be covering most of this through our platform. As you would know, we've also launched the 3D Graphy news now, and also the evening panel will also be covered. So I think it will be very interesting. So now, may I then quickly, go to the next speaker, who will also be sharing his insight on the subject on metal additive manufacturing with his expertise. So Ashwin, you can start your presentation.
Okay, thank you, Shibu, and thank you, everyone. It was a good session so far, and from this, I'm Ashwin Deshpande from Intech Additive. I will be taking you through some of our solutions and couple of case studies, and yeah. So, introduction about Intech. We were India's first metal 3D printer service bureau, established in 2012, recognized by Bowlers Associates, one of the leading consulting company who tracks the additive manufacturing space. From there, we went ahead and launched our Design for Additive Manufacturing Consulting Services, which we have discussed in this today's forum, that how DFM is extremely critical for a successful implementation of additive manufacturing in the for various types of applications. Then in 2018, we launched our first software for parameter optimization called AM Optimate, first of its kind in the world. That probably piqued the interest of DMG Mori, and DMG Mori is an investor in our company, a minority investor. And then in 2019-20, the pandemic year, we launched India's first laser powder bed fusion machine, a small format machine, and with our own software, that is AM Builder. So we not only design our own machines, but we also develop our own softwares. Truly in the spirit of Atmanirbharta, where we would like to bring as much, increase the local content of our offerings. Today, our systems are class 1 with over 70% indigenized components.
Ashwin, sorry, your slides in between, they're actually shading. I mean, we are missing it. Is there a lag?
Can you?
Yeah, now it is.
No, I'm on one slide only right now.
Okay, you're on one slide, but no, in between it has gone to a black shade. But nevertheless, now it is okay. Please continue.
Okay, so yeah, the aim is to increase the local content as we go forward and become a 100% indigenized company. Today we are over 70%, and with the software being 100% indigenized. In 2021, the highest number of machines were sold in India that came from Intech, and that's a proud moment. And we also got two of our machines in Europe. And in 2022, lots of softwares and new materials are will getting launched, as well as the hardwares. Nice to see ours, we being featured in the National Strategy on Additive Manufacturing document, where the government of India showed our machines also on the cover page, along with the CMTI machine Suksh. And inside the document, our corporate was covered with certain the software that we are developing, the first of its kind and one of its kind in the world. Nice thing to be recognized. These are some of our customers today. These are I'll probably take this pointer. Yeah. So Indomim, a leading one of the world's largest metal injection molding company in the world, based out of Bangalore, uses our machine. IIT Madras, Yanapoya, doing a lot of focus work on medical applications. IIT Madras working on material development for automotive as well as other industries. Pandit Deendayal Energy University in Gandhinagar, doing a lot of work on in the energy sector for India. MRF, one of the biggest tire manufacturing companies in the world. DMG Mori incidentally also has our machine, and then we have a company called Power Jets, which is a UAV company. So, and then Conify, which is the first sale that happened in Europe, and the primary reason was the software. Of course, the hardware had to meet the international standards, and which we are, and so forth. So I'll just play a small video, and this could yeah. So this is the software that is that starts from a periodic table where a customer can create his own new alloy, and from there the software helps you get the start values for the 3D printing process, metal 3D printing process, which otherwise would take months, and dedicated machine has to be dedicated for this R&D purpose. Here this happens at a click of a button, the parameter generations and as well as the optimization. And now what you see is the pre-processing software, again indigenized, developed by us, that is called AM Builder. So this is our small format machine, a circular build plate, build envelope, offers the lowest cost per part, and loved by the industry for its compactness, for its lowest cost of ownership, very useful in R&D as well as smaller parts, but R&D in terms of new material development. I hope that was visible, that video. Yeah, this is the portfolio of Intech. We have like 4 divisions over here. A consulting division, that is the DFM division, which we give consulting services to our customers to reimagine their existing parts, redesign new parts suited for additive manufacturing, and so forth. Then we have the software division where we are developing our own indigenous softwares, the AM Automate and the AM Builder. We'll have a brief introduction later again in the slides. Then we have the hardwares. The iFusion is a brand of machines that we manufacture, and then the on-demand parts for low batch, low volume production. These are our machines. The small format over here, then the medium format, and then our large format machines. And the medium and the large format are typically positioned for production applications. Of course, small format can also be used for production application, but it is most useful for the small components and doing a lot of R&D work and so forth. So and these machines can be configured with multiple lasers, the medium format and the large format. The materials which have been qualified on our iFusion so far is what you see over here on the screen, and many more in the pipeline. And assisted by our AM Optomat software, our turnaround time for developing new materials is really very fast, and this is something which our customers have liked, appreciated that what we bring to the table, to their table. So this is that software for parameter optimization and new alloy development. Helps you in faster build rate. So there are different modules to this. You can have a productivity module or you can have an R&D module. So a productivity module is primarily aimed at helping a customer determine, let's say, a higher layer thickness as compared to currently established one. That whether I can build the part at a higher layer thickness and improve the speed of manufacturing and do more number of parts in X amount of time. So and so forth. You can also give targets of improving the surface finish to the software, and the software will accordingly churn out new parameters for the LPBF process. For the R&D module, it's about finding the start values in a matter of clicks, and I'll share one case study, not from automotive, but yes, we do have a very good case study on this for the R&D module. So this is what you see over here, just a visual appreciation that without AM Optimate, this is the kind of surface finish we got, and with AM Optimate generated parameters, 3D printing parameters, how the surface finish improved without any post-processing. No post-processing was done on this part, from 11 RA to 4 RA, and that essentially means the cost. You save a lot of cost by avoiding the post-processing steps and the time as well. So this is AM Optimate, and then we have AM Builder, the data preparation software, all the pre-processing software, which follows the standard process of taking the CAD data in different formats, generating the supports, orientation, doing distortion analysis, and then the actual path generation for the laser. So these are the two softwares currently which are available from our portfolio. I'll talk about this case study. This is from not from automotive, but is very relevant to understand that this was done for HL Bangalore. This is one of the components from the engine. It's a super alloy called CM247LC. Now this alloy has been successfully used for several years by the manufacturers through investment casting process. So that's the traditional way of doing using this material in the manufacturing process, and that is investment casting. So HL approached us, and through collaborative approach, they wanted to actually figure out parameters and print this part in CM247 in a laser powder bed fusion machine. And this is the part called gas generator nozzle guide vane. This is a published case study, and AM Optimate was used to generate the parameters quickly, actually in a matter of minutes. But then, of course, you have to do coupons and test parts, test blocks, and this all effort took about 2 weeks. Conventionally, it would anyway take between 8 to 12 months to actually come to the most optimized parameters to run this material for a certain layer thickness, for a certain laser power, and there are several more parameters that are required to successfully qualify a material, a new material, and to run on a LPBF machine. And the challenges of this material, this particular material, was it is a crack prone material, and previous attempts across the world to print the parts were not successful from a functionally for a functional prototype. A lot of research has been done in the universities, but not at the industrial application. So by virtue of developing this material, qualifying this material for LPBF, and additional applications of manufacturing, prototyping, or end-use parts have come into the ambit, and that is what is also important for the automotive sector. The more and more materials the industry can develop, industry means I'm talking on behalf of LPBF at this point of time, they can develop more and more parts can come into the ambit of additive manufacturing, and we are working towards that. Another area where we really excel since 2012, almost like 10 years now, additive manufacturing is what we eat, breathe, live, and that is what has been appreciated by a lot of our customers, that AM is in our DNA, and the DFM is an extremely important component in a successful adoption of additive manufacturing. So we have domain-specific experts, aerospace, automotive, tooling, our own in-house softwares and hardwares, various so methodologies have been set up, and so forth. Here is a case study about this is our own case study with our customer. It's the door jig assembly fixture. We have seen in the previous presentations, lots of applications are there in the production shop floor. Additive manufacturing not limited to making prototypes or low volume and production parts, but also used in the manufacturing floor for various types of jigs and fixtures. So this is the door assembly fixture. The problem statement was the conventionally fabricated machined fixture was heavy. It was not easy to handle. Lead times were, of course, more considering the conventional processes. AM solution, we went through the topology optimization and infill lattice structure as design methodologies were adopted. FEA was performed on the new design to determine the structural performance and the results that you see over here. So about 48% weight reduction. Since this is a near net shape manufacturing process, very less, very significantly, very less material is wasted. So around 70% material saving. Lead times were drastically reduced, and the customer today is using this fixture in the shop floor. This is another case study. This is a proof of concept, not at this point of time implemented, but going through testing. This is an exhaust gas recirculation system used predominantly, used in the gasoline engines or the gasoline automotives, where the traditional design is bulky. It is of course heavier in weight, and lots of manufacturing processes, typically welding, are required, which increases the chance of leakage. Of course, that is not it's not that leakage is not addressed, but yes, the chances of leakage are there. And the AM solution was, we used triple periodic minimal surfaces. What you see over here, these are the kind of specialized features which are used to improve the thermal efficiency of the EGR system through topology optimization and other means. The AM solution offered a lightweight, less in size, less in volume parts were consolidated, and we'll see the metrics of this. So what you see over here is the traditional design, and this is the new design. This is under testing. So it's a compact design. Volume was reduced by around 60%. Smaller size, weight reduced by around 70%. And that's a big boon for the automotive industry, especially as far as this part is concerned. It is for the conventional fuels. The lesser the weight, the better the mileage. Part consolidation. From a 20-part assembly, it became a 1-part. Again, it's amazing. It's a humongous benefit. So almost nil assembly operations or labor and time involved in assembly and so forth. We also have some cost metrics. These are again very approximate. Conventionally, this would cost something around, let's say, around 30,000. This could be, AM manufactured is approximately, let's say, 25,000. So again, decent cost reduction as well as time reduction and a better thermal efficiency. So the last slide, this is to Intech expertise is across the entire chain, and as I said, we eat, live, breathe additive manufacturing. And so we have this designer for additive manufacturing consulting division with all the leading softwares available with us, doing these various functions used for various feature developments and so forth, lightweighting material. So we have an in-house material characterization department, powder development. We do not manufacture the powders, but we work closely with Indian local companies, and we have already localized a few powders in India, and efforts are on to improve, to increase that portfolio of localized powder development, and again, to bring the benefits of additive manufacturing at an affordable cost as compared to foreign OEMs. All the players in India who are there as indigenous solution providers are working towards this, and Intech has been doing this for several years now. Our portfolio that we discussed, the small format, large format, and the medium format, and our softwares. Then we have a complete setup of post-processing available with us, and followed by on-demand services. So we can handhold a customer right through from the concept generation to actual putting the part in use, with all our expertise and man hours and man months and man years are available with us, and the state-of-the-art infrastructure. That was it, and I thank Dr. Shibu and 3D Graphy for having us into this discussions and in this forum.
Thank you, Ashwani. It's always a pleasure to have you to come and share some great innovation And every presentation, I can see some new innovation happening in the space that you've been doing. Especially, I think the last event was on aerospace and then the maritime. This was actually very, very specific in terms of how cost optimization, as in terms of ensuring that how cost can be reduced. It's very interesting to know. Though I don't come from the expertise in auto, I'm sure Mr. Vijay Pankhawala sir would have already taken most of the inputs from here to also have a panel discussion with most of the things to be covered eventually. I also see a great prospect for a lot of startup companies who would probably want to get into automotive as an industry, because now we're talking about lesser inventory and come up with customized solutions like Krishna also mentioned in terms of what they've been doing. So very interesting times, not looking at the big OEMs, but I think auto component manufacturing companies looking at solutions like these in additive manufacturing would be a great prospect going forward. What do you think about that, Ashwin, on a quick note?
Yeah, of course, with as our machines become faster, as I'm talking on behalf of the industry, as the technology becomes faster, as new materials get developed, additive manufacturing, metal additive manufacturing will come into go beyond the prototyping applications and go into the end use production parts, mass customization, call it, or addressing even more higher volumes, as well as the other enhancement tools, so forth. So of course, we also saw in the previous presentations from our colleague from MS about the tooling applications. Yes, these are very exciting applications, and that will make the Indian industry much more competitive. And with indigenous solutions across the tool chain, from companies like us and my colleague from MS, I think the Indian manufacturers will have access to the affordable technology, reliable technology, and an affordable technology.
Right, and also for and also for somebody, maybe an OEM, a component manufacturing kind of a setup, starting small, can also be looking at this as an option to then offer solutions with lesser inventories.
Yes, there are already several companies here in India. We being amongst them when we started in 2012, and today there are quite a few entrepreneurs, MSME companies who are looking at adding additive manufacturing to their portfolio. So along with the conventional manufacturing methods, they would like to offer additive manufacturing parts also for those relevant applications. So yes, and now with the government support, I'm sure we will see much more growth of additive manufacturing in India, which we have been lacking, honestly, compared to, of course, even compared to China, Japan, Korea, or of course, the development of the European and the American nations. But I'm sure with the government support coming in and companies like MS and Intech and several others bringing in indigenous technologies, it has to grow.
Yes, good. So I think at least now, since government has actually recognized it with this national additive manufacturing strategy, the Ministry of Electronics and Information Technology, I think there's a long way to. There's definitely an opportunity going forward, because at least the policymakers have recognized the initiative. Thank you so much, Ashwin, for your time. And I would also invite you to join the panel discussion. I think we will have greater meat of discussion in the course. And Mr. Pankhawala sir will also want to get those inputs. And we will be covering this also to the industry at large, to the auto industry at large, through the panel and also through the online piece that we've been building for time to come. Thank you so much. And it was a pleasure to have you on board, Ashwin. And now let me introduce you to Sanjeev Kumar, who is a business head with Lodestar Innovation Private Limited. Sanjeev has been a key respondent for certain technologies like metal and peak, Sanjeev, and additive. G additive has been their interest of promoting and as a reseller in the country in terms of gaining that traction for the machine. Sanjeev, over to you for your presentation.
Yeah, good evening all. So I would like to thank Mr. Shibu and 3D Graphy organization for giving us an opportunity. to discuss with all our friends and other industrialists and people here. So I'll just share the presentation now. So just we'll start the presentation now. This just to discuss on 3D printing and visualization of technology innovation for automotive sector. So it's a brief, small brief on our company. Like Lodestar Innovation is a decade-old company. We are creating a 360-degree ecosystem for 3D printing. So our aim is to take this AM facility to existing Indian manufacturing industry, so make it easily accessible and affordable. So AM has a potential to add values to end user, manufacturer, and distributor, and still. So these are our few core strengths as a company. Since a decade, we are in the industry, so engaged in providing professional production and application-based 3D printing solutions. And our promoters and our directors are having very good experience of more than 2 decades, working with global OEMs and MNC companies. And we have a highly experienced support staff and highly trained engineers to support the customers post and pre-sales technical support. And our dedicated sales team focus on extending consulting-based sales, not as a box selling approach. So we mostly like work as a system integrator to provide a better solution to the clients. And we have a headquarters in Bangalore, and Delhi, Mumbai, we have engineers, certified engineers. So since morning we have been discussing many points. Sorry if I've been repeating the same. So these are all the few points where additive manufacturing applications for auto and manufacturing industries. These are the main points where we have to look around. Even other team members and other speaker also shared the same thing. Foremost is rapid prototyping during R&D, which helps the company to reduce the cost as well as even time, reduce the timing to make many iterations. So this is one of the main points we are discussing here. And next is come to weight reduction. So nowadays now we are into electric vehicle era. So when we're talking about vehicles and automotive industries, mostly the weight reduction is the main factor for fuel efficiency and for the easy accessibility. So AM is helping a lot, a vital role to create a hollow pattern and other weight reducing tactics like DFAM and all. And next it comes to customization. When you're talking about streamlining customization, this is one of the most popular trends in automotive. Not only for the existing or aftermarket vehicle, it is for the new vehicles and new design, a new vehicle design also. So AM, additive manufacturing, makes more easier and cost effective for the customization process. And for manufacturing replacement parts, this is the most promising application, you can say it in automobile industries. Like many people are working on service providers for the olden designs of cars and vehicles, where finding difficulties to maintain the stock of the parts or maybe inventory. So now we are also working with a few people who are the automobile companies or automobile dealers who are into designing and customization of replacement parts and serviceable parts. So we are also offering them AM, additive manufacturing solution, to make it so possible and even cost effective. So even customers as well as service providers both are beneficial in this process. So some of the benefits faster turnaround on prototypes and low volume parts. So due to minimal setup compared to other conventional methods, the AM provides a faster turnaround on prototypes and short run low volume parts than a traditional manufacturing. And when we talk about additive manufacturing, the key fact is less wasted materials. As the name states, additive manufacturing, we just add the material when and where is required. So compared to conventional method, obviously this will help us to overcome all the wastage of the materials. And the support structure, by using effective softwares and optimized softwares, So we can reduce the support materials. Still, that also help us to reduce the material wastage, and it's like a very minimal or negligible percentage in overall process. That in other way, it will help us to reduce the cost of the material also. And when we compare to a conventional method, again, the additive manufacturing process is using very less energy intensively. So over the period of time, definitely it will make an impact in an energy cost. Then less need of inventory. Obviously, additive manufacturing is like creative replacement parts and tooling. So facilities require very less inventory space, and you can easily manage to keep those items on hand. So additive manufacturing helps us to reduce the overheads and ongoing resource cost by using the this technology, this process. So overall, all the above factors can result in cost saving, time saving, and highly productive process of additive manufacturing in any industries, especially automotive. So now we are just going to a few things, like along with our offering, what are the application advantages we can have with every technology of this 3D printing, like metal, SLA, SLS and all. So we are offering the widest range of metrology scanners and 3D printing solutions from SLA, SLS, EBM, metal, DLP and FDM. These are the few OEMs we have been partnered with in India as their resellers for many technologies of 3D printers and scanners. So the main thing is like Arcam, additive Arcam, EBM, a GE company. So they are having EBM metal 3D printers, which is which has been proven technology for aerospace and healthcare and implants applications. Then here comes E Plus Shining 3D. One of the major partnership with these people, E Plus Shining 3D. We're having the most number of SLA printers, industrial grade printers installed in India. So they have SLA, SLS, and wax and sand printing, and metal printer also. And there is a company called TPM 3D that uses high temperature SLS printers for peak powders and PA materials. And FS Zettel is a company, they are making the sand printers for casting industries. Where it comes to professional grade 3D printers, we have been partnered with Intamsys and Sharbot. So Intamsys is the company who are the global leader of high temperature and high performance FDM printer for peak and ultra materials. Then we have been tied with Materialize and Amphion core line software for various software support of additive manufacturing process, like build preparation, metal simulation, and medical modeling. And here it comes the industrial grade metrology 3D scanners from Shining 3D. So we are offering free scan series, laser scanners, and Optim scan series, like a structured blue light scanners. And talking about consumables, we have been partnered with earlier known called DSM Somos. Now it's called Covestro company from Netherlands, and Shining 3D resins. These all are proven resins and proven materials for the polymer 3D printers, like resins and other powders in the industries. So we will just talk about a brief about every partners of us and what is the application advantage in the forthcoming slides. GE Additive Arcam is the pioneer company making the superior technology called electron beam melting technology. These are the proven technology, or this company is proven leader in a cost-effective AM solution for the production of orthopedic implants and aerospace components. So these machines doesn't require any post-heating process or wire cutting machines literally. So it's all completely a production grade machine. And only in this machine, we can have a option of stacking on the Z direction, nesting option on the Z direction in the metal printer. So it will be helpful for the production grade implants, and aerospace parts can be produced in this. So these are all the machine lined up in GE Additive, Arcam EBM, Q10 Plus, Spectra L and H. So Q10 Plus is the machine which is exclusively for ortho implants. Have been installed, few machines have been installed in India with 200 by 180 mm bed size. And other two models, Spectra L and H, are broader and bigger machines which will be used for aerospace and industrial 3D printing using titanium and cobalt chrome powders. And these machines are using electron beam of 3000 wattage to 6000 watts to make the parts. And E Plus is a company like E Plus Shining 3D or the partners company. The founder in 2004. They are mostly focusing on integrated 3D digitizing technology solution. More than 60% of their employees are in R&D team. So they have they are producing a very rugged and workhorse kind of machines, metal, SLA, and SLS, all these three technologies. And it's an ISO company. Based on their material handling capacity, there are three categories of printer they offer. Plastic, we have SLA and SLS, and casting 3D printers, like by using SLS technology, wax and sand, and we do have metal printer also. So these are the few glimpses of models available, and as I already mentioned you, we have more number of SLA technology machines installed in the market. In all industries, starting from automobile, service providers, and medical healthcare applications. So start from EPA 350, the bed size of 350, 350. We have even 800 by 800 by 450, the bigger machines, which is all completely open source machines, parametric as well as material based. And these are all the like rugged machines running in the field for almost 6 to 7 years now. So these are the metal printers solution from E Plus Shining. Starts from 150 mm cube to it goes up to 650 by 650 by 800. We have various range of metal printers. Again, it is an open source machine, and we can easily customize the parameters as well as we can use the open source powders. And these are the casting, wax and sand 3D printers using SLS technology. There are a couple of models available with various bed size and various applications. So these are the application benefits of few technologies like a metal 3D printer. So already we have discussed a lot about applications and parts. So here we can see have the core engine components of aluminum, stainless steel materials can be directly printed or supported in the metal 3D printer. And you can see the service parts in AL, SS material and other materials possibly by any metal 3D printer. And on the left, you can see a lot of automobile components are nowadays making by using AM additive manufacturing process. So these are the few live examples or maybe application proven application segments of SLA printers. So plastic components by using by using SLA technology, we can either print the prototype models or a pattern for vacuum casting process like dashboards and bumpers and lighting solutions, either using prototypes or VC patterns by using SLA technology. And we have many kind of resins available in market now, starting from ABS, PP, clear, and high temperature resins and all. So these are the parts are produced by using SLA printers, R&D parts, prototype parts, and SLA printed air vents for testing as well as VC vacuum casting patterns. These are the few special application oriented parts produced by wax and sand SLS printer. On the top you can see polystyrene based wax dipped parts for investment casting patterns. So directly a SLS printer by using polystyrene powder which prints the parts, and later it will be dipped in a wax investment castable wax material. Then directly it will be going for investment casting patterns. So this is a special machine from E Plus Shining 3D to make wax and sand SLS printer. Same way the sand printer, by using binder jet technology, the SLS technology will cure the layers. Directly you can print the core cavity for a short run or a low volume production. So these are the offering from E Plus Shining 3D in different technologies, SLA, metal and SLS. Here, when we're talking about additive manufacturing and cost effective and other factors, so there is one more factor is like we'll be talking about reverse engineering process. So Shining 3D is offer laser scanner and blue light scanner for the application of reverse engineering as well as inspection of additive manufacturing products. So this is a very important tool or aspect, mostly majorly used in automobile and other engineering industries, where you can just reverse engineering, or you can just scan a part and redesign it by using a designing software and reverse engineering software, and you can recreate a part with some modification or changes. Same way, scanners are useful for making an inspection of our either additive manufacture parts or maybe conventional production part, compare with the CAD drawing or the scan drawing. So this is one of the major application we are seeing in a practical like scenario. There is a company, FS General. They are the leading manufacturer of sand molding 3D printing technology. So they introduced a technology called PCM technology, which is nothing but patternless casting manufacturing based on the binding jet technology. So this company, like we are offering 4 different models. So the bigger one is PCM 2200. You can see the bed size of 2200 by 1000 by 800 mm. So this is the fastest printer in its class, and it works with the normal foundry sand, and they are working on new sand and used sand mode also. So some of the machines are offering we can mix with the new sand as well as old used sand to reduce the cost. And we have a direct support team available in India to support all those machines for post-sales technical support. So these are the application benefits of patternless sand printing by using binder jet technology. You can see the sand core and cavity directly can be printed, or maybe sand casting patterns can be printed in larger volumes, or even for smaller parts in a low volume production, we can directly use this printer for printing instead of going for the sand casting conventional methods. So there is a company, one of our partners, TPM 3D. They are like more than 20 years in R&D in SLS technology. This is the first Asian company to develop SLS 3D printer in 2008. So they are having a high temperature SLS technology printer for the peak powder printing capability of medical applications. Even implants can be printed directly in the SLS technology by using peak powders. So a couple of customers are using these machines for their R&D in implants and production part also. So later stage, they have been joint venture with the Stratasys to promote SLS technology. They also got a CE certification and other patents for supporting the healthcare and implants applications. So these are the few offerings from those company, from OEM, starting from 260 by 260 by 400. We have a bigger machine for 550 by 550 by 600 mm. So these machines are working under high temperature SLS technology, as I already mentioned, for PEEK and other plastic materials. So these are the few parts created by PA12 industrial grade nylon material by using TPM machines. And Intamsys is one of the major partners of us. Like they are producing the FDM technology printer for high performance and high temperature material like PEEK and Ultem. So they are the global leaders. Their presence is everywhere in Asia, European and US countries for industrial and institutions for R&D of medical implants and medical applications by using PEEK, PEKK, Ultem materials. So they have a couple of offerings like 410 and 610 machines with a large build volume. And recently, Porsche Automobile has invested in Intamsys being a partner to create an advanced automotive digital manufacturing strategy to produce prototypes and in-house parts and all. So this is one of the good partners of us. So we have a very good installation in India to support the medical and implant R&D segments and applications. So these are the few of the engineering and medical components printed in peak and ultim high temperature parts. Along with that, we have been partnered with software solutions like Materials Magics for data preparation software, which works under SLA, SLS, DMLS, and EBM technologies. And there is a company called Amphion, who are also having metal simulation software for powder bed fusion technology. And we have been partnered with Coreline. They are having medical modeling software, which is CE and FDA certified solutions. So this is a short presentation on our offering to the industry, along with some practical application advantages. So thank you for giving us an opportunity. Thank you, Shibu sir.
Thank you, Sanjeev. Thanks for that presentation and detailing out in terms of what Lodestar has in the offering, and more importantly, like a solution provider rather than machine sales. So thank you for that inputs. And may I now introduce, ladies and gentlemen, to you, Mr. Santosh Nagarjuna. He's a technical specialist in the software space, Hexagon solution, that is also MSc software. So I think we had a mixed blend of various metal solutions, polymer software solutions. Starting in the morning, we had Rafiq speak on ANSYS solutions when it comes to simulation and how it can help. And then we had Materialize, and then also Altair, and now Hexagon. I'm sure everybody has its own expertise and something to offer the additive manufacturing space. So thank you so much, Santosh, for your time, and we'll start your presentation. Thank you so much.
Yeah, thanks. So thanks, Shibu, for an opportunity. So today, I'm glad to share my experience. So I more than talking on the products, I will be more focused towards solutions. So how we can help industry in terms of adapting end-to-end solution for industrial additive manufacturing. So I'm Santosh Nagaraju. So good evening to everyone. So I'm a technical specialist, so that you will see a lot of technical related slides in my presentation. So I have decade of experience. So I was working in advanced manufacturing processes. So from 2018, my focus is purely on additive manufacturing processes. So I have worked with the major OEMs. I worked with the Service Bureau in India and Indo-Pac, and I have also worked with educational institutes in India, Singapore, and Australia to implement the end-to-end additive manufacturing solution. So I will be majorly focusing on design, printing, and quality aspects, and so and how do we ensure? So when I say additive manufacturing, it is not only we will be focusing on design and engineering part, or manufacturing of it, or quality aspect of it. So we are addressing starting from the material to the quality of a 3D printed component. So let's start with the company overview. So Hexagon is a Swedish company. So it has spread over 50 plus countries with a 20k plus employees. So Hexagon has been growing from last I can say decade with a 2% of or 2 digits of growth, and we invest almost 12% in the R&D. So now MSc, so you might have heard MSc software is part of Hexagon now. So Hexagon majorly focuses on digital and software solution, also on the industry 4.0 or more of automation related solution. So what are the different solutions we have? So we are not just a software company. So we have 3 different categories. Like one is design and engineering. So where MSc software comes into the picture. So we have software for structural optimization, multi-body dynamics, and we have software for acoustic manufacturing process simulation, material modeling. Then we have software for production software, where we talk about conventional manufacturing process, and we have a metrology where we help customer to use the technology like scanner for the reverse engineering and re-engineering process. So we have more than 12 brands within Hexagon. So this is I can call it one of the few company where they have hardware and software together under the same roof. So even we have been working with the global companies where we are supporting them from the software and hardware point of view, even from the industry 4.0, where it is majorly focused on integrating a physical and digital world. So let's look at how we stand when it comes to the market. So if you've look at the aerospace industry, so we have reached 90% of aerospace company from our software and hardware solutions. So even in fact we have a couple of softwares like Nastron, MSc Nastron, which is known as NASA Structural Code for Space Application. So which is certified to use, or one of the few software which is certified to use in aerospace. And when it comes to automotive, so we have reached 95% of customer from our different offerings. So, and we have solutions like Adams, which is well known for multi-body dynamics. And when it comes to the smartphone manufacturing, so even we have a hallmark kind of things where the smartphone manufacturer suggests their supplier to use particular set of scanner or particular set of software for their product line. So this is where we stand. And when it comes to quality, so we proudly say that we are the quality driven company. So let's look at what is our offering when it comes to the additive manufacturing. So I have been working with many industry, like starting from the supplier or service bureau, so where we are majorly supporting and design or manufacturing point of it, then OEM, and then educational institutes where we have a lot of tie-up with RMIT University, A-Star, IIT, and IISc. So when we start with any additive manufacturing, so it will be either of re-engineering or reverse engineering process. So when it comes to re-engineering, so we always start with the initial design. So where we have the part design, then we work with material selection. So then we go for a process related or process simulation software, because here we have a lot of challenges. No, it's not always true that whatever optimized design, it can be easily printed. So we have n number of optimization tool even with Hexagon, but not all the design we get, it can be easily printed. So there are a lot of challenges, or it has its own challenges when it comes to printability of a component. Then comes the post processing or planning. So where once we are able to print, so what are the post operation, like if we have machining of a 3D printed component, so all of this can be studied in a virtual environment using design and engineering. So this is majorly focused on the OEMs, because I won't call it as this is much useful or much adopted by service bureau, because they will not have any control on the design aspect. So then comes the production. So where we majorly talk about a part printability, orientation, support structure. In fact, we have partnership with many leaders in the market, as well as you can name any machines available in the market. So our solution fits for those environments. So when it comes to production, so we have a software which we call it as virtual 3D printing machine. So whatever you do it on the shop floor can be simulated, and you can go for a printing right at first time. So quality inspection. So we are leader when it comes to the scanner or even the 3D visualization software. So you can get the scan data. So you can either use Hexagon scanner or any of the scanner available in the market. Then you can take those scan data for a 3D visualization, and you can have the complete pictures, or if you're printing the internal cooling channels, or any if you want to understand the density related issues or powder stuck inside the coolant, all of this can be done with our quality inspection. So top of it, we also do the service life or durability analysis with the tools available with us. So we are not only as I always repeating, so we are not only focused on one particular part of the AM process. So we are there from starting from the material selection to the service life of a 3D printed component, from the digital world as well as from the physical world. So where we can do the reverse engineering starting from the scanning of it. So top of it, we have a customer, so where they are more working on the DOE or statistical analysis, where our tools can be fit into it. So it is not always true that we use the same set of parameter our material. So all of this DOE study and a lot of new techniques can be adopted for your existing 3D printing model. So you might be working already with couple of simulation tool, but when it comes to DOE run, so we have an algorithm where with the minimum run you can optimize your best design and you can optimize your best orientation, so that you will not be wasting much time and cost for any 3D printing. So also this is a kind of smart factory solution. So we have with Hexagon, so where we will customize because we have a lot of OEM. So in fact, you can name any OEM, like so where they are more towards to the customization based on their requirement. So in fact, we are working with government, US Defense and Australian Navy, many in India. So where no, because when I say India, there are a lot of R&D setup where I am personally working with. So they have multiple branches throughout the globe. So they want to have this single or cloud-based solution. So where we are actually configuring based on the different solutions. So it need not to be our own solution. So we are configuring on the different solution available in the market. So this majorly gives the flexibility. So what we do when it comes to design for engineering, so we have developed our own tool called Apex Generative Design, because we had Nastran, so that is more of structural optimization. So when it comes to additive manufacturing, it completely has a different manufacturing principles. So we cannot really use the structural or a different kind of algorithm into the additive manufacturing. So this majorly focus like AM algorithm, like what is the minimum angle thickness and the overhangs, which has to be considered during optimization stage, so that whatever design we optimize, so that suits for additive manufacturing. So we are optimizing, focusing the additive manufacturing instead of the regular structural optimization or any other optimization algorithm we have. So then it also has a lot of new feature like a narrow AI, so that the iteration so can be easily reduced and there is no geometry cleaning or machine required. So all of these were optimized with advanced techniques and tools available with us. So what we do when it comes to the actual printing, so this is a kind of as I said, virtual 3D printing machine. So whatever happens inside the machine can be simulated and can be understood from the layer by layer point of view. So our objective when it comes to the manufacturing, one is part printability with a given set of parameters. The second one is manufacturing risk. So this is where we have a major challenge. It might be recoated blade connect, shrink line, crack, delamination. So all of this. Then optimization. So which is the best orientation? I have a design, so it might be from any tool. So I have a design optimized. So which is the best orientation to print? So what are the best support structure? So all of this can be optimized with our tool. So then if you want to do further analysis, like what will be the durability considering the manufacturing effect, like stress or residual stresses, distortion. So this gives a complete picture. So before I go for actual print, so I will analysis from the part printability point of view, manufacturing point of view, optimization point of view, and part performance point of view, like considering the post-build parameter. So that when I'm going to print physically, I will be printing right at first time. But same time, I would like to say that. So when it comes to the accuracy, so we also have developed a couple of coupons, because we have a number of machines in the market. So we cannot always look for the ideal condition. All machine will be in the same condition. So we have a coupon method or calibration method where we can bring the software to the correct condition of machine, so that our results are output will be very accurate. Same time, we can estimate the cost of each component, even how much cost is reduced when you optimize. All of this can be estimated from the software. So if you are into the polymer 3D printing, so we can support you from the optimization point of view, material engineering point of view, then process simulation, and part performance is our DNA. So where we can use Nastran or CAE fatigue for the part performance analysis, as well as we have the part inspection tools from the Hexagon, where we can actually scan the existing part and get the deviation. So this is a reverse engineering case. So we have worked with one of the truck manufacturers. Sorry, I'm not using any customer names. So the moment I say who are they, so you might be having those cases. So this actual component we got it. So this is the CNC or this one is a conventionally manufactured one, and this is a 3D printed one. So we keep all of this in most of our physical events, so where people can really feel the 3D printing capability. If you look at these two, so it almost has similar kind of surface finish. In fact, there are questions like when it comes to strength. But so this is a kind of reverse engineering process, starting from scanning of a component, then AM process simulation, printing of it. So it can be any machine. So I'm not going to name any particular machine because I am work with everyone. And this is a kind of how additive manufacturing can be adopted for reverse engineering process, and how we can help them to set up reverse engineering process or labs where they can use the multiple tools. So this is on the re-engineering aspect. So when I say re-engineering, so you might have seen a lot of example from the other presenters, like where we start with the initial design. So this was done because if I say technically, so the lighter the wheel, so we get better cornering efficiency. So as lighter the wheel, so it's easy to drive, or it has the better cornering efficiency that makes better performance of the car. So this is one example, where we started with understanding the critical load coming to the wheels. So then we have made a design and non-design space. Then from that, we did the optimization of it. Then we have done process simulation. So considering the effect of process simulation, we applied the same boundary condition and analyzed that which design is best. So when I say optimization, we end up with multiple design candidates. So which one is the best? So which one should I go with? So this is a kind of validation we can do. Then we have printed it. So we are not stopped at printing of it. We did the scanning of it. So we have done scanning for the dimensional accuracy, as well as CT scanning for the quality aspect, like to understand the internal dimension density related issue. So this is a kind of end-to-end support we are providing to the customer. So what it majorly helps, so when I talk about any new product development, so there are two phases. One is technical evaluation and commercial evaluation. So when we have this end-to-end kind of analysis, so we can clearly estimate, so what are the designs from feasible from the technical point of view, considering the manufacturability, durability, then design aspects. So then when it comes to commercial, so we can estimate the cost of each component, and we can select one of the best design which satisfies from the technical and commercial point of view. So these are the example of actual printed and implemented cases. So this how we use the scanner, I can say it. So we have a very unique range of scanner. So starting from measuring a very nanoparticles, or we can go till 20 micron accuracy, to we can even measure the big ship, or even we can measure the flight. So we have a range of scanners starting from microns to the a larger level. So we have a couple of scanners. So absolute arm scanner, it was most used when it comes to the reverse engineering or measuring of 3D printed component. So these are the other examples. So where we have used the different set of scanner when it comes to re-engineering, reverse engineering. So this complete body shape was scanned, then it was used for to understand the manufacturability or quality of it. So let's go in detail into one quick case study. So then, so this explains what are the steps required. So when it comes to successful implementation of any 3D printing technology, whether it is reverse engineering or re-engineering. So we always start with, we start with generative design. So then we go for a part performance. So where the manufacturing effect were not considered. So then we go for AM process simulation. Then it goes for print job preparation. So we can use any, or we can use our own tool or many open software available or any competitors tools for this. Then we have MES, then it goes for actual printing, then we can have the data capture from that. So once we have data capture, so then we can take those back into the system for the quality and inspection point of view, like whether the printed part is in line with the initial design and what are the deviations. From that we can define if there is any post-processing operation. So all of this different operations can be done with Hexagon solutions we have. So it's a single platform, so we have developed, so you can integrate or you can use our tool, and it has a more flexibility. Also we have tie up with many softwares and machine manufacturers, so it is quite flexible. So we always open to the technology, so you either go with us, or if you have any existing solution, so it can be integrated with our solutions. So I will quickly go through the a video where how this whole process was done. So initially we have taken the design, so then we have done topology optimization, or we call it as lightweighting of it. So the greater advantage here, so when we do use Nastran or any other tool, so we do the topology optimization, then it required a lot of manual effort to clean the geometry, then do the CAD editing, but it directly gives you the file format, so you can just define you want results in STL file format or step file format. It does the automatic cleaning and meshing, so then you will get the direct results in the required file format. So that saves a lot of manual effort to the user. So once it was done, so then we have taken that into Nastran for the structural stability. So once it's validated, so then we are taken into other platform where we wanted to try with both metal and polymer material. So with a different machine and printing environment. So this with the polymer material. So then, so it clearly gives us the idea of how the part can be, how the part is getting built inside the machine. So what are the defect, and we can work on optimization of it. So this is on the metal printing side. So this is more like a virtual machine. So where whatever you do it on the machine, so it has the same platform, like you can do the different orientation, support, optimization. So even in fact we have a partnership with Materializer. If you want to access Materialize support, so it is allowed from our platform. So this from the AM printability part of view. So this gives an idea whether the design can be printed, or we can validate the design for additive manufacturing. So post printing, maybe this is quite important. So if you have any post printed data, so we can use our scanner to scan, which can go till 20 micron. Then we take those scan data back into the system. So then we do the actual understanding of where are the deviations. So based on those deviations, so you can give further if you have any machining allowances, control those deviations using machining. So it generates the G code where you can control those deviations using post 3D printed operation. So this is the kind of platform we have for the additive manufacturing process. So here, so when it comes to machine again, so we are not using any reference machine, but it works with any of the machine, because in the background it is G code and M code. So we will not see any challenge when it comes to adapting to different environment and different machine. Yeah. So this is operations on post 3D printed part. So this again one of the case study with a global car manufacturer. So they wanted to do the light weighting with us for one of the light hinge. So this is it's a part of bonnet. So when someone falls on the bonnet, it should lift automatically, so that damage to the pedestrian will be avoided. So same time, it's also quality criteria. So we had a lot of challenges when it comes to bringing those distortion within the dimension accuracy, but we have tried with a different orientation, support structure. Then finally we could able to bring it back under required dimension and quality aspects. So then it is successfully implemented. And we have a lot of case studies similar to this where we have done lightweighting and optimization of process. So this is recently we have worked with the Manipal Hospital in Bangalore for one of the tumor patient. So where uh, we have acquired the CT scan data. So it depends on what kind of analysis. It's not always required MRI because we're not working on tissues. So CT scan data. So then we have done some design optimization, like where are the worn out bones. For that we generated an implant. Then it was simulated, like which is a best orientation to print implant. What was the support structure? All of this was done. Then we have done durability analysis. Then actual implant was printed. Then we scanned it for the dimensional accuracy, as well as we have done CT scanning. All of this exercise was done in just 6 weeks of time. So this operation is successful, and so this is one of the first when it comes to printing of this implant, because we had a lot of challenges from the certification point of view and getting the manufacturer, but somehow we managed to get it done within the 6 weeks of time, because it's one of the cancer or tumor patient. So if we wait for more than 2 months, the design used to change, in the sense cancer used to grow and we used to do the redesigning of implant. So we have could able to done it with our single platform. So these are the case study published by our customer like Saffron, BAE Systems, so where Simufact has become part of their process flow. Before they go for any printing, they will simulate and understand how the part is behaving, what are the optimization we can do. So this with the service bureau. So I am personally working with many service bureau in India. This with the Bosch system in Bangalore, and recently I could see a lot of demand from the tire manufacturer. So where they want to, build the mold or the tire mold for the quick validation of their new tire design. Unfortunately, I cannot put those images. These are from some open references. So we are working with the tire manufacturer for their mold design, or getting it printed easily. So these are the few customer references. So you can visit our references for the more details. And also we continuously conduct the training, and we publish a lot of case study e-learnings on generative design and additive manufacturing, as well as since uh, 2019. So we have not done physical events. Otherwise, we used to call our global expert to train the AM industries in India on what is adopting the new technology in the AM market. So this is our end-to-end solution or lab, we call it as AM lab, where we are implementing with the government or major OEM. So this is one of the example of how the complete setup can be done, starting from D&D tools, then manufacturing of it, quality aspect of it, then rest of the post processing can be also integrated here. So before I close, so I will quickly play a video, so where you can clearly see how volume graphics. So when it comes to additive manufacturing, so most of people thought that it's single process. So it has multiple stages, starting from generative design, process optimization, material selection, build preparation to the scanning. So what I majorly suggest here, so there are a lot of advanced techniques available, because to make or to for the easy adaptability of 3D printing. So let's go directly into how CT scanning will be done on the component, and where I can go into the visualization. Yeah. So this is how the CT scan data can be visualized. That's our CT scanner. If you can bring any scan data into software, then you can usually visualize where are the deviations. Then top of it, you can give your post processing of 3D printed components. So this is a capturing of when it comes to capturing of part quality. So there are multiple options, like we have blue light scanner, red light scanner, and if you want to go with a different set of detailed features, then we have different set of scanner where the accuracy of scanning can be improved. So this is on the 3D visualization software. So it might be CT scan data or it might be regular scanning data. So it can be bring it into volume graphics platform. So where you will really understand the density difference, the internal dimensions. So yeah, so with this, so I will end my presentation. So with Hexagon, so we ensure as designed, as manufactured, as measured. So we are ensuring the quality of an component. With this, thank you very much. Maybe if you have any questions, so time for Q&A. Over to you, Shivu.
Excellent presentation, Santosh. I think it gave a clear a preview of an end-to-end in terms of where you might want to analyze the client and his requirement, and then want to cater to his solutions based on the requirement. So machine has never been a challenge. I mean, the choice, right? As it will always be as a solution finder going forward. So when you
Sure.
said software, is it going to be very confined to only MSc, or you also are open to other softwares also when you work?
Yeah, when it comes to the manufacturing process simulation software or design software, so we have our own set of software too. So it doesn't mean that you have to always go with our software. So even our scanner can be integrated with the other solutions available in the market. So even though we have end-to-end, so I was always pitching that it can be integrated with any solution available. So we want to be more solution oriented than just selling our product. This is one of the example I think I can, which we have printed for Manipal Hospital. So which has both metal and a polymer 3D printed component in it. So polymer was printed for the feasibility or tool selection for the operation. So this is how the metal and polymer can go together.
Right. And also that becomes it also becomes like a pre-op requirement for the doctor to analyze, and then for you to then get the metal part done for the actual implant.
Exactly, you're right.
Necessarily. Fantastic. It was a very impressive, Sunush. Thank you so much for your presentation. We would like you to stay back eventually also for we have a panel discussion though. So I think we will also have a to and fro discussion. Maybe though we had a set number of members representing, I think your thought would have also been very interesting if you would have been a part. But nevertheless, I think these opportunities will keep coming. Thank you so much, Santosh, for your presence, and be around. And I will go to the next speaker now. May I now invite Kuntesh Radha Di, who is actually the business head for STPL 3D, based from Gujarat, and they have done some great work in terms of indigenously manufacturing SLA printers, and which is a resin technology, and they've been offering solutions in automotive to an extent also. So, Kuntesh, over to you. Thank you.
Am I audible to you, Shivu?
Yeah, please.
So, like STPL is like Sahajanan Technology Private Limited, and we are the one of the leading technology solution provider company and manufacturing the machines in the different segments. And today in my presentation, I will cover our introduction, current trend of the AM industry, and application and examples, and our product solutions. So that I cover in today's my presentation. So first, in Sahajanan Group, there are three companies. One is STPL, Sahajanan Technology Private Limited, which is established in 1993 with the providing solution in terms of manufacturing of the machines for diamond industry. Then we started manufacturing of stand cutting machine via using laser, and then we started sheet metal cutting machines and marking machines, and then we started 3D printing machine manufacturing. And today we are the one of the very high leading company in the laser space from the India. And we have a dedicated DSIR approved R&D center, which is already accredited by Government of India, and we have ISO certified manufacturing facility. And second company, we have a Sahajaran Medical Technology, where we are manufacturing cardiovascular stents, which is we are exporting more than 100 countries. And our third company is Sahajaran Life Sciences Private Limited, where we are manufacturing herbal medicines. And that unit is also ISO certified. And again, as I said, in STPL, we are having the 4 segments of business. One is diamond technology, medical technology, industrial laser technology, and additive manufacturing. And in terms of our global presence, we are our installation presence is more than 30 countries all over the world. In terms of like innovation trend in additive manufacturing, there are a lot of challenges and a lot of opportunities coming in the additive manufacturing, and in front of like a lot of development is going on in terms of materials and improve the quality and consistency of the parts, where post processing time is all reducing, and multi-material printing is also happening in the AIM industry. Also, in terms of sustainability, there are a lot of big players in terms of like PSU and private units. They are procuring their machine, additive manufacturing machines in their units, in R&D units. So therefore, shipping and logistics is also reducing. In terms of technology development, there are like now industry is switching over from the like FDM to SLAs, as SLA metals and high-end technologies. So this is all about like development in terms of technology. Also, mass manufacturing is also like mass manufacturing and small batch production is also running because of scanning and printing speed of the AM technology. And also as like providing some speaker about generative designs. So that is also revolutionized in terms of technology evolutions. And in terms of affordability, there are a lot of Indian players is coming in terms of like polymer machines and in terms of like metal machines. So therefore, like machine cost is also reducing by like over period of time. And also like post processing is also very in terms of like software developments. Post processing time is also reducing in also with the cost. If you talk about like purpose of 3D prints, like there are like a lot of people is printing because of proof of concept and prototypes, and by over period of time there are like in other areas 3D printing is also using by R&D teams and manufacturing levels. So these are the few datas available on the like public domain. So these are the one analysis most of the people is using AM technology for the prototyping, but over the period of time it will be change and like changing. So I not much included the content because a lot of speaker is already covered the topics very well, and therefore I included images and applications of the SLA and FDM technology in my presentation to check. Like these are the SLA printed parts in terms of like bumper, auto engine cover, one of the grill, tire grill. So these are the components now automotive industry is printing in big volume SLA machines. This is one of the example of a grill of the car. So high detail and accurate grill designs can be printed in very bigger volume of SLA printing, and with the high speed and higher quality of accuracy. That is now possible via stereolithography technology. Also, like some of the component of like car, like steering also can be printed in hollow designs. Some interior parts also can be printed in SLA printing with high detail accuracy, and also can check feasibility. This is the one of the concept model of the car that can be printed in like SLA technology. So many times the concept model is developed by the clay in earlier stage, but now it is very easy to print as actual as in design. So that can be available with the like help of SLN technology, and after processing it may be realistic, we can see. Also, actual car can be we can print with the 3D printed life size car. So that kind of components we check and print via FDM or SLA technology. This is one of the example of actual car. Also, some of the transparent part like headlamp and tail lamp also can be printed with the using of SLA technology, which is having a good accuracy and as sharp like crystal clear transparent part can be printed, and we can fit it in actual like life size car for the prototyping and concept model. Also, we can dashboard parts and gear parts also can be cover parts also can be printed with the using of SLA technology, and after post processing we can check as actual fitted in the car. So the same kind of finishing we can get it via using of SLA technology. This is one of the concept model for cycle manufacturer by using of FDM technology, ABS metals. So also can be before metal cast, we can print concept model and then check, and then we can go for the mass production. Also can gear parts also can be printed in FDM, big gear parts. One of the tire application, major tire application can be check and in terms of designs, or also we can enhance the value in terms of NPD process, because most of the ideas we cannot experiment every time, so that via using of 3D printing technology we can experiment and we can check and validate each and every idea, instead of throughout some ideas while discussion on brainstorming. So we can rapidize the process of new product development, and also can be take the all of ideas. So that is also advantage of additive manufacturing. This is one of the part of automotive. Housing component by using of lightweight and high heated temperature is required. We can use carbon fiber metals using of FDM technology. So this is also available. In terms of solutions, we have INFD models where build volume is 600 by 600 by 650, and in terms of speed, our machine can goes up to 200 seconds, and a lot of metals we are available in our machines can be printed glass fiber, fiberglass infused metals also can be printed, and support we can use PBA metals, so we can get the good surface quality because we use servo motors and ball screw system based mechatronics, so that we can get the good quality of finish in FDM technology as well. We have two technology in house. One is ADM, one is SLA technology, and we have a total 6 number of models in both the technologies. This is the, again, repeat slide. So this is our one of the SLA model video.
Creating history along the rise and shine. That's right. STPL has pioneered the art of providing automated solutions for the global diamond industry. STPL is now extending its arm towards bringing and adapting to future technologies. STPL 3D have opened their wings to pursue the path of innovation with technical finesse of 3D printing in India by bringing and developing prospects of 3D printing technology. To embrace the challenges from tomorrow, today, STPL 3D brings the leading high-tech industrial-grade additive manufacturing solution with the state-of-the-art Indomake INSL 600. Aesthetically pleasing, INSL 600 is a revolutionary stereolithography 3D printer that's designed to create highest quality parts for toughest of applications. With maximum build size of 600 by 600 by 400 millimeters, it can fulfill most industrial designs and prototyping needs at lower per unit cost. Built with aerospace-grade Z-axis module, the solid steel frame sits on a highly stable granite platform to assure high accuracy and precise finish. Equipped with a galvanometer designed by ScanLab Germany and a fast, intuitive software, Indomake INSL 600 scans fast and prints super smooth surface at high resolution with roughness as low as 0.06 millimeters. The printer is compatible with materials like ABS, clear or transparent, tough and durable, high temperature, and many more with unique characteristics along with tight tolerance, providing ease of functional prototyping and low volume manufacturing feasibility. The Industry 4.0 ready with available upgrades such as autofocus, auto material refilling, environment sensors, and remote diagnostics and control. Ideated with intelligence and fine-tuned for cost efficiency, INSL 600 unlocks the opportunity for accurate and high-productive additive manufacturing solutions for automobile, general engineering, medical, dental, R&D, architecture, rapid tooling, cast and molds, and much more. Explore beyond possibilities with STPL 3D Indomake INSL 600.
So in our INSL series, we use a dynamic laser control system. So wherever is build a part, so it's use a different power, and where it builds a support structure, it is used a different power. So that why the speed of the printing is very high, and the quality of the output is also in a much accurate way. And we also use 3 printing modes like standard, precision, and fast. So you can select the printing precision mode as per your requirements. So these are the extra advantage features we have used in our technology of SLA manufacturing. In terms of metal supports, we have 5 metals based on the requirement of the industries. So these are the metals available with us, and if this machine is open source machine, so we can use different resin as well along with these machines. And in terms of our solutions, we have as I said, 6 machines which is made in India machines, and completely we have industrial grade machines. So we have a bigger build volume and along with the speed and accuracy. So based on the requirements of industry, we can provide a solutions. We have dedicated 250 plus field engineers in our team, so we can provide a better support in terms of solutions after sales as well. So thank you very much 3D Graphy and Dr. Sibu John for providing such an opportunity to showcase products and the solution from STPL 3D. Thank you very much.
Thank you, Mr. Kapish, and a very formidable and a very sturdy machine that you have been able to manufacture and indigenously for the country. Really appreciate your effort, and
Thank you.
also for the last 4 decades that you have been in the space of engineering and tooling, and also in ensuring machining has been your core area of strength. With the one in the feather with 3D is a great achievement. And I'm also told that you are also working on peak going forward. So I
Right.
think we will also await how that going to shape up. And congratulations and wishing you all the best.
Right.
Thank you
Thank
so
you.
much, Ramesh. And I
Thank you.
think this was the length and breadth of the technologies that we could share and discuss on a platform like these for automotive industry at large.
Right.
And I think we were just trying to catch up with a time. We've somehow had a cascading effect, and that is also helped somewhat delayed in time. But nevertheless, we'll quickly go into the next panel discussion. I'm sure there'll be a lot of thoughts to be discussed, and somebody who's been in the epitome of automotive industry, Mr. Vijay Pankhawala, who will be the moderator of that session. May I invite all the key respondents to join in the panel discussion, and all the other speakers also who are still around. Please be around in the delegate section to also be a part of the discussion. And you could also raise your hand and come out on the stage to also be a part of that discussion in case if you feel so. But otherwise, there are other respondents who've been invited for the panel. So may I invite everybody to join in the next panel session for us to discuss on the future prospects of how 3D technology can be taken seriously for the automotive industry going forward. We'll also be covering the entire aspect through our coverage in 3D Graphy online news too, in a digital video version going forward. Thank you so much. Thank you so much. So, ladies and gentlemen, now we will be starting the panel discussion. It's always good to have a clear discussion of what we had gone through the day in terms of actually a learning. And it's my privilege and an honor to have Dr. Naga sir to be a part of this discussion. He was an active respondent in the morning with a keynote. So thank you so much. And also, again, it's always a pleasure to congratulate the initiative and the efforts that he's been able to make with the institution, Central Manufacturing Technology Institute, with this machine called Suksham 3D, and also Fedor Antonov, who is also going to be sharing some best practices of his efforts made in composite materials. Composite machines that is actually designed. Also, Surup Chand, who has actually been in the epitome of 3D printing technology for many years, coming with various solutions, more like a solution finder. And also Rajesh also coming with a portfolio of various different machines and technology and scanning solutions, because 3D technology is one aspect, but I think the larger gamut is to ensure that even simulation, software, scanning, all of these are part and parcel of the integrated solution. We also had a good presentation by Santosh on that aspect so earlier. And also then Sushil Mane, who is a technical director with Altair as a software company indigenously designing these simulation software, ensuring that all is taken right called for the final manufacturing in AM. And most importantly, sir, thank you so much, Vijay Pankhawala, sir, who is the director with ARAI, the Automotive Research Association of India, setting the roadmap for the automotive industry, sir. Thank you so much for your presence, and also an industry association partner with us, the 3D Graphy. Such a privilege to have a very a strong body of key respondents from the industry. Sir, over to you, sir, Vijay sir, for your since Mr. Vijay sir is the moderator of the session, I'm sure there'll be a lot of meat and discussion going forward. Thank you so much. And we will also want to cover the entire discussion in our newly designed platform, the 3D Graphy News, as an online space, which will go to very sectorially. It will also be covering the automotive and tooling industry also, and I will also be getting the guidance from Mr. Vijay sir accordingly going forward. Thank you, sir. Thank you so much. Over to you, sir.
Thank you, Dr. Shibu, for introducing the panel to the audience, and my compliments for having such a wonderful conference or workshop, as you call it, organized for the entire day. I could catch glimpses of some of the presentations, and my compliments to Dr. Naganomiya for having created the Sushma 3D. So, sir, compliments from all of us, from the wonderful audience and the wonderful panel that we have over here. It was really the way I could get the glimpses. I could find that our panel or the speakers that represented, most of them are from the additive manufacturing service providers. We have institutions represented by Dr. Naganomiya and myself, and then we have a media and the platform represented by Dr. Shibu. And then also we have, I think Sushil is also there from software and ITES, I would say. So looking at the constitution of the panel, we have quite a balance, but also we see there are some people who are not represented, or the sectors or the segments not represented. That is maybe the academia I couldn't find, maybe the government. But however, whatever the panel we have and the discussions, what has led so far, I think all the stakeholders over here know very well that 3D technology is certainly a game changer. And it's not just a game changer, it in fact is an enabler also. That is, I think, very well established by now, not just in India, but over the globe. And they all know how to exploit this technology to provide the solutions those are required. And they have been providing successfully, in fact, much better than the conventional one at in certain segments like aero or aerospace or medical. They're far better exploited over there. In automotive, however, it's a scale game, we all understand. And so far, the maturity, of course, has been to prototype manufacturing, maybe a few parts to a small volume scenario that it is able to provide, and maybe the high-end vehicles where the production size itself is very low, then it is able to provide a good solution over there. Now, this is expected to progress, and we all know how well it is progressing. But having seen into that, the typical thing what I found in today's entire proceedings, that additive manufacturing themselves are creating the solutions and they are offering to probably the end users. I find a big gap over there where the MSME tier 1, tier 2, tier 3, the backbone of our automotive ecosystem is entirely missing. So maybe I would start first with questions, or rather pointers in that direction. So if we have to look at creating an ecosystem, like what is the existing supply chain system is there, what all that we need to do. Because I find the additive manufacturers are creating solutions, they are approaching the OE, and with the help of them, they are trying to establish the product. But somewhere the parts either has to be made in between and has to be supplied to the OE, who can then integrate and provide it. So to start with, so that is one perspective, and this I would first start with the additive manufacturing solution providers, and there I see maybe Krishna, you can give your perspective on this, and after that, Rajesh, you can take on to that. And better than we'd like to hear from you after that, how you do at European side. Over to you, Krishna. Krishna, you are not audible.
I hope I'm audible. I hope I'm audible now.
Yes, Krishna.
Okay, great. So, sir, thank you first of all for this opportunity to present my thoughts. And on behalf of Amaze Solutions, this is a very interesting aspect that I was waiting to answer about. Because sir, most of our customers that we are dealing with from the conventional point of view, they are like spread across this tier 1 supplier, tier 2 suppliers, right till the OEM. And what we have felt is that the constraint here, that tier 1, tier 2 OEMs are not able to prove out such case studies more, is because the approval has to come on the design changes, which is a very important aspect of adoption of additive manufacturing, the design changes and the enablement of the workforce. All that they will not do until unless all this approval is coming from the final OEM who has to approve the design, the end design, whom the end product is going to be sold to. And OEM takes this call based on, because they have this liberty to approve those designs. Now, if OEM starts driving this change and they start instructing with organizations like yours and various other platforms where we can illustrate how additive manufacturing can be used to make case studies, then they can drive the change, sir. So my point would be, I would focus on that the OEMs need to drive this change, because this verification, acceptance criteria, all these parts are in their hand. These cards they are having. So they have to drive these changes and tell them, okay, we will approve, you invest in this much. Your R&D, 30%, 20% of your budget of R&D should be invested in additive manufacturing for a person who is doing casting, for example. So this is my thought, sir.
Oh, noted. Thanks for giving that point. Maybe Rajesh, you can give your perspective.
I guess that was a good perspective, sir. However, we have to see that the MSME is the backbone of our industry, but we also have to see that the automotive industry is a very well structured system. It's a system it's a complete ecosystem which is already structured, and there is no gap in between to actually implement anything new with respect to additive manufacturing. What happens is now the economies of scale, it's like for volume manufacturing, and we see we in fact I have got some examples where we went to a few customers who are manufacturing some parts, components for say spark plugs. They are doing 2000 3000 those components every day. So now we say that, okay, why don't we implement additive manufacturing in that? They are saying that it's so tight, it's not possible for them to bring anything new in that unless it shows a considerable amount of savings. And again, investing into that at this point of time is basically when they are looking at this industry is in turmoil presently because of EV and few other industry coming in. They are not sure about getting into this. So they are not looking at aspects like the wastages which are happening due to machining or the different other conventional ways. But if the government subsidizes, or if we bring in subsidy or some carbon credits or something with that respect, probably we can find this technology go in. So this would be my view. So OEMs also, it's very difficult for them to implement this with the MSME because they have structured it in such a way now.
Okay. Got the point. Got the point. Yeah, Feder, we will like to hear from you. How do you do in Europe?
Yeah, thanks. First of all, I just wanted to say that I have a very important call in 15 minutes, so maybe that's the scheduled. So that's I will have to, unfortunately,
Understandable. Yeah.
quit the discussion. But the question is, I think, very interesting, and it's the problems I believe are similar in every territory, in every country, and I have quite a clear, let's say, vision on how this can be fixed. So from my point of view, there is no way, there is almost no way that established OEMs will apply additive manufacturing at scale. So that's what we see all over the world, and it's not getting through. What Rajesh just said is probably one of the solutions, is what we call golden applications, is just some application which is so good in terms of economy, first of all, and economy at scale, that it gives such a great advantage or savings that companies will ready to really change their processes and everything to fit into that. And so far, we hope that such applications will emerge, but we're still not there. What I believe could be a solution for additive manufacturing for automotive is the paradigm shift. So and as an example, I think we all heard about like the pioneers of that, local motors, who sadly vanished. But that what happens with pioneers time to time. Then there is another example which so far seems to be more successful is Arrival. And these are the companies that are talking about localized microfactories, instead of global gigafactories. And this is, I think, the opportunity for AM to really compete. But for that, I think that's the emerging companies, the new companies who offer new products, mostly EVs or like new generation of mobility. They can do that, but not the old generation ones, because they have to erase their infrastructure and build a new one, and that's not possible. So I think that the future is still bright for AM, but in automotive, but the way it's possible is actually through new companies, new ventures that will compete with the new products based on a different manufacturing model and a different manufacturing paradigm, which is microfactories.
Thank you, Faisal, for giving that perspective. I think what you said very rightly, it may not be the traditional OE, but maybe the new OEMs who are coming up, like the EV OEMs, because they change the landscape and they also accelerated the penetration of EV more than the that is coming from the traditional OEM. So the similar thing can happen with AM. I think I like that perspective very well. Rajesh also said it differently, that government subsidizing or other aspects could factor that in. Dr. Nagami, I think now you and me are institutions on one side. And when we ARAI and CMTI, so when we see such scenario happening over there, what traditionally the role of institutions could be for accelerating this process of acceptance of a new technology. So in that manner, what you think as an institutions, CMTI or ARAI can do to accelerate this adaptation?
Yeah, basically whatever the three panelists said, if I summarize that, additive manufacturing is a promising, but it is not the option or alternative as a regular manufacturing process. If you look at as an MSME perspective, if you look at an industrial setup, normally MSME, when they wanted to be a supply chain, unless this MSME is born out of as an ancillary unit of the larger OEMs, in many cases it happens that before he gets an order, he has to prove the component.
Yeah.
Many times it so happens that if I'm an MSME located in some Pune industrial area, if I go to OEM and I wanted to be enrolled as your supply chain, definitely I have to prove my components. That is no assurance about getting an order, confirm order from OEM. This is, of course, there are exception. OEMs are also build their own ancillary supply chain. That is different. But otherwise, in general, it is like this. So then, in that case, particularly the automotive components, where the requirements are usually geometrically components are very complex. Invariably, when someone has to supply the batch productions and all, so naturally, additive manufacturing is one. These MSMEs are looking to this. because the requirements are not huge. Requirements are few batches, and it can be done. But only thing is here, still this with respect to geometry and with respect to assembly feasibility, testing feasibility could be demonstrated unless the designers has taken care of the component design, which is because component design is not just functional requirement. Component design has to look into the process feasibility, that is manufacturability and all. But yes, the MSME could take the benefits to that extent that before investing a bigger investment, but at least we can able to use this additive manufacturing and produce few batches and all. If I am an MSME, I always look at that. Uh, I may not be so keen on prototyping, but I will be keen on that appropriate technology which could be able to produce the functional components so that I can meet the requirements of my probable customer. Then at the same time, as of if I look at restrict myself to India, uh, the development of the capital goods, particularly the additive manufacturing machines or the software systems, are developed elsewhere. So being an MSME definitely will not be able to. It is not affordability is the one issue, and second is unless you have a confirmed order from the OEMs, it is very difficult. That is where I think we institute like your CMT and ARI, we are already into that service. We can pitch in because these equipments, facilities could be created, institute like us, or even the tool rooms, the technology centers of under Ministry of MSME, or even in the CEFC's scheme, where the facility could be created so that MSME could use this facility until to prove the component manufacturability, acceptability with the OEM. I think that is where MSME look into this. I think that is one part.
Yeah.
The second part is yes, if I look at additive manufacturing as a alternative or regular manufacturing process in the shop floor, technologically there are a lot needs to be done. It leaves lost from the design. In the morning also I was talking the same. Uh, it is not that okay, I have an SLS machine made out of make X or Y. I can use it and produce any component what I wanted. Because a lot of things have to be there with respect to your design customization and also the process specific. Process means material specific and all. And still, this aim is not affordable. If you look at the other manufacturing processes, like we know molding, casting, die casting, and all. If you look at the scale, definitely, if it is scale requirement is in few lakhs of component, I think we can't even look. We should not look at the additive manufacturing, right? So scale of operation is the difficult. So here, what we need to do is the institute like us, R&D establishments, can able to create the facilities or create that capacity more than the facility to engineer the machines, process technology within the country. And here there are challenges. The challenge is just integrating subsystem and making a machine will not take us anywhere. We need to design the machines with first engineering fundamentals and ensuring the subsystems. It is a road is yes, journey is a long journey, but what we have to start.
Yeah.
I think that is where we need to focus on, particularly the research institutes and academic institutes, at least the top tier
Can do
academic
it.
institutes like IIT and IISc must do.
Great, great. I think you almost sounded what METI's strategy is also saying the same, that we need to collaborate and create capacities to begin with, which can then be exploited by MSMEs. But having said that, I think here one thing comes to my mind, and I remember an example how this e-learning industry had accelerated the adoption of e-learning modules. So I remember there is, I think it may still be there. There is e-learning for kids or something of that sort. ORG website is there, where all those who were in the process of creating these e-learning modules, they all contributed one each example of their application on that I would say public platform, where everybody can see that what that particular company, which are otherwise competing among themselves, how they are doing that, how they are creatively using these new technology for the very purpose of creating a new educational system for that. So likewise, what comes to my mind, maybe what Dr. Naga Hanumaya said, going forward to that, maybe the industry, the AM industry, can participate and create applications along with the MSMEs and OEs, because OEs, as we rightly established, that they themselves traditionally may not approach us. It is we have to create and show them as a AM industry. That comes to my mind. So I would like to append to what Dr. Naga Hanumiya said, that okay, creating a CFC, creating a capacity, and also along with that ensuring the subsystems, the entire supply chain for that particular capacity. Along with that, maybe the people from additive manufacturing can contribute machines, or can also undertake some of the application making. So that will enthuse the end user, both the ultimate end user, the customer, maybe in automotive, the person who use the vehicle, right from there to maybe the OE who sells these vehicles together. So that would enthuse them. That comes to my mind. I think, Fajar, you are excused. You have the meeting. So please proceed. Thank you very much. I think, Mr. Sarup, you want to add something to this?
Sir,
Yeah, please.
my experience the last 5 6 is slightly different from what has been spoken. My experience,
Yeah, please.
my experience with the MSME in OEM, more the OEM is with the MSME. In the MSME, the biggest challenge are ensuring that the quality is delivered, and both incoming as well as outgoing. To give a very quick example, when the casting is being done with a wood pattern and sand mold casting, the tolerances which are being given is reasonably high. And then the machining time which is required to be provided for each part to be machined and then supplied is also relatively high. Now, if the casting pattern and the core making becomes little more refined, which can be achieved with the 3D print, then the machining time which goes in is relatively reduced and the productivity of MSME unit becomes very high. So both in terms of productivity and his costing goes down. When he receives the casted pattern, most of the MSME also gives the casting to someone else in many cases. At that point of time, his input material also need to be checked. So the large, practically on the, you are from the ARAI and you know that practically one line manufacturing would involve right up to the MSME more than 2,000 fixtures of different types, for packing to drilling to making and everything. Now, those are something which do not require significant approval in terms of material or in terms of specifications. And depending on which MSME want to take an initiative, they are able to improve their productivity and also the turnaround time, which is what the OEM is demanding today from the MSME. So in my thought process and in my experience in the last 5 6 years, I have worked with MSME and most of my MSME units have adopted it for fixture building on the shop floor.
Point taken, sir. Point well taken. I think we don't, all of us don't have any doubt that as far as tooling and fixturing is concerned, this is one of the possible best solution that is emerging. So we are talking about getting made into the vehicles,
yes,
or the automotives. So that side, the adoption challenges that we discussed.
Yes.
How to accelerate that? So as Dr. Nagamiya said, we need to create capacities, CFCs, where these can be built. And I added to that, if the additive manufacturing companies like yours and others can contribute to that through machines, through materials, we together create applications and those applications will be seen, felt by MSMEs who will ultimately make and then supply to the OE, and OE will be happy to see these parts getting adopted. So it will become a sort of, I think, and this has to be nucleated at all possible what you say automotive hubs across the country or their supply chain center. So there is one point that emerges out of these panel discussion. Another point I would now for Sushil, I just wanted to know, you are from Altair, right? Yeah.
Yes, sir. Yes, sir.
And you are representing basically the software and simulation side of that. So as we know, simulation and software, when we start building a model, it requires a reliable material library.
Right.
Yeah. So when we say now here is it's a very difficult situation. I can see myself being an engineering postgraduate from that area, that my material properties, I actually do some testing earlier or later, and then create those coupons, test specimens, test them rigorously. That program itself can run for a long time, and then use those data and then feed that into software, and those library are used at later date. Then my validation becomes easier, things like that. Now in this case, we know material that we are producing are most of the time are proprietary as of now. Secondly, their properties vary as per the laying process, the direction of solidification if it is a metal, direction of laying if it is non-metal, etc. The anisotropy is inherent, we all know that. So as such, how this challenge is overcome?
Yeah, I agree with you. I think this definitely is a serious challenge as far as designing a structure which is going to be using a very specific material and for which you don't have those properties yet. In that scenario, what many companies are currently doing, not just in very heterogeneous kind of materials where there is use of composites, these fiber induced plastics and all that, but even in the 3D printed parts, you can actually do a very specific unit cell simulation wherein you actually build a small model of that 3D printed part, which has what we call as a representative volume element, and run these simulations at a unit scale level, trying to understand how the behavior of that material is. So this is all part of what we call as material characterization. So
Okay.
these solutions is basically going to help engineers to understand the material much better and characterize that material based on the different conditions. Now, once you characterize that material based on all the different, let's say, scenarios, you can write out a material model which can then be used in your simulation scenarios. So definitely technology is available now to address some of the concerns that we have as far as material properties are concerned. And this can be seamlessly integrated into the design and simulation platforms. Yes.
Yeah, so I understand you are basically referring to doing, when you say unit cell simulation, it is ICME technology, right?
Yeah, what we
You
call as
use the ICME to create a material model and use it. But again, the validation challenge remains. This is all again entirely done simulation or in virtual platform. But
right.
correlating that with actual build, that would be, or maybe, but I do see there is a point that at least until we have nothing, until then we can create this.
Yeah.
Then I think somebody also mentioned very rightly in the presentation later that they do a lot of DOE and then select the appropriate proper combination at the simulation level, and then create a build and do a validation. So maybe it's a reverse way what otherwise traditionally we all do. We start with the material first and then create the model for the material and then create the part out of that. Here it probably is going to happen ulta, the other way around, and the simulation happens first. It creates the entire thing and then we create the material. I think ICME is a wonderful thing, and I think this is an inherent advantage with the additive manufacturing, that is it is inherently digital now. So having said that, we have all the integration possibility with different technologies like ICME on one side at upstream, or maybe at the later stage at creating the virtual representation and making a make feel even before the parts are made. Thank you very much for that perspective. I've been wanting. Now the second thing, I think maybe we have just 10 minutes, so maybe one last point, Dr. Shivu, if you allow us to deliberate upon. That is okay. We discuss a lot, and this also correlates to why the OE are not able to adapt them. We say they have their rigorous and rigid processes of acceptance, but we have to understand that rigorous and rigid processes have come not as a bureaucratic practice, but there is a hard experience and the liabilities which they need to face. Against that, these practices of adapting a design change has emerged. So it is for nothing, not for nothing that has emerged. Now, having said that, then if they have these rigorous ways of testing validation, where some standards are available, some standard protocols are available. The protocols are available at the international standard level, national standard levels. They are available at the OE standard levels. Now, this AM, looking at that, one side the material and processes are proprietary. Now some people say they have open source. That's a good thing that is happening. But having said that, I do see a big gap of lack of standards, lack of testing protocols, and actually field trials with these parts. So in that case, how we can overcome that? So maybe again, Dr. Nakanomiya, I will like to take your guidance first, then we will throw open this question to AM team. Sir, you are muted.
Yeah, when the technologies are developed, so typically we as a researcher will always define the problem between the quoted objectives, because it cannot, research is not that you will can able to do it in one go. But at the same time, the taking this technology from the lab scale to the kind of shop floor, the application domain, is a long way to go. Yeah, in the meantime, we are always looking at, okay, we reach out to the end user and taking their feedback and continuously improve. So at least I will quote the particular additive manufacturing when this technology first patented in 1987 was rapid prototyping, that is SLA, Charles. I think it was not too late. India 91 itself, we had a machine. And even in my previous institute at CMERI, we had a machine towards 96, 97. I think 91, 92 itself, the first machine was installed in IIT Kanpur. From there until 2000, almost 7, 8, at least there was a annually huge number of at least 10 level, at least national level conferences. I think many of you must have attended. The Team Tech is the one conference being organized every year in Bangalore itself. As I was doing PhD at IIT Bombay, I used to attend these conferences.
Okay.
But that was the scope was primarily limited to using 3D printing or rapid prototyping to prototyping applications, and then taking a little further on the rapid tooling. Tooling was another option. Though there were some thoughts for their rapid manufacturing and all, but it was not. Before that, this technology went out of research institutes, because the reason was there are a lot of if and buts. Say, for example, even if I quote my this one, I was using a CMT facility as a user from my previous assignment. DMLS machine was installed in CMTI. I think that is the first metal-based additive machine installed in India. We had only two series: direct metal series 1, direct metal series 2. That was mostly the copper bronze material. Then, as a tool engineer, whenever I was looking for this DMLS machine, as far as more geometrical features, complexity is concerned, I think it was the best option to realize the mold overnight. But if I look at as a molding person or a end user, I think it was not the design. The reason was there are a lot of limitations with respect to life, and at the same time, there was nothing available, no knowledge was generated. How does this mold behaves with respect to my solidification process? or in the injection molding or in the casting process.
Got
I
it.
think, but now we to look at, there are so many options are available. Even in EOS itself offers, I think, range of series, and even these machines are also competitive, because that time as a researcher I requested my colleague here at CMTI, my friend, he was responsible, my friend. I said, let us try some material, but it was not possible because we were not ready to take this risk there. But now because of XY limitations. But yes, that now technology is evolved, and now everybody is last again for 4 5 years in India. We are looking into using 3D into your manufacturing, because the only reason is now options are available with respect to material and all. I think this is a part of, as I said, I always say it's an S curve. So technology development, we cannot look at any other alternative. This only happens when the developers and the users join together, uh, then with an intention of like taking, absorbing technology, then develop, understanding the process and understanding the applications, because end of the day it has to be used by end user. I said car is end user is any individual, but even morning I was showing a slide, so that is car I need free of cost, or I need all the features, all the scale, but there are a lot of pain involved in the manufacturing process. I think that is where we need to look into that. uh, the stakeholders, R&D technology stakeholders has to join together. If it happens, if we join together at the early stage, I think that is where the kind of lacuna in India.
Yeah.
We can wait 3 more years until it comes demonstration stage, but when it comes to this stage, I need tomorrow. That is
Yeah.
how I think we all are. I'm not blaming, but that is how the reality. I can
Oh,
wait.
very well said.
I can wait.
We don't want to spend on experimenting. We want somebody to experiment, and then we say now it's too late. Let me adapt it. Very well said. Very
So
well
that is
said.
how then people are always looking at a shortcut.
Yes,
So that shortcuts sometimes, yes, it meets the requirement, but it may not be universal. We can apply anywhere and everywhere.
yes. It
So
may not
ROI
be
is what
reliable all the time. Yes,
there is always uncertainty about the ROI.
yes. You
I
said
think
it.
that is where the cooperation matters. I think we have
Exactly.
to work together, and then naturally we can able to reach. It is true for AM. It is true for any technology.
Anything, Declan. I got it. Very well said. So I think maybe Dr. Shibu, just 2 minutes and we summarize. There are many more questions related to this, what Dr. Nagamaya said, and other aspects also. Since we do not have academia representation to make this happen, what Dr. Nagamaya said, or we discuss around this situation about how to create a supply chain, or about how to create acceptance and create the applications, and also create the technology absorption, readiness, learning of as a ecosystems as curve. But to enable this, we also need a strong educational system, which would create a basic research on one side, create the next level of skills and human manpower, which can adapt and start working onto that side. So maybe that point, now in the paucity of time, we won't get into that, but maybe actually the discussion has just begun. We can't stop it over here, but I would say this is a good starting, and we would continue discussing on these and similar other forums and take up these points. Uh, Having
Sir,
said that,
I
I would
just
like to.
want
Yes,
Sir,
yes,
I
yes,
just
please.
wanted to add
Yeah, yeah.
to
Last
these
point you can
points.
make.
All your three
Yeah,
points
yeah.
that you asked, they were very well interconnected. They just now gave us also an idea. So I just have one request, sir, that in institutions like yours and CMTI and other government institutions, they should try to intensivize the private people, the private OEMs, to outsource to make it their case studies more public, so that the repository that we are talking about, the repository that is full and that is made up of useful applications. Because when, as you told, there are many certifications, many standards. As far as I am concerned about LPBF, most of them are can be managed, sir. at least for the very well established materials, all the certification can be managed, but it takes time and cost. So it involves certain
Exactly.
investment.
Said it.
So if we give some incentive to these people who are doing this work, and they would come forward and they will deliberately expose their work, so that the MSMEs can learn from their work and they can adopt as well. So that is just what
Very
concluding.
well, very well said. So I think Shibu, a good point has come up from entire this discussion, that we create a collaborative platform where
Yes.
the additive manufacturers contribute, create applications in association with participating MSME on one side, OEs of course on other side, research institution then providing or taking up the task of validating this because it requires time. And to make this happen, we can have the academia, faculty, and students as a primary research, I would say, contributors or research scholars getting into that. So if we can create this, and here your role comes, Shibu. So here is the last question for you, and then you take it over. How you can make this happen? Over to you, Shibu.
Yeah. So thank you so much, participants and speakers. I think it was very, very detailed in terms of getting into the intricacies of what needs to be done. I also wanted to give Santosh a chance, because he's been taking care of the entire process from starting from design to then finally execution in terms of validation. So before I could actually come to my final conclusion, sir, may I
Yeah,
request
please,
you,
please.
sir?
I didn't see Santosh over there. That's why I didn't
Yeah,
ask him. I could see.
yeah, because
I asked everyone whom I could see.
yeah, Santosh, your inputs, and then
Sorry,
probably
Santosh,
I.
I kept you waiting. I didn't see you in my
No,
window. Therefore, in fact, I liked your presentation very well. You touched
Right.
upon so many aspects. In fact, the DOE in statistical method idea I borrowed from you, and congratulations to you. You understand durability and residual stresses together.
Yeah, yeah. So it started from design to the final validation. So I think it's covered every point. So good. So
And I like what you
okay.
said, creating a coupon on one side and re-engineering. So the post-build performance is as important as what Sushil also said at the beginning of the site. So both things are equally required. So you both do complement. Please, Santosh, give a perspective on the point what we discussed. Sorry that
Thanks.
I missed you.
So, thanks. So, I have been, working with the conventional and additive manufacturing. So, what is the challenge majorly I see? So, first of all, I would like to say any new technology. So, it required at least 15 to 20 years of time to adopt. Whether we take replacing cars with horse, or we talk about adopting a cell phone. So, it required some time. So, our people will wait until it become perfect. So then they, some, as rightly said, somebody want to evaluate, then they will adopt it. The another challenge when I compare with conventional and additive manufacturing, so when it comes to conventional, I will only sell the product. When it comes to additive manufacturing, I have to sell the technology as well as the product. So recently, I had one discussion. So we had a nice presentation. Then they asked us, "Okay, you give me the software, but where do I find the resource?" So there is not really much university coming up on the additive manufacturing side. So I think we have to look into that, where we create a lot of resources so that they know the additive manufacturing in depth during their academics, so that industry can easily pick them, or they will not have any shortage from the resource point of view. Cost, obviously, any the new technology is expensive, but same time it will have its own advantage. So I was many of us saying that it is not replacing the conventional process. It is a alternate process where complexity comes with free. So to go with conventional manufacturing, the complex the part, the cost will go higher. So these are the challenges. So same time, material availability. There are a lot of challenges or opportunity. I call it as, maybe we have to use the new technology and other things to make sure that this technology will be adapted in the industry. Yeah, with that, so I thank for giving me opportunity, and I really like the discussion. So most of the points like material cost, technology were already discussed. So I thank everyone.
Thank you, Santosh. Hope to catch up with you all. Over to you, Dr. Shibu. You are muted, Dr. Shibu. Dr. Shibu, you are muted.
Oh, I'm so sorry. I'm so sorry, sir. So, I'm saying, yeah. In fact, you're all experts in the domain, sir. I mean, with Dr. Naga, sir, already sharing what is expected, because he's been in that phase, starting from a researcher to then finally also knowing where the final accreditation and how it needs to be done. There are a lot of challenges, though. And especially when you have a new technology come in place, this will always be there. But I think there is also a wrong misconception in the marketplace that additive, if it is here, I think the conventional, we are here to eat away that space. No, it is not. So that's been, I know for the fact that there are key respondents whom I was also in touch with Tagma. They were actually sitting at the fence saying, if additive comes over, then I think CNC will go away. It's not possible. These are two different, they are brothers, and they are two sides of the coin working in the same space. Now, that was long back, but now I think things have opened and people have realized the importance of both the technologies. So every shop floor needs to have an additive, manufacturing unit at the same time, even CNC or vacuum casting for any other. Because now we all talk about, building buildings in 5 days, sir. You are actually now, and there are, people who are doing some good work from IT Madras, if they've actually built this. Recently, there is also, they've set up a 9 square feet house. They've printed it in 5 days. It was for MES, that is military electric services.
Engineering services, yeah.
Engineering services. And they've done some 2-3 projects also. So I'm saying additive manufacturing has a great prospect. I'm so impressed of somebody like an Amaze who's already started the initiative. We need to understand they've also got into the process of for these electric bikes. Now that is where for smaller inventories, sir, if there are MSMEs who would want to get into that space and want to see and look at that as an option and still make a business sense, which means we will actually activate more entrepreneurs in the country, coming up with innovative ways and use cases. I'm talking about even bicycles, sir. Even why not a company not competing with like a Hero. Hero has its own space in terms of what they're offering, though they are actually taking these solutions for prototyping. But I'm talking about something in metal with bicycles which can be made more the electric bicycles, making it more proactive, handy and lighter, and looking at that foldable ones. So I think wherever there can be additive tuned and consumed and absorbed, I think there's a lot of scope. There's a business case that can be built with time, and there's an opportunity. So we need to look into that. And I think, sir, with your support, ARI will also stand as one, standing body, supporting and working in confluence for research and development, various materials, and also with CMTI sir's participation and I think everybody need to come together, and the industry and the end user at the end of the day, who would want to set up these shop floor with a small unit to begin with in additive. So I think where Hexagon as an organization also can fit in terms of offering values. MAs as an organization can also come up with more machines so that they can produce more machines and get more business out for everybody to be actively involved in the value chain.
There is space for everyone.
Exactly, sir. But we need to look at a new paradigm, a new market, innovatively looking at that as a solution. But there has to be some validation process which need to be structured for additive manufacturing also going forward. And I see a new dawn, sir, with the Ministry of Electronics and Information already recognizing additive manufacturing. They're looking at 500 different products, innovative products, maybe for medical or any product. So I think that innovation space that we are getting into with additive itself is going to be very, very clearly defined. And I think if that comes from a ministry, I think there's a definite prospect going forward. So I think though later than never, it's definitely a good sign. So they have come up with this document, a white paper, sir. It was also announced. So we'd also covered that in our online publication, though not active, but now we'll also be covering a lot of these aspects. So I would invite companies like Hexagon and MAs to come up with more research and share these, and we will, as a media respondent, we will want to keep communicating it with working in confluence with all the institutions like yours and CMT to take the things forward, sir, so that we can also categorize and we can take the course forward. Thank you so much. Gentlemen, and I would want you to summarize, sir, since you are the key respondent and the moderator, and then we will we'll call up for the day. Thank you so much.
Thank you, Shibu, for your thought onto that. And as you rightly said, the national strategy for additive manufacturing has been put in by the MIT. It recognizes all these gaps very well. What we discuss is probably one of the solution what they have identified as a strategy. What we there are many more points to be discussed, but what in a nutshell we said that we as an ecosystem can create a common facility center wherein all of us can contribute in their own capacities in kind and in cash. We together can approach to the government for creating this ecosystem, and government, I'm sure, will happily. Dr. Nagamaya certainly knows that capital goods scheme and other, they have PPP funding possibilities over there. So it's not difficult as far as government. Its commitment is very clear. So government is ready. We as an ecosystem need to approach them, create this ecosystem, take the startups along with us who are going to create the possible applications, create the take the MSMEs along with that. OE will be happy to see the new solutions coming up, which they will have to adopt at later date. As somebody mentioned that example of Bajaj, the differentiation of 10% to 40% can create a change in acceptance and sales. So they certainly would be after that too, which can create. But I'm serious. Certain aspects we really didn't discuss about validation and other things, but we cursorily did mention we need to have a framework where institutions can play a role. We certainly would do that. And having said that, we can rope in the academia. So that is how we can create this. And these platform could be digitally enabled. Like Dr. Nagahanumiya certainly knows that with under MHI, we have already created similar such 5 to 6 platforms. CMTI and ARI has also contributed one platform each. So similar platforms we can create for these purpose. We can approach MIT on MHI on other side. So there are many possibilities of funding. Funding is not a problem. We know for that for sure. So let's come together and create these. And Dr. Shibu, you have the responsibility to create, I would say, a concept note out of this discussion and put it across to the panel. And maybe I would say, Dr. Nagahanumiya, you can take a lead and take these as a, and we can send as a note to respective ministries. So that could be a good starter coming out of this particular panel discussion. And that would be the best thing to happen to the panel.
Very true, sir.
Thank you. So I thank organizer, Dr. Shibu, and all the panelists for the wonderful time we had together.
Thank you, sir.
Thank you so much.
Thank you, and thank you for a good time together. And it was a great session, sir. Thank you. And have a wonderful and a pleasant weekend. So there's 2 days more to go for the weekend. But I think tomorrow is Holi. Wishing you all a Holi and good
happy Holi to all of you.
And take care. Thank you so much, sir. Take care.
Thank you, sir. Thank you.
Thank you. Take care. Bye-bye.
Thank you. Thank you, sir. Thank you, sir.